Test.
Awesome. There's no way this can go wrong.
It's happening now. It's happening now live.
Is this on
And we
Twitch
got
or
the audience
YouTube
here
or
and we
something?
got the camera, right?
Yes. Okay.
Thank you so much, Roy. If this is going out on Twitch, can we do a shout out to our subscribers and get them to slam like and subscribe? I don't know, we do that.
I don't know what it's going
that button.
Yeah.
Yeah.
Thanks for free subs.
I think
all that
that's
sort of
the
stuff.
host job.
Thank your mother.
Yeah. There we go.
Right on time.
Welcome everyone to Techorama TV. Today we're talking about architecture, not the ivory tower kind, Steve, but the real world kind that breaks, evolves, and occasionally works. With me are three people who've shaped how we all think about building modern systems. We have Sam Newman, the microservices trailblazer, although I think lots of things have been set on fire with microservices over the years. Yes.
I'm not saying nothing at this point.
We have Steve Smith, an expert on patterns, principles, and testable architectures, and Barbara Forbes, DevOps and cloud-native expert who turns architecture into running systems. Let's get started. So I want to start off with just talking about architecture today. So today, architecture does feel complicated. There's so many tools and techniques at our disposal between microservices, serverless, cloud-native AI. There's so many things going on. What does it mean to you to be an architect today? Barbara?
It's almost like a philosophical question.
You're welcome.
I mean, but how awesome is that we have so many tools to our disposal, that so many things that we can use. And it's very easy to get very lost, and especially if you don't know the tools that well and just start implementing, hoping for the best. And I find it's so much fun to just start running with the tools, but it's so necessary to think about what you're doing first and really come up with a design and know why you are choosing a specific tool. Because I keep hearing everywhere, we are using this because we have used it forever. This is what we're using everywhere, so this is why we are using the tool.
What kind of challenges do you see in communicating those sort of decisions to non-technical folks that make those decisions about which direction you actually should go?
Well, we tend to want the technical people, the non-technical people, to understand the technical perspective, but that's not the world that they live in. And one of the challenges is to be like, hey, we have a specific reason why we're choosing a tool, and these are the non-technical reasons. So these are the functional reasons why we're choosing this specific tool. And I really hate the part where it's not always the most fun tool that is the best solution.
I tend to prefer boring as well. Boring is simple.
Yeah, and it's such a shame. It would be so cool if just the most technically challenging tool is always the best, but it's not always. Sometimes we have to compromise a bit.
So what do you see as changed from building and designing architectures from 5 to 10 years ago?
Nothing. I mean, in all seriousness, I don't think the fundamentals of architecture have changed in 25 years. I think the difference is the pressure to change. I think you could get away with a bit more, being a bit more sedentary. Like the world is changing a bit more quickly. There's a bit more pressure on our customers. Society expects our software to do more. So we're being driven to change our architecture more. I think that's the biggest thing. You could get away with coming up with an architecture and living with it for 5, 10, 15, 20 years or whatever. I mean, look at the mainframes that's still running. The difference is there's now more pressure on us to change more rapidly. And like if you see what's happening with AI, for example, the pressure for us to have AI in our solutions is not coming from the technology world. It's coming from the business world. So I think that's a change in terms of a force acting on it. But I think the discipline of architecture hasn't really changed that much, which is kind of good and bad. Like it's good in as much as it means we can draw on lots of knowledge that's come before. It's also bad in that I do worry we're not maybe innovating. But also, I'm still seeing people making the same mistakes we made 30 years ago with architecture. So it's like, maybe we do need to read some books from 30 years ago. I don't know. But that's a boring thing to talk about. Let's read some books. Christ, Granddad, get back in the
Reading,
past.
really?
I know.
So we have not solved the fallacies of distributed computing yet?
No, I've simplified them from 8 to 3, but we work on it. I mean, the physics is still a thing, right?
I wanted to ask too, how do you balance teams wanting to be autonomous and making their own decisions versus trying to have some sort of standardization across the enterprise?
I'll take that one. I think it's a challenge. You want to have probably some standard platforms and things that your company is working with, so that you don't have to worry about 5 different cloud vendors that you have contracts with. And oftentimes companies find themselves in that position through acquisitions and have to somehow deal with it. But I think ideally the teams should be able to make most of their architectural decisions themselves with guidance from the enterprise architects or whatever architecture org might exist inside their company. And they maybe have a menu of options they can choose from, and they could even go off book if they have a good reason to. But the amount of risk that any given organization is going to tolerate for that will vary from, let's say, a bank to a startup.
I think that's just on that. I think that's the point that's really important, is that this idea that this is what you should standardize on, as though that's going to exist across domain and across company, is like contextual. Like it's what you decide to standardize on and what autonomy you decide to give teams should actually be underpinned by what your company or what your organization is trying to achieve, right? If you're an Amazon who doesn't mind having 25 different teams doing exactly the same thing because that's how they succeed, that's part of their corporate strategy, so therefore that kind of drives into how they think about autonomy and architecture. But I think this idea that you can just copy what a platform this other company does and use it over here, but they're different to you, they've got different drivers, different people, different skills, so I think I like that thing about how much power you give people and how much standardization you give people should be dependent on your company, your people, what you are trying to achieve.
Yeah, and one of the things that the business needs to do a good job of, and they don't always, is informing the technical team of what their priorities are. Because how you optimize for your architecture, it's always going to be trade-offs. And so it's, are we architecting, the trade-off is we want maximum scalability, or we want maximum simplicity, or we want the cheapest hosting plan, or we want maintainability. Like, those are all things that are somewhat at odds with each other, depending on what architecture you choose.
I know one thing I love about the business is that their priorities never change. They're ironclad, and we can just take them for their word all the time. Barbara, how do you navigate the sort of politics of those sort of discussions with the business when trying to balance like the technical concerns versus like immediate sort of business needs?
The challenge of the businesses, yeah. One of the important things, I think, is that we need to understand each other's language. Like technical people and business people, we put them into corners, they don't speak the same language. It's very powerful if you can be like the translator, almost. And make it into something that people understand. For example, security. It can be very hard to drive security. To be like, hey, we're going to give up on productivity because we need the security because we don't want the risks. I can tell a C-level that, but they will be like, oh, well, whatever. And what will help is I'm like, hey, here are these specific examples where this has been happening in companies, and a very powerful one, and this is how much money it cost the company.
What was that word you used again? Security? What is this?
Yeah, that secure thing, that doesn't matter. We'll be fine, right? And I like security as an example because you have to have that talk with both the C-level and with the engineers.
I know one of the things that we keep hearing so much about is like, how can we leverage AI to make ourselves more efficient? Have y'all seen any changes in that area that you've seen any AI tools make your jobs easier? Like, does it spit out the PowerPoints and Miro diagrams better?
It doesn't do Miro diagrams that I've seen, but yeah, the AI tools are effective at spitting out a lot of something, and the trick is to be able to give it enough specific context for that something to be close to what you actually want or might have done yourself. And I know many folks in the audience have used Copilot or other tools, and they can make you feel very productive, but if you don't have the context just right, a lot of the time is spent where it gives you something, it's not right, you tell it it's not right, it says, oh, you're absolutely right, that was wrong, here, let me try again. And you can be in that cycle for half an hour sometimes, and it's like you're on a slot machine and you keep pulling it, hoping this time it'll give me the thing I want. So yeah, they're not quite perfect yet by any stretch, but they're definitely interesting.
I think it's also my job is probably not representative of lots of other people's jobs. I mostly speak to people. Like when I go and work with my clients, it's like I'm educating them or I'm helping connect them with each other. And so the last thing I want to do is stick confusion in the mix. And so I talk to people and we do workshops and we get in a room or we do a virtual session. It is actually about that face-to-face contact. And I've seen some stuff recently from a couple of people saying, oh yeah, I talk to my AI now, so I don't have to talk to my colleagues. It's like, no. Whatever AI is doing, that is broken, right? And so actually you think, at least the stuff I do, that's not helping me at all. I will say, there's a tool called Granola, which I love for my meetings, because it does really good meeting notes. And that's amazing, and that's the one I use. And I use Notebook LM for my research, which is brilliant. But like in terms of my day-to-day work, like it isn't really helping me, and I don't actually want it to.
But do you use it to prepare that workshop?
No.
Because I do. I use it to prepare my work. And I need my own expertise to be able to work with it. But it has been a big time saver for me.
I think maybe it's just me being a control freak. I think I try and think about, like, I like telling the stories and I like telling the arts. And the way I've been able to present and share is about how do I take my personal stories and make them informative. And the thing is, it doesn't know my life. And so it might give me raw content. So that's why using like Notebook LM for research is super useful, right? So I've got a bunch of papers I'm going through. I'll throw them in it and I can ask it questions of the papers. So getting raw information like that. But I haven't found that it's been useful for me to work out how to tell those stories. And actually as well, like that's the thing I enjoy about my job anyway. So like if AI could do it, it's like, why take away the last thing I enjoy about my day-to-day work? Right? So I don't know, maybe I'm just too old now. I don't know.
In your workshops, do you have clients that they're too busy to attend, so they send an AI agent to like take notes?
I was doing an architecture kata for like O'Reilly. We do these things for like teams all over the world. And so I create this problem for them. And I say, here's a scenario, and this is all about you learning about the nature of architecture, talking about trade-offs, working out how to capture and share that architecture with your colleagues so you can grow your skills and become a better architect in your company. And I had some attendees said, can I just have ChatGPT do all this for me? And I'm like, do you know what? You absolutely can, but you're wasting your own time. I say, you do it, but like, then why are you here? So, in answer to your question, not quite coming to my workshop yet. It'll happen. But like at that point, it's just like, okay, you know. That also means I haven't made my own personality compelling enough for them to turn up.
So we're not yet at the point where we can take a Miro diagram, use AI to generate JIRA tickets, and then from JIRA tickets use AI to generate the code, and then use AI to generate the tests, and then...
I mean, we could do that now.
Oh, okay, good.
I'm going to guess along that journey, some issues might crop up. I can't imagine what they might be.
I'm sure it's fine.
I've been trying that. I've been doing some experiments, pretty much doing projects completely with GitHub AI. I've made a few applications and I'm now working on some Azure implementations. The AI is horrible at Azure, which is fun because it changes a lot. So it's almost always out of date. And I see it always comes to the solution. Oh, is it ugly? There's some really ugly code, but it's working, I guess. And I hate to say it, but I do like it when you're having a conversation that the thing keeps saying, oh, what a brilliant question. Oh, what a wonderful idea. I feel so appreciated by AI. Maybe I need better coworkers who keep telling me I need to hire someone to be like, oh, you're such a brilliant person to talk to.
I mean, I hear that all the
but
time,
I love it.
but it's just AI saying that to me. I have a little button every time I want to hear it. I did want to ask, if you could meet yourself from 10 years ago, what things would you tell yourself back then to help you become more effective today?
The lottery numbers?
But you said you enjoy your job.
Yeah, but then I could just do the bits of my job I enjoy, right? And then spend the rest of the time on the beach, right?
So perhaps like maybe Kafka shouldn't be put absolutely everywhere or something like that. I'm not sure.
From 10 years ago, I don't know. I'm trying to think now.
Yeah, I don't know. 10 years ago was when .NET Core was first coming out, and
Yeah, do .NET Core, because it's way
yeah.
better than running on Windows. Windows sucks, man.
yeah. I would tell myself that yes, this .NET Core thing is good. We should do that.
But
Yeah.
is that 10 years already? Oh, wow. Now I'm feeling old.
Yeah, just to be
Why are you
clear,
doing this to me?
It is .NET 10 coming out, although we messed around with some version numbers along the way. But
I do want to be clear about my Windows sucks comment, is that, just to be really clear, I don't want anyone to be offended, but I really meant that. I'm a Linux sysadmin, a lapsed Linux sysadmin. I think .NET Core has been one of the best things that's happened. So 10 years ago, I'd be like, you should really be pushing this even more than we have been. Like, so many of my clients have been so happy. They've reduced their maintenance costs. They've reduced their runtime costs. It's just so much better. So 10 years ago, like, I don't know how you buy shares in .NET Core. Don't know how that works. Anyway.
Well, I was thinking more in terms of do you see your what sort of mistakes do you see that you've made since then that you wish like, okay, maybe that would have been more obvious if I knew what I knew now? What are the things that you wish you had known back then that you've now taken the time to share to others?
I learned in that span at some clients that I was working at that trying to build a system of microservices first is not easy and can take a very long time to get to even the first feature done. So I kind of suspected back then too, but I would know that that's not the right way to go, at least for this particular client that I'm thinking of. So yeah, build something simple first, and then if you need microservices, spin those off later.
And Sam, you've never seen people screw up microservices, right?
No. No, I mean, like, they screw it up all the time. People think I'm a fan. Like, the reason I wrote the second edition of the book is this thick. It's like, this thick is all the stupid shit that you have to deal with when this stuff. But coming back to touching on the 10 years ago point, when I wrote the first book, a colleague of mine said, oh, you should look into, like, Parnas and information hiding. And I looked into it a bit, and I thought, oh, this is kind of this is interesting. So I mentioned it in the first edition of the book. And then, like, over that, like, following 6 or 7 years, I just kept coming back to that idea again and again and again and again and again. And the reason I really wrote the second edition, which is more than twice as big as the first edition, was because I had to come back and call that content out. And that concept of information hiding that I learned about over 10 years ago now, that was first shared in 1971. And now it's like, that's it in my head. It's popped in my head. And I wish 10 years ago I could go back to me and say, actually spend some time looking at this now, because you're going to save yourself about a decade of explaining things in not as quite a good a way as you could be. And so that's the thing I think about, is like, I fixed the record now, right? That's where you get to a second edition.
Can I do one on a more personal level? I learned something really important, and that is, did you know that no one has a clue what they're doing? Like, no one? I thought when I was starting out, like, oh, I better back up because I don't know what I'm doing. Oh, I better not try this because I don't know what I'm doing. I better not speak up because I don't know what I'm doing. Everyone's winging it. Like, it doesn't matter what level you are. No one has a clue what they're doing. We have kind of some level that we know something, but half of the people is winging it.
But we have to present it as if we do know what we're doing.
Everyone's pretending to know what they're doing. There's so many people who have no clue what they're doing. That's awesome.
The people that are pretending the most is the AI. I mean, this is the problem with the chatbots, is because they speak with such confidence. And we believe them. We believe them. And I don't know why we're surprised, because we get away with that rubbish on stage all the time, like talking like we know what we're talking about.
Yeah, we're trying to prepare stuff. There's no need. You can just bluff. No, it is good to know what you're talking about. But if you feel like, hey, I'm not doing well, I know I felt like, well, everyone here knows what they're doing, and I'm just winging it. And I should back off and let the big people talk. And I learned at some point, like, wait a second, like the people I looked up to, that I saw that they sometimes bluff, and they sometimes, they don't know, and they're going to try. And that doesn't mean they're less knowledgeable. But I love it that a lot of people are honest and speaking up about it. But that would have helped me 10 years ago to know, like, it's all right to don't know what you're doing, because we all feel like that sometimes. And sometimes we all are like that. And
I mean,
AI is a very good example. AI has no clue what they're doing.
It's why I love the consultant's motto. It depends.
Yeah.
Right.
You can go any direction from there. Now, being a consultant, one of the things I tend to see a lot are messy architectures. What techniques do you use to help ensure that things don't trend towards the messiness or spaghetti, but things trend better?
I like to use the compiler whenever I can. So I'm a fan of things like, taking away primitives and primitive obsession and moving toward value objects, or taking things that are, statically coupled to the file system or the database and, putting an adapter and an interface in front of it so that you're not, tightly coupled to that, and you could change it in different environments, or you could write unit tests. So, those are techniques. And I work in C#, which is strongly typed, so like that all just makes sense. Like we expect that we're going to have the compiler help us know that, no, you can't pass this integer into that string, parameter. And it's just taking that to the next level to help the compiler help you do the right thing in the software.
I think architecture is messy. I think let's not pretend otherwise. Like I think we use tools like that very effectively to build our own kind of personal mental models to help us navigate it. But like the real world systems are messy. Mike Nygaard talks about like architectural change coming through an architecture like a quantum wavefront, right? You have a new idea, and that idea comes through the architecture. It doesn't happen immediately, and it doesn't sometimes always complete. Every architecture is a work in progress. It's things that are people trying their best to make things work. There's no architecture that's perfect. I think this whole concept of clean architecture is a broken idea. It's always a work in progress. My worry is when we fixate on the architecture has to be clean, we're almost describing that architecture somehow has an end state or perfection. And I think that potentially puts us down a wrong path of thinking that it shouldn't therefore change. If anything, I want an architecture to be messy so I can change it. I think we then need tools to help us build our mental models to navigate it. So I think I like what you're talking about there, using that way in. But I think it is messy, and I think pretending otherwise. Now, I think it needs to work. That's the key thing. We need to be able to navigate it. But like, I mean, the vanity clean laminated A2 architecture diagram on some CTO's wall in a cube office somewhere, it's meaningless. It's not the real world.
What do you use to sort of judge the efficacy of architectures that you're dealing with? How do you know if they are good versus bad?
I'd actually come back to the thing that sort of Barbara mentioned and you mentioning as well, is like about the business priorities. For me, it's like this architecture, it exists to serve the purpose of the organization. So firstly, what's the organization trying to achieve? How well does this architecture deliver on that? And I think the other thing that then needs to get added onto this is how nice is this architecture to live with? So that's the other piece that gets missed. There's a concept called like habitability that originally comes from the built environment. Originally was talked about in coding, but like an architecture imposes on its inhabitants a whole lot of forces. The developers, the testers, the sysadmins, the operators of the system, they have to interact with that every single day. So I think you need to take that, is it working for the business and is it working for the people inside it? And I think you need those two lenses. And often you see problems when people only look at it through one lens or no lenses, and they've come out with some, but the book says I have to have 3 layers. So I think that's the kind of framing I put to it.
You mentioned spaghetti code in your initial question, and like, I think that arises in many organizations because the business in the early days, their main priority is time to market and rapid feature development. And the developers are eager to please, right? So that's what they do. And what's the fastest way to deliver more features? Copy, paste, 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 right? Like it's easy, lather, rinse, repeat, until it gets to a certain size, and then it becomes this big ball of mud that becomes difficult to continue to evolve. And so, businesses are often surprised that 12 or 18 or 24 months in, these features that took a day or a week now take a month or 2 months. And they don't necessarily understand that that's coming. And we need to do a good job of explaining to them, like, we can only just slap stuff on here for so long before it falls apart or falls under its own weight. And there's a consequence to that, and you're going to pay it later.
Yeah, and I'm thinking I have an example of like, you want to add value for the applications. Like the application is there for a reason, and you need to run it as good as you can. There's multiple ways to do that. But I remember I had a case where I was asked by a customer to check their Azure environment. They were running a worldwide app, and it was set up by a third party. And they wanted me to check if it was cost efficient, because they had a feeling it was not. And I checked the Azure environment, and I started the conversation saying, this is the most cost-efficient setup I have ever seen. I wouldn't have been, it has shown me things that I learned. I said, this is beautiful, come to cost. But there's no monitoring whatsoever. So if your app goes down, you're going to find out because your users find out. And if you put good monitoring in, you can find out yourself. And they were flabbergasted. It was on a phone call because this was during COVID. And they said, wait a second, you're telling me I won't have to get 4 a.m. phone calls from somewhere abroad because the app is down? I said, no, you can catch that. You need to know it's down before the user knows. They didn't even know that was a possibility. And that's one of the things I like about architecture. Like, you always have your own frame of reference, and you know what you're coming from and what makes sense to you. And then they never thought about monitoring. It didn't get into their heads. So that was a way to get the value there and get prioritization there. I could have told them, yeah, we could maybe tweak this a little bit and save €3 a month. Would it make a difference? But with this, even though it would be an investment, it would be a huge difference in the quality of what they're delivering. So that's where your value lies.
I think that's really important, though, because I think you mentioned, like, techies aren't always good at talking to business isn't always good at talking to techies, but we sort of sit in the middle, and we sometimes do have a responsibility. Like, the business probably didn't even know observability was important. But the moment you put it in the context of that 3 a.m. call, that unlocks something like, what, you mean that's a possibility? Like, that's adding value, right? That's adding value. But people don't know that, right? I mean, this is the benefit of consultants, people. We bring outside knowledge into, we are available. Well, some of us are available anyway. But this is like, the thing is, like, they may not know what they want, or they may not know what they need. And that's a lovely way of kind of putting it in their language. Like, we'll talk about uptimes and percentile latencies, and they're like, the 3 a.m. phone call, that cuts through. That cuts through.
Yep.
I also found that if I just change my language a little bit, instead of saying what happens if, to say what happens when, that they're like, oh, well, we should actually think about it and plan for it instead.
Teachable moments in the press help. Like you've been trying to push on this idea of what happens if X happens, and then it happens to someone else. Like, it's a great teachable moment, right? Never waste a crisis. It's like, so that thing we were talking about, you know, that company that just lost 300 million, crypto locker attack. Should we do something about that now?
And you need those examples.
Yeah.
And that's the thing. You need those examples. You need to tell them this is the consequence if this is going to happen.
Yes, let them feel the pain.
And that's the thing. Like, if you tell them, yeah, you have spaghetti code, they're not going to care about that. Is it working? Then what's the problem?
Yeah, exactly.
I just blame AI. That's what did it. It wasn't.
and that's the new copy paste, right? You want a bunch of fast features, just let AI keep spitting it out.
I mean, it's just too hard. Command C, Command V, like just let it just spit it out already. So I know one of the ways we try to avoid spaghetti code or spaghetti architectures is to try to limit the blast radius of change by drawing boundaries. But that seems to be the really difficult part. So do you have any tips or pointers on how you like to create those boundaries in your systems and architectures? Like, how do you go about determining what those boundaries should be, and how do you make sure that your assumptions are correct?
I think start with the last thing first. You'll never know if your assumptions are correct. So assume they're not correct, and be prepared to change your mind. Because I think if you worry about, the pitfall I find people fall into is, I don't want to have to change this boundary again. So how do I deal with that? Well, if I don't want to change this boundary again, I basically have the boundary hide nothing. Because then people can get whatever they want, and I've covered all my bases. I think it's better to assume you are going to have to change it again, and therefore you actually create it in such a way that you hide the bare minimum. That's kind of my approach. It's always been, it's a service level. Modules within a process boundary are different, but at a service level, my default is I expose absolutely nothing, because that's the least coupling. I can always expose it later. But if I start with that viewpoint of I never want to have to change that boundary again, then I'm going to overexpose, which causes too much coupling. I'm more at the service boundary than I know the
Yeah,
module.
we're talking about information hiding that you had brought up earlier, and the idea of encapsulation, and you should be encapsulating like at every layer up the complexity stack, right? From a function to a class to a a module or project or whatever, all the way up to your architectural units of deployment. So those things have minimal coupling between them as a result, and we have the tools to do that, but it takes some discipline, and then you have to be open to changing it. And when you get it wrong, it can be expensive to change it if everything is a tightly coupled ball of mud mess, right? But the more things are just communicating through established contracts, whatever that means at that layer, the more ability you have to change the internal design of something however you want, as long as you don't break your external contracts.
I know one of the things I see often is a desire for monolithic architectures, such as everything must be serverless, everything must be APIs, or everything must be events. How do you fight that sort of desire to make things always the same when there's clear trade-offs between those different choices?
I think there's a little bit of that which I understand. I think it's useful to say, in general, we do X. In general, we are a .NET shop. In general, we build systems that use HTTP-based request response communication. In general, we use events. I think that's actually okay, because then you can build up like an institutional body of knowledge about the patterns and practice and the technologies in that space, and you have a degree of predictability. If I'm going around different parts or connecting with different services, for example, I don't have to use 55 different technology stacks. The problem is when it goes from in general I to I only. And so I kind of try and so I think that's the kind of thing, is like getting away from that though. It's like being really clear about what this is good for and what it isn't good for.
Yeah, I think you have to know the trade-offs and decide for each situation whether or not it makes sense. And it's easy to fall into the golden hammer anti-pattern of, I have this one thing that worked for me, so I'm going to use it everywhere. And I've seen organizations that have made the jump to microservices, and they decided that every microservice has a REST API, and so that's how they'll all communicate to each other. And that's not always the best way to do it, because now every single call is synchronously waiting on all the other systems, and your uptime suffers. There's better ways, and you want to combine asynchronous protocols with synchronous things, and not just do one size fits all, right? And as far as explaining that, I think it's pretty easy to show the trade-offs. So like what would happen if, or like you say, what happens when
Yeah.
this thing's down? Can you see how that would impact things? And then there's almost always another pattern you can use that alleviates that, but it will mean more complexity and multiple ways of doing something.
Yeah, and it's like, if one solution could fit all, then our job would be very easy, and we wouldn't have it, because AI could run our job. There's a reason AI can't do our job. And I think at every level, it's boring again, you need to keep the conversation going. Because in IT, we tend to be on our own island, and we tend to throw stuff at other islands, but never talk to them. And I have seen so many things being solved by having a conversation and having that flexibility. Like you said, you have a preference. If someone challenges that preference, have the conversation. It may not mean that you have to change your preference, but have an open mind about it. Hey, we heard what you say, but we're still going to keep to this. Or, hey, we hear your point. You need this. We're going to fix it for you. And what I love the most is that I have had a lot of these conversations where the other side was really surprised that I said, okay, we're going to change our ways because you have a good point. Because they were busy talking with each other how it was not fair that they got their way, that they didn't get their way. And these are examples in Azure, for example, that they said, yeah, we're not allowed to create this resource and it's keeping us down. And then, oh, you have a good point. Okay, we're going to check with security. Oh, no, this is good. If we do it like that, okay, we can do what you need. And the surprises that people offered, like, what, this is actually possible? I was so busy complaining about this, but you can actually do this. And that's the thing, we need to keep talking. I mean, you have no already, you can at least start a conversation if you feel like you have a point. It also means if you get a conversation, talk about it, and you say, okay, we still need to go the own way. Okay, we need to understand each other. There's reasons why choices are made. But
I think on that, I think that's a really interesting way of to talking about you have to have the conversation, because I see people using, say, architecture decision records, but missing the point, right? The point of an architectural decision record was we had a conversation, we reached a decision, and we've written down the decision we reached.
Yes.
But it's challengeable, right? Because you can go back. You say, well, we made a choice to do X, Y, Z, or not allow X, Y, Z. Going back, looking at it, and looking at the reasoning. If the reasoning's still good and nothing's changed, then at least you understand. But something might have changed, or your problem might be different. But I think people don't have the conversation. And if they do have the conversation, if you at least write it down for later, you can challenge. It's not about codifying how things have to be done. It's actually about opening up your decisions to be challenged in the future in a healthy way.
Yeah, I think architecture decision records are underused, and the two things that I think are most valuable in them isn't so much we decided to do X, but we considered X, Y, and Z, and we chose X because this was our reason, this is our priority at the time. And any of those could change. Like there could be some brand new option that didn't exist before, or our priorities might be totally different, and all those might be reasons to revisit that decision.
Yeah.
And you need it for compliance as well.
Yeah.
You need those records, and if stuff goes wrong, you need to be able to show, hey, we made this decision with each other, we made a conscious choice, and maybe we should change our ways, but hey, this was a conscious choice, we all share responsibility.
I think that kind of goes back to this idea that we want to facilitate change. So what things do you do in your clients to help foster a culture of being okay to have mistakes and have change, as opposed to everything being so rigid and the decision is done once and we never revisit it ever again?
I tend to start with the cost of change. So I say, we've got a decision. Okay, so if we change our minds in the future, or if this turns out to be a bad idea in the future, how much of a hassle is it going to be for us to change our minds? And if the answer is, it's going to be quite easy, then just stop talking about it and just do something, right? If on the other hand, it's like, if we get this wrong, we're going to have to go out to all 10,000 external customers of ours and get them to roll over to a new version of an API. So if the cost of change later on is massive, it's like, we need to take time on this. So for me, it's that reversible, irreversible decision type, sort of almost like, where are we on that? Because I think the two-way door thing is a bit overly simplistic, but on that horizon of easy to change our minds and cheap and expensive and hard to change our minds, where do we think this is? And then based on that, this is how much time or effort we need to put into having the conversation and doing our homework.
Oh, that's such a good point to talk about, or to think for yourself. Like if I want to convince someone of my awesome idea, how much time is it worth it? And it reminds me of when I was a system administrator, and they needed to, like my coworkers wanted to convince the customer to buy a public certificate for an internal service. And they had this whole speech set up, and they were like this, and you see this, and then I stopped them, and I said, the thing is 10 euros a year. And he was like, okay, done, next thing. But they had this whole speech prepared. I told him, if you do it for 3 years, it's going to be cheaper. He says, how long do I have to take this for before it's free? But he was like, if we talk about this for 10 minutes, it's going to cost more than actually buying the thing.
Do you have that little, I've seen the timers people put on the how much does this meeting cost sort of thing.
Yeah.
That would be so healthy for so many things. But then again, like you say, some choices can be very expensive if it's the wrong one, and then it's very worth it. So it's a good thing to think about.
What I've seen work well in many organizations is to just change it from this is a decision we're making to this is an experiment we're trying. And there's many things from your team activities and your how you meet or how you decide to deliver software to the architecture that you can do a 2-week, 6-week, whatever experiment, and then have a meeting after that to say, well, how did it go? And beforehand, hopefully you've got some idea of how will we measure success? What would success look like? And then when you're done, you can have those metrics because you knew what they were going to be, so you captured them along the way, and then you could say, well, did it meet our expectations or not? And then continue or change course.
So this keeps bringing up this idea of communication. What sort of resources do you share with your teams to help them become more effective communicators? Because I don't think that's talked about very much at all.
I think it's a bit personal, and what I mean by that is that some people are confident speaking in a group. Some people aren't. Some people are okay talking on stage. Some people aren't. Some people write really well, but they might not present very well. So I think when I've done coaching with people like that about internal comms, it's often, well, let's actually start from the viewpoint of what it is you need to do with your job. And now let's talk about all the ways you could communicate. And now let's talk about the ones you enjoy. Because like, there's this idea that everyone has to be able to get up on stage and be a public speaker. No, you have to be able to get by in your professional context, right? So actually, the better thing is, if you're an architect, what are the things you need to be able to? You need to be able to communicate with your team and to get your ideas across and create a space in which that works. But then you might need to adapt how you do that based on yourself and also the context you're in, right? Because some organizations live off documents, right? And that's how that works. And if you're in one of those environments, talking about doing presentation skills is way less useful than talking about how to write a good, clear design doc. So I think it is kind of personal and contextual as well.
I have a consulting company, Nimble Pros, and we do regular lunch and learns and have different people present internally, and it's small. It's like 10 people or so, and anyone that wants to share something can, and if they don't want to, they listen. And oftentimes the topics are technical. Sometimes they're like somebody set up solar in their backyard to charge things. Like it could be whatever, but it's giving them an opportunity to get to know their coworkers better and to develop those presentation or communication skills. And sometimes the topics are literally about like soft skills or presenting or whatever. So like those are the ways we do it. Is try and practice it, try and give opportunities, try and make it so there's chances for folks to learn and grow in those ways where they want to.
And we need to realize it's a skill. Because we tend to be like, you are good at talking to people or you're not. You're good at a stage or you're not. And that's not, we don't expect someone to know a programming language they've never seen. We expect you to learn it. And you need to learn how to talk to people. If it's not, some people have it coming naturally. But I always love to tell people, I hated public speaking when I did it in college and in university. I thought it was awful. I would start shaking, and I would be at the back, and I would talk really fast, and I hated it, and I thought, I'm never going to do this again. This is just not in my skill set. It's not something I'm good at. Well, that changed a bit. And that's because I found out I liked doing it, and I practiced. Mm-hmm. And I looked up how you do it, and I did it internally for small groups, and I fell on my face, and I tried it again. And then I noticed I could also use it when talking to customers, that it worked for that as well. And I learned how to have conversations. It's also a skill. So if someone's like, oh yeah, I'm not just not good at that thing, you can learn. It's something you can learn. And for some people, it's easier to learn, just like a programming language. Some people will have an easier time learning that, and some people will have a difficult time. But we need to treat it as a skill, so something that you need to be trained in.
And having a safe space, I think both of you mentioned, I think is really important, is I'm doing it in a safe space. A lunch and learn's a great one. Like, because you're around colleagues, you already know them a bit. And doing like internal, like I first did internal, we had like internal conferences. I would do the lunch and learns for a client. I'd then do an internal conference. Like user groups are also a great one to do it at. So if it is something you're interested in, finding those safe spaces to start that's a great advice. And I started learning how to write, doing a blog that no one read. Just getting it out there, like just the practice of putting something out there and writing something out there. Safe space because no one knew about it. I've still got the analytics, no one read it. But that was okay because it was safe.
Blogs, I remember those things.
Yeah.
Yeah, I know like when I was at a consulting company, we used like books and things like Crucial Conversations. We would do things like after meeting, let's do a little mini retrospective to say, how did that go? What could have gone better? What didn't go well? Just to have that, kind of culture of constant improvement, because it can always get better, right?
You did in some really large organizations, they have like great resources around this, but they can be a bit identikit. I worked with a guy who's an excellent sales guy, used to be ex-IBM, and he shared with us the video that IBM used for corporate training their sales team on how to shake hands. So that stuff's out there if you want it. I've kind of just winged the shaking hands thing nowadays, in general.
Fist bump, I think.
Yeah, exactly.
So one of the things that has really changed in the last 5 years since COVID is a very changing dynamic and where people are working these days. So how have you seen kind of your job change with remote work, maybe return to office, and like a lot of hybrid sort of situations in between? Or is it just gone back to normal?
No, certainly not normal.
Right.
Normal. We have a new normal now, and I feel it's very difficult. I feel we're at the stage where, when we were fully remote, it was something we had to do. And I think fully remote teams can still work if everyone is fully remote. But the hybrid part, I think that's such a difficult thing to do. And personally, I don't like being fully remote. I love having a day at home with, I have a good setup and big screens. My setup is better than at the office. And just quiet working and get some laundry done while I'm working. So I like working at home, but I hate meetings remotely. And one thing I hate the most is workshops, remote, teaching remote. I did it during COVID, and I said after COVID, I'm never doing it again. Speaking remotely, virtual events, I'm sorry, I hate doing them. I love the feeling of seeing people in person. And it's very difficult because I feel like, I don't know with you guys, but I feel a lot of people have, on Teams you have at least one person who wants to stay at home all the time. And I feel, I want to give people that space, but I just hate the meetings that way, and I do feel a little bit disconnected. So I think we're at a very difficult stage between what actually is the new normal. Because fully remote is not the answer, I think. But
I think it's going remote and assuming that just acting how we acted in office works remote. And I think that's why you mentioned that fully remote tends to work, and that's because companies that are fully remote have built skills and do things like workshops or training or facilitation in a way that works in that environment. I think if you just take what we do when we're in the office and just sort of stick that with a screen between us, I think it breaks down. I do a lot of training online, and because I can reach people that could never come to a class and I can't go to them, but I do it quite differently. Like I found that I had to do things like I'll take way more frequent breaks. I have to do a lot more actual polling. Because when I'm in the room, I can read body language and see someone's about to ask a question and say, did you want to say something? Like, I can see that. I can't do that, like, in a virtual thing. So I had to do a lot more active going out and soliciting questions and opinions and things. So it's been good for me, partly because I work with lots of different clients who's, like, might be doing transformations that might last several years. And actually, the model that works really well is that I have just periodic catch-ups with them. Like, it would be incredibly expensive for them for me to go and do the work with them and be on site for like a few days here and a few days there. So for me, it's actually worked out really well. I still prefer training in person or doing workshops. If I can, I absolutely would love to do that. But at the same time, like I don't know, I probably do about 20 hours of online training a month. And that's with people, by and large, that I would never get to meet in face-to-face, and they wouldn't be able to come meet me face-to-face either. So for me, it's actually probably broadened the number of people I can work with. Mm-hmm. But if I could meet them in person, I'd take that opportunity.
Would you do hybrid?
Hybrid for training does not work.
No, exactly.
I have done that. I did that once the other way around where I got COVID and I was supposed to be at NDC. And so I was remote and all of the audience were in a tent in Denmark. And that was difficult. But no one got COVID from me. So,
Yeah, we're a little different with our company because we were remote since I think 2017, like fully remote, and then COVID came along and it was like, well, we're still fully remote. It sucks, but it's not affecting our office or anything, right? So I think fully remote is certainly easier than hybrid because you don't, if some people are in the office and some people aren't, they're missing all that water cooler conversation that's happening and they're out of the loop. But when everybody's remote, if you've got the right tools in place, it works well. It works fine. And our clients are all remote. Like we're mostly in Ohio, but we have like one client that's in Ohio, and the rest are all over. And our clients are often distributed teams as well. Like the one I'm working with frequently now, they have developers in 3 different continents, and they're all meeting at the same time. There's like one time that works for everybody. For like stand-up meetings, but otherwise it's all over the place. And if I would love to do an in-person workshop, but it would be hideously expensive to bring all those people in one place on the globe to do that. Whereas we can meet on Teams or Zoom or whatever, and it works it works, right? It's not as good as in person, but it works, and it's certainly cost effective.
Did you find I'm asking a question. I'm sorry, Jimmy. I'm doing, but I found people way more open to doing things remote post-COVID because they were forced into it, and I tried to do it before. So now, I could do things that I could never do before because they're open to it. Is that what you found a little bit?
We found that before COVID, we would tell people well, no, we don't come on site. We're just remote. And they're like, does that work? Like, yeah, we've been doing it for a while. And then after COVID, it's like, well, yeah, I mean, we all do that now. So yes, that changed.
I love that you have to explain now to the younger generation that we used to be all in the office. Like they're so confused. I have that, and then you feel old. Very quickly, but you say, yeah, this was before COVID, so when we were all in the office, and they're like, what? How? You didn't?
This thing called Skype. Remember that? Yeah. It's dead now.
Skype for business.
Yeah,
Yes.
well, yeah, okay. Now, I know one of the things that have had a hard time replacing personally is getting the stakeholders in a conference room with a whiteboard to have discussions. I've yet to find some technology that could help replace that. Have you found similar kinds of activities you've done before that you've had a hard time finding an analog?
Yeah. I mean, Miro's great, but it does not replace the tactility of actually having a physical space. So I used to work at ThoughtWorks many years ago, and I was involved in putting the radar together. And there was something about having 12 argumentative techies in a room with a wall full of hundreds of sticky notes. And then you could get up and wave your arm and shout at something. That's up, and you could do, but it was tactile, and you can pick things up and you could move them, and you get people involved and engaged. Same when you're doing event storming or something like that. Getting people in the space and milling around. Miro does as good a job as I think you can do with a pure virtual thing, but you lose the tactility, and I think you lose some of the spatial side of it. You lose the spatial awareness part of it. So there is a lot of, when you're absorbing knowledge, and you're interacting, there's something about being able to move you to the knowledge or move the knowledge to you that you just cannot replace with a digital analog. That said, again, if the choice is I'm doing an event storming exercise online with Miro or it's not happening, I'm still going to do it kind of online. But for me, there is those things, especially doing facilitated workshops, that tactility, the interaction, I think is really hard to replace.
Yeah, the thing that I find is really hard over the tools we have today is to be able to have many small conversations happening at the same time. Like on a Zoom or a Teams or whatever, there's only one audio channel and everybody has to share it. And in a meeting room like that, you might have 6 or 7 conversations happening all along the wall about local optimizations of these sticky notes or whatever, right? And so for event storming or big planning meetings, that's really hard. And you could do stuff like breakout rooms or something in Zoom, but I wonder if maybe at some point in the future, if these metaverse things ever take off, we'll all have our HoloLenses.
The little Apple glass.
You'll be able to be in a virtual space where only the person close to you in the virtual space can hear you, and you could have these conversations. But I don't know if that's ever happening.
How cool would that be, though? That would be awesome.
Oh, we'd look like idiots. It might be cool if you did, but
But we
outside.
already
That's
do.
why you're just
Come
in
on.
your office, in your room. No one else can see you.
I would put those people in a glass room. I want to see it.
I know one thing I missed personally was just throwing up ideas, the tactile, but also reading body language of people to
Yeah.
see what are their reactions to some ideas that I'm throwing out there.
Especially when you go to different cultures.
Yeah.
Kind of, if you haven't been to that place before or had people from that, working out how to read it, people in, say, Norway is different to reading people in China, different people in Australia, whatever. And there's always little different nuances. If you spend some time with those people face-to-face, in that culture face-to-face, it's easier to read it remotely. But then if you haven't, and you start remote, the first time I worked with a team in China, I was discussing this thing we were going to do. And I said, I think we should do it like this. And I just got silence. And I just assumed they were agreeing with me. And I found out later that because they just ignored me and did the better thing anyway, what silence meant was, we think you're an idiot, but we're not going to tell you to your face, and we're just going to make it work anyway. So then I learned, and they were right, by the way, but then I learned in that situation, it's okay, so what I actually need to do is, if I don't hear anything, it's okay, so tell me why I'm being an idiot, right? What's wrong about this? But that was me having to learn. And if in a face-to-face, I probably would have got a sense of that, because if you get silence in a room, you read it a bit different. And so I do think that is really difficult to build up purely in a remote session. So I think it's also why people massively underestimate the cost of offshoring and nearshoring, because you do actually need to have people moving. You do need that cultural awareness, and that does not, even the best cameras don't bring you all the body language cues that you kind of need to pick up on.
All right, well, I wanted to end this is something I personally struggle with myself, was just this idea that everything moves so quickly. How do I try to keep myself relevant when there's so much new stuff coming down the line? Is that something that you struggle with personally, or is it just me?
Yeah, what did you say about working hours? That's the thing. Also acknowledge that you can't keep up with everything, and that's all right. So it's all right if someone says, "Hey, have you seen this new technology?" No, haven't been able to catch up yet. Tell me. Or ask AI and pretend you know what you're talking about.
Well, especially if it's something JavaScript related, I'm like, no, I'm not going to try.
It's all right to not know it, yeah. And I had the luxury that I'm capable of doing that stuff in the evening because I love learning about it. And I love keeping up. But I'm not able to keep up. And I will, but I have a very good personalization on it, but I will ask ChatGPT, what is this new thing everyone's talking about? Tell me in less than 200 words. And then acknowledge I probably don't know for sure what it actually said, but I'll...
You mentioned what I wish I knew 10 years ago. I wish 10 years ago I would have been happier saying, I don't know.
Yeah.
I did not have the confidence 10 years ago to say, I don't know. And now I'm like, I don't know that. That sounds cool. Whereas before I felt like I had to have an opinion. So recognizing that I can't keep up, I think is part of it. But then also being confident enough to say, I don't know, but if it's important to you, I can find out.
Yeah.
That took me, I wish I'd known that 5 years ago, let alone 10 years ago.
Yeah, that's something we tell our consultants in our company, is that's the right answer. If you don't know, don't BS, don't make something up. Just say you don't know, but you'll find out. And that's almost always the right answer, and folks will respect that you are being honest with them generally. The other thing I think is there's different levels of knowledge. There's things you don't even know you don't know, and so you want to find ways to be exposed to those ideas, and that might be social media or LinkedIn or YouTube or whatever works for you. So you're hearing about these new things, and then you decide which ones you care to know any deeper, right? Maybe I just need to know what that acronym stands for, and that's enough. And maybe this is something that you think is going to be really relevant, or you just think it's really cool, so you're going to actually play with it. And for me, if it's something I want to learn, that means I got to actually work with it and do something with it. I can't just read an article or watch a video. I need to create a GitHub repo and start messing around, and that's the choice that I have to make, because there's always way more cool things than I have time, so I have to pick the things I really want to spend the time to get good at.
And if you get into a conversation based on what you say, being able to say, I don't know, if someone asks you, so what do you think of the new GPT model or whatever?
It's great.
Yeah, that's one option, but one of the options, chances are that person has already read about it and has an opinion about it. So this is where you say, oh, is there a new version already? Awesome, I didn't see it, tell me about it. And now you're going to learn from them, and you don't have to do the research.
But then there goes the next 30 minutes of your life, because they're going to talk your ear off. That is one thing I did find valuable from using chat-based tools, is I can ask that a question about what is this all about, and it actually can give semi-coherent answers sometimes.
Yeah, and you can say, I don't understand it. Explaining it to my grandmother, and it will do that. And you won't have to tell other people. They have no clue what they talked about.
All right, we're at that time, so I wanted to thank Sam, Steve, and Barbara for coming today. Thank you for all your insights. Architecture has never been more exciting and probably never more complex. I'm reading this here. To everyone watching, stay curious, stay critical, and keep designing systems that stand the test of time, or not. It's fine. This was Techorama TV, the architecture panel. Thank you very much.
Thank you.
Thanks, Jimmy.
What are you talking about? Not scary.
Hello.
Hello. I'm Hannes. We're sitting here at Techorama Netherlands today, and I'm joined here by Steve, Bart, and Poornima to talk about software development. I'm going to let you introduce yourselves, and maybe you can tell us where your journey in software development started.
Wow. Okay, so I'll start then. So hey, I'm Steve. I'm a developer, architect type guy. I work at Microsoft at the moment. I've been in the software industry since about 2003, I think. And my journey, well, as a professional at least, I started with some Visual Basic and classic ASP. I built some software as a service type stuff. I did a stint at an investment bank working on their risk management system. And generally, I've done a lot of web stuff, probably going up to just until the last few years. I've been pretty focused on web and UI things. And then more recently, I've switched over to focus on AI. So I'm now working on GitHub Copilot, and I'm very concerned with how we make AI systems work at scale and be really useful.
Right. What about you, Bart?
Yeah, so I'm Bart. I'm originally from Belgium, but I've been at Microsoft in Redmond for the last 18 years and a couple of weeks. So it's been a long journey. Before that, I was an MVP for C#. So I was like 4 years in the MVP program, which is a program by Microsoft called Most Valuable Professional. So I was in like C# for a long time. I started with the early betas in 2001 back then. And before that, you know, I was actually a high school student, and I developed quite some software at the school, set up like the Active Directory domain. We started with Windows 95, 98. Later, we rolled out Windows 2000. And we were actually the first school in Belgium to give an email address to all the students in 1997. So on a single ISDN, you know, connection. So that was kind of terrible. So yeah, I started early, you know, was just lucky enough that my uncle had a computer to replace his typewriter. So it was like MS-DOS 3.0, you know, GW Basic, and I was just writing, you know, simple programs. So like I came to, I think I was 10, I went to the math class, and I proudly had printed out all the prime numbers until 1 million on chain paper on a matrix printer. So that was kind of where my journey started. Yeah.
What about you, Poornima?
Hello, I'm Poornima, and I am pleased to be here at Techorama, and I've traveled in from UK. So I am a software engineer and solutions architect at Particular Software, where we build end-service bus. So like Steve said, I started my journey as a web developer as well, mostly web till very recently, and for the last 2 years, I've been focusing on distributed systems on the product side as well. So it's a nice shift in career. And I think I am one of those lucky people who decided to have a career in software development when I was in my university education. And voila, because I was in India at that time. I'm born and raised in India. So being a software developer at that point was like a no-brainer job for me. And I think I'm lucky to be here as a software developer there, because I decided to be one and I got the job that I needed.
All right, thanks for introducing yourselves. What I always wonder, like the three of you have been around for quite a while in the software development world. What is the thing that changed most throughout the years? Like things that you do very differently now from when you just started out?
All right, okay. Well, there have been a bunch of different shifts, I would say. I mean, I'm sure we can talk about all the AI stuff. But like even going back before that, I think when I first started as a professional developer, we didn't really even have a particularly good sense of stuff like source control. We certainly didn't have automated testing, or we sort of vaguely had heard of this mystical story that somewhere out there some people had got automatic tests, and wouldn't it be great if one day we could have something like that? But you know, I don't think that was commonplace back in the early 2000s. So I would say, yeah, the shift to fully decentralized source control with automated tests and CI systems and things like that, those have been really huge shifts. Even if they feel commonplace to us now, they were not commonplace 15 years ago.
Yeah, I think I'll second that. Maybe add a couple of other things to it. Like, I think the initial shift from like simple editors to like integrated development environments was a big one. So like when I started, it was like, you know, there was this thing called edit.com in MS-DOS, you know, and that was my editor, and then there was not really any good debugger, you know, we had debug.com. So like, yeah, moving up to like, you know, the first integrated development environment, and, you know, as a student back then I couldn't afford Visual Basic, so I was actually using Visual Basic Control Creation Edition, which was like this weird Visual Basic version that was actually shipped for people to build visual controls. So I started with that, and it really opened the whole world because, you know, I was able to do the development, to do the testing, the debugging in one environment. So I think that was one big thing. And then I think in recent years, I would say, and that kind of goes to the point that was made earlier, I think everything to do with containerization has been a big thing as well. You know, I started on the current team in the Azure organization about 8 years ago, and the first thing I actually tackled was, you know, containerizing the entire build for our subsystem. Because we had so many dependencies, there were non-reproducible builds in many developer offices. We had like an ad hoc solution at Microsoft for that called Razzle, which is like a development environment. But we modernized that whole thing using like Docker and containers and those type of things. And then, of course, the whole extension to like anything testing related and so on is a natural extension to that.
Anything that you care to add?
Yeah, so first of all, the source control. So that was a new thing for me when I started my job. So there was Visual Source Safe. That was the first source control that I used. Then moving on from there to, what was it? The SVN? Yeah, SVN, and then now GitHub. That's a big shift, paradigm shift, to the point that GitHub is like every developer's go-to thing these days. The tooling, the integrated development environment, which has grown leaps and bounds. And then one thing, the cloud did not exist when I started my journey as a developer. I still remember the first ever project that I completed when the release was happening. So I was based in India, in Bangalore, and the people in my team doing the release, they had to remote log in to a server in Mumbai. And that itself, that establishing of the link at that point took about 3 hours because it was a very secure connection. Now we have all sorts of modern tools, DevOps, deploy to cloud, continuous integration, continuous development. So I think as a developer, the tooling that you have to support you in your productivity journey, that's amazing.
I hear some similarities between all three of your stories. Like the tooling that we use has gotten more and more professional over the years. We're starting to containerize things. Our IDEs have gotten better. The way that we deal with deploying stuff and running automated tests, like all of that has professionalized quite a lot. Today we frown upon things if they're not being used in certain teams. But it's not that hard to remember the time when we didn't have any of those things for ourselves. It's just that our vision on all of that has shifted. What is the one thing that you feel like is going to happen over the next couple of years that is going to make our lives a lot better?
Well, I guess everything's being impacted by AI at the moment, and there's definitely a very strong desire and a demand to move more and more of our development process over to be orchestrated by AI and to an extent actually done by AI. And we don't know how far that's going to go. You know, we're just like literally trying to predict the future here. But we do see some clear signs that some of the coding models that we've got at the moment can take on a lot of our basic problems for us. We see cases where we get more and more productive systems for orchestrating collections of AI agents that are working on our software. We could imagine ways of pushing that forwards beyond that. You know, you could imagine that when you've got your repo on GitHub, that whenever someone's filing issues against it, it's trying to repro the bug for you before you even get to that. It's trying to propose what a fix for that would look like. It's working out what the impact of that on other things would be before you even get there. I don't know if that's going to happen, but you know, it's the sort of thing that you might predict based on what we're seeing with AI at the moment. I would think. I don't know. What do you guys think?
Yeah, I think that's definitely a big point. Like I just remember a couple of weeks ago, we had one of our bugs in the system. We use actually GitHub for organizations in our team, and you know, we actually just CC'd on the reviews for a particular issue. We actually just assigned Copilot to the issue tracker, and it came up with a pull request, you know, fixing the issue, right? You know, it went search for like, you know, what the code is doing, like what the most likely places where things were happening. You end up with a whole explanation of what's going on, and you know, actually that one was actually spot on. It wasn't super complicated, but it wasn't super easy either, because you know, any junior developer on the team would struggle to have the context of finding where is the issue, how to find it, and so on. That thing can just read all the code and contextualize it, right? So that's I think one big thing. And then the other thing I've noticed is, you know, in the past we had a lot of cases where like, yeah, maybe we should consider building the system this way or that way, but even prototyping this will take so long, and you end up also with some kind of Stockholm syndrome where you're kidnapped by the current code. You say like, I don't want to throw this thing away, it's working, it's in production, it could be better or anything like that. And so over the last year or so, we've actually done way more rapid prototyping by actually using, you know, AI to help us build a new solution. And then we don't feel guilty for tossing it into the bin and trying another one, right? Because you can quickly get up to speed with something, especially in languages that aren't super productive, where like the barrier to entrance is quite high. There we can actually say, well, we're doing this in C++, we've always done it in C++, you know, it's a pretty hostile environment to get any productive stuff going. Like AI doesn't suffer from that, right? It will just flow through and do it. And then we say like, well, we already have this thing, can you build the same thing using Rust? And like, we wouldn't even dream of even starting that on a big code base, and you know, the thing sort of just blows through and tries to get to some point where you can do the last couple of miles yourself, and then actually have like apples to apples comparisons between the two things, and then make decisions that way. So I think it also helps, you know, speed up the experimentation cycle. I think that's a big thing.
I think I pretty much agree to what Steve and Bart has to add here. So I don't think I can add anything more. It's definitely AI that I need to watch out for. Similarly, like just like what Marc said about using Copilot as a reviewer of the pull request, these are things that I have baked into my workflow these days. But I think the biggest impact of it is to make sure that I use the tools as tools, something that I co-pilot, work with, rather than just leading me. I think that's the biggest thing that I need to watch out for as a developer and also as a mother who is trying to educate 11-year-olds, making sure that she uses the tools, not just her friends who I'm close with as well, making sure that these AI tools are used with a purpose of being on the side as like a friend, a companion, to help with their journey rather than leading the way.
So the cat's out of the bag. We're talking about AI now. Is this going to be a theme for the whole conference? I guess so, right? You started it this morning.
I'm sorry.
But I think it's interesting. And I know that a lot of, especially junior developers out there, are worrying about their job security for the next couple of years. As somebody who has been around for a while. I don't see it quite as bleak, but maybe you can enlighten us how you think it will change our role as software developers, because we're already hearing like it has a huge impact on the workflow that we do things. I'm not hearing just quite yet that it's replacing actual humans. It's making humans more efficient. What do you think is going to change most in our roles? What kind of skills should we be optimizing for today?
I think this is my take on it. As a senior developer in the team, I think people skills are getting more and more important here for me, because the knowledge about a language, an IDE, a platform that's readily available, any developer, be it junior, mid-level, senior, and even above, I think the learning process continues. Right? So for me, the way I see it, the next generation of developers, I need to be in a position to mentor them, guide them, have not just the developer skills, but also have the people skills in place to make sure that they can then take on the roles and then lead the next generation with that knowledge and experience that has been gained. So that is what I'm focusing on right now. But yes, it is important to give the junior developers the knowledge that we have been in your shoes. It's not impossible. You can work your way up. But as you said, it is a daunting time. Do I have more thoughts about it at the moment? No. But the way I look at things is use all these tools as something that can work by your side rather than just take everything that it says as the gospel. That's the best advice I can give someone listening.
What do you think the effect is going to be on the next generation developers? Because we grew up having to do a lot of stuff by hand, and we've gotten better abstractions throughout our careers. We've gotten better commodities over the years, so a lot of things have become easier. What is the effect going to be for people who enter the workforce with all these things already in place?
Yeah, I think there's also something to be said about like seeing junior developers come into the workforce and being able to be productive in a complex code base quicker. That's actually something I've concretely seen happen the last 6 months with some new people on our team where, using, AI assistants, they were able to actually get into like the weeds of the code quicker. And, I've always been telling, new people on the team, the most important thing to do is to step into things as opposed to talk to other people saying, I don't own this component, I don't understand what's going on. And in the past, there was a scary prospect and, the best of the best would actually just blow through and lose maybe the whole night. I'm not saying you shouldn't have a work-life balance, but, there have been beautiful times in my career where I was stepping into like Windows source code and ending up all the way in totally irrelevant areas. But it was a slow process to actually figure it out. And now you can actually have this also with better tooling, right? With better tooling, you end up stepping into things much quicker in other subsystems, other parts of a distributed system. And then you can say, well, I'm lost here. Can you please explain me what this code does, right? And you just sit in VS Code or whatever your editor is, and you ask, like, give me some context, help me understand this thing. And I've seen people getting up to speed quicker, actually, by using these tools. So I think it's like having an encyclopedia next to you and also have the ability to ask it to like try to mutate the thing, and kind of see what the effect is. And I think that's very empowering because in the past we were pretty much in read-only mode, right? And then you have to first internalize everything before you can even be productive. Now you can have somebody help you look over your shoulder, and you don't have to have the shame of going to the most senior developer on the team asking, like, how does this thing work, right? So I think that's empowering.
Yeah, I think that's right. And I think even for the most junior developer coming into a complex project from the beginning, having that sort of starting point when you're about to create something is really helpful. And it's an opportunity for every developer to produce value through having critical thoughts about something. Like, I don't know how good AI coding is going to get a few years from now, but right now, it gets a lot of stuff wrong. Like, if you go back to the early days of computer automation in like the 70s or whatever, people used to say things like, oh, computers are devices for making more mistakes faster than ever before. And that, you know, that's true. And a similar thing kind of happens with AI coding. Like if you just want to make 25 PRs today by assigning them all to Copilot, cool, you can do that. Probably 18 of them will be like, well, this might be useful, but it isn't really what we were asking for. And some of them will be just like flat out madness. So having that insight as a developer to say, no, I don't really think that this is doing what, you might technically have made some test pass, but did you do it by changing all the tests so that they're now garbage? Something like that. You know, having that willingness to question the system allows you to accelerate your learning quite quickly. You can go into a code base you don't know, try and do some productive work in there, and then say, okay, but I'm also going to assume that it's wrong. So let me like pick through what it's done, try and find all the holes in it, you know, look at things from a different angle, and then suddenly you're like operating as if you're a senior developer in that code base, even when you've never seen it before. So I think that's a good opportunity for people coming into software.
You've been talking about getting things wrong, getting things right. Do you think that there's certain programming paradigms where AI is really going to shine? Because I can imagine like going from natural language maybe to something that is command and event driven, that it might have a better time translating that to code, or maybe there's more code out there that is very low level, it might be better at that. Where do you think it's going to shine the most?
Cool question. I don't know. I've got an answer. Any insights?
I think, you know, languages and protocols and things may evolve more to become, you know, AI friendly in some way. We see that with all the stuff around MCP servers and whatever. So like, you know, traditionally a lot of programming languages have been built to be friendly towards the machine, right? And like, you know, even if you look at the syntax of low-level languages, like they're kind of hostile to humans in some way. Because they were optimized for like, oh, they need to be easy to parse, you know, they need to be, you know, highly structured and so on. So I think maybe there will be a little bit more of like a blurry line there going forward. Where it shines, that's a good question. Like, personally, I've been using it, you know, for mostly C++ and Rust. And the thing with Rust is it's a very verbose language, like in the sense of, you end up with indentation from here to the window because you have very nested, you know, pattern matching kind of things, and you end up with code that looks like an indented triangle, and it's hard as a human to kind of find your way to the nesting and so on. And like it's very good at like stamping out these templates and not getting confused about like how deeply indented things are, and then you go refactor it obviously to make it like more human readable. In C++, I find like, you know, it struggles a little bit more with contextualizing the thing because the context of a single source file is just humongously big in C++ because there's a whole bunch of things being imported, and so then it tends to hallucinate in those kind of places. So I think in more controlled languages, I've seen it do slightly better than like in places where, you know, it's kind of opening can of worms in the Wild West of like includes and bounty fines and stuff, and I'm just talking C++ here. But yeah, like I think at some point there will be more stuff, I think, in programming languages that's more friendly towards like, you know, AIs producing code patterns. That's just my thought.
No, I don't have anything to add here, but summarized it pretty well, I think.
One thought that Bart's just reminded me of is the sense that it tends to work better the more you have a closed loop of feedback. So, you know, the AI system in most cases can't actually see your program when it's running, which makes it hard for it to debug any problems that are occurring. Now, to some extent, maybe they can because they can automate a browser or something. But any way that you can move the error detection earlier generally makes you get faster feedback that allows it to proceed more reliably. So, you know, strongly typed languages, they can often detect problems before it's even got through compilation, or if you've got a good test suite, then there's a good chance it can detect problems before it even tries to run your app. Or if it is running your app, do you produce really good event log of what's going on so that it can see what's going on Because if you don't have any of these things, then ultimately it ends up having to like take screenshots or something, which is a spectacularly unreliable way of debugging what's going in your application. So yeah, maybe we will see an increase in, log everything by default kind of languages.
It's interesting what you mentioned, because I've always been a huge fan of the philosophies around domain-driven design when you're writing business software, thinking of how can we bring the code closer to how we talk to each other as humans and not bring the code closer to how the machine thinks. I know that some of you write vastly different code from that. Also, no judgment there. Do you think we will see, because of AI, a shift in the direction of that way of coding?
I have no idea. I know a lot of people have talked. So, have you heard of spec-driven development?
Yeah.
Okay, so for anyone who hasn't, this is just a little pattern that people have been using with AI coding assistants quite a lot, which is you don't just tell them to write some code, you tell them to write a specification for what the code is going to be like when they've written it. And then you get your markdown document that says it's going to have these features, it's going to have these data structures, we'll use these libraries and things like that. And you read it and you say, oh, that's not really right. I don't really want to be using that JSON parser. Or, no, we don't even have a database. This is nonsense, or whatever. And you have a conversation with it until it refines the spec into something that you feel, okay, there's a fair chance that you're actually going to succeed with this. And then you say go, and it starts to write some code. And then not only have you got your code, but you've got your spec as an artifact that you can put in source control as well, that can be part of context forever, and you can build other specs with reference to that, and so on. Okay, so that's spec-driven development. Some people have said, well, do we even need the source code anymore? Like, if we've got all these spec documents, maybe that is the software. And from the spec documents, we can effectively machine translate that into something executable through AI. Now, we're nowhere near that being a reality today, but it sort of almost feels like the end game with what you're saying there. Like, you've got a bunch of documents that are pure natural language, pure business language, and then somehow it runs as software. I don't know. What do you think? Is that madness?
Sorry for being very cynical, but wasn't that the promise that we were given with all of the rat tools, all of the low-code, no-code solutions? Like, I've heard this promise before. And with AI, I'm super skeptical, because the way that AI generates output is non-deterministic. So we could get the same spec and transform it into a working solution, and on the next gen, it could output something that actually doesn't do the thing that it needs to do. Like, that's a major hurdle that we would have to take before we can actually think about using it in that way.
I sort of agree, but you wouldn't necessarily throw all the code away. Maybe that's that's like the machine code that humans don't really think about, and the AI system sort of evolves that over time for some kind of like consistency. But in terms of the non-determinism, I think I would have to challenge the fact that probably, Hannes, when you write code, that might be like a non-deterministic process as well.
For sure.
So, is it necessarily fundamentally different? I don't know.
No, I get what you're saying. Like, the way that I output code is always affected by everything around me. Like how well have I slept? What's my state of mind that day? What's the amount of time pressure that's thrown at me? Like, a lot of these factors would not even affect an AI, which is a good thing. But it's true. Like, the way that my code comes out is affected by many different things. The thing that I'm pretty sure of is, as long as I don't touch it, it normally keeps working, and I'm not going to regenerate. And that's what a lot of these RAD frameworks used to do. They would regenerate code, but in a very deterministic way. Same input would yield the same output. With AI, we're nowhere near that at the moment. And that's the scary bit to me. But it's maybe because I just don't understand well enough.
Yeah, I think you definitely need to have, like, from the spec, you also need to distill, the test cases and like the test suite. So like the thing can have many stabs at generating code, using different dependencies. Maybe, I've had many cases where the code wasn't changed, but we just upgraded some packages and things break. The whole world was not deterministic. My part was deterministic, but the exterior factors were not, right? And so always being able to like start from the spec, be able to like, assert that the thing produces the right output for the right input is like a critical part of the feedback loop. And if it's not right, you know, improve the model and like have the feedback, right? And, you know, maybe, you know, with all the software that we build, which is not real world AI kind of things, you know, we are like more clinging on to like, you know, this good cozy feeling of like, you know, my little world is very deterministic and so on. On the other hand, I've seen very successful uses of AI. I've been using it for 5 years in the US with Tesla full self-driving. And like, you know, that's a real world AI, and like I don't touch the wheel for the last 3 years. Like barely ever do I touch the wheel in my commute, and it's like 10 miles back and forth, roundabouts, red lights, you know, lane changes, the whole shebang. Like, you know, it's even saved my ass a couple of times with somebody jumping from like a parking spot into the road and just swerved around, right? Like, that's a super non-deterministic world. The model gets updated all the time, but the way it gets validated is by asserting it against all the video clips of all the possible driving scenarios it's seen before, checking that it's going to react in the same way. And if it doesn't, then the model needs to be refined and tuned. So having this big corpus of data to be able to validate, you know, the solution against is super critical. And I think in traditional software development, we don't nearly do that as much as maybe we should, you know, in a lot of places. And yeah, in the world of real world AI, you can just harvest a whole lot of data and like, you know, consistently feed it through the model and see if it predicts the same, in this case, actions for a robot on 4 wheels, right? So I think that's maybe the critical thing that's also missing, is like good ways of like feeling well at night, knowing that the thing is producing new code, but we're still checking that it's actually adhering to the specification and what it's supposed to do.
So you're advocating for more elaborate and more, how would I say this? Like rated test suites to see if the model behaves better or worse than the previous iteration of it? Is that the kind of test suites we're going to be seeing?
We do have test suites like that already. So I work on GitHub Copilot, as I mentioned, and we use benchmarks. We've got both industry-provided benchmarks and our own internally created benchmarks that go through anything from tens of thousands of coding scenarios, and they evaluate the model's performance. Well, not just the model, but the agent that's running around that. We capture all the logs of everything that it's done. We check whether or not it's satisfied the problems based on like deterministic checks. We also have other AI systems that check, do we believe that the behavior that it's gone through matches all of the way that we define what good behavior is. And we get numbers out of it in the end, and we decide, do we want to ship this new model? Do we want to ship this change to our prompts or whatever based on that? But it's a fuzzy thing. It's not like, you know, your normal test suite, you're looking for a green at the end of it, which means 100% passed. You don't look for 99.95 or whatever. That's still fail. But, you know, in this world of fuzzy benchmarks, of course you're not getting 100%. You're going to get 71%. And it varies like randomly between 65 and 74%. And you trying to decide, is that a statistically significant change or whatever? It's a different set of skills than we're used to as developers to think about, you know, random processes and whether we believe that things have improved or regressed. But yeah, that does feel a bit like the world that we're moving into now.
Well, to circle back to the Tesla thing that Bart mentioned, as humans, given an infinite amount of time, we can analyze that situation and come up with the correct course of action. If we're at the wheel, like, it's impossible. Like, the AI will probably have a better context on how to respond to certain things than we will, because we still need to check our mirrors and we still need to look around before we even make the evasive action. Might already be too late, right? So creating the guardrails for that is going to be a very important part of the way that we deal with this. Another thing you mentioned was dependencies, Bart, and I feel like it is the cause of a lot of pain throughout my software development career. And I'm sure that you've all have similar stories. Maybe how do you build a context for yourself to decide whether a certain dependency is worth bringing in or a certain abstraction is worth having, because we're going to get to a point where AI is going to suggest a bunch of packages and dependencies and abstractions for us, and we're going to be the ones judging, like, should I actually be doing that? Like, what kind of frame of reference do you use before you bring in new dependencies into a code base?
Okay, I need a minute to think on this one before I answer.
I'm also super curious about how you two feel about the security of taking all these dependencies. You know, we talk about the supply chain attacks, and we're pulling in just random code from people we've never heard of and putting them into production in billion-dollar systems. Like, what's your mental model for even approaching that?
So I'm going to go back to the days when I was a web developer and I was working with open source software as well. So the frame of reference that I used at that point was, if I have a package that is well supported by the maintainer of that repository, as well as there's a bunch of contributors who are regularly making contributions, then that is something that I can rely on. So that was the first thing that I used to go back to. And of course, the open source software itself, they had their security pen tests done every 6 months. And we as community could go back and say, hey, we have spotted this. Could you have a look at it and maybe fix it? Or someone would have already made the fix by then. So making sure that the things that I bring in are also well taken care of as repositories and products. That's the benchmark that I've primarily used. Then I follow the number of GitHub followers, the stars, how many issues are there, the pull requests, the documentation, all of that. All of the basics are covered. Yes, this has been a past benchmark of reference.
Yeah, I think I'm in a little bit of a skewed environment on the Azure base platform, where we try to keep the number of dependencies super low. And it's kind of a blessing and a curse, right? You know, it's both at the same time. On the one hand, you know, a lot of stuff has traditionally been written in C++. We're now moving a lot of things to Rust as well. And that's by itself a dangerous thing. It's a safe programming language, but it has the blessing of having a good package management system, which means packages exist. In the C++ world, that's kind of like, what are you talking about, packages? Well, you know, we do have that now with VC package, but, you know, traditionally it's just been, you know, almost unsurmountable in certain cases to say, I'm going to take a dependency on this random library here, because then, you know, you're in the weeds for like 2 days, you know, getting the thing to build, aligned with your compiler version, weed out certain issues like integrated files, static linking, dynamic linking, whatever. Like, you know, a whole lot of a can of worms is being opened. Like in the Rust world, going back to the whole AI-driven development too, like we built a whole bunch of tools that are not mission critical, that are like, you know, automatic analysis of like core dumps, for example. And if I can just rat hole on that for a little bit, like in C++, I would still be working on it today, like on that particular tool. But in this particular case, you know, this thing needed to have an HTTP server with a particular protocol called debuginfod, doesn't matter what it is. Needs to be able to read ELF files from Linux, PE files from Windows. Like, if you just ask an AI to do that with Rust, it says, oh, well, there's a crate for this, there's a crate for that, and it just pulls them all in. And, you know, things, you know, literally in one day, I had the skeleton of the service working with like grandma's UI, like, you know, all full HTML. And then some other person on the team actually took it on and said, I'm going to modernize this thing, and then asked the AI to kind of like make it fancy. And, you know, it suggested a whole bunch of JavaScript-based, you know, voodoo to make the UI look nice, right? You know, and I don't know much about that. But going back to the point of like the whole dependency management stuff is, what I've been surprised by is that we have actually pretty good tooling, and I think that exists on GitHub too, with things like Dependabot and so on, that like automatically flag, you know, packages that have vulnerabilities in them, and you have to go upgrade them to the next version. But I think the main thing is really, to be a little bit cognizant about those dependencies. And the place where like I see that happen in the Rust case, for example, is like you have so much choice that there's always good alternatives. Like, you know, the simplest thing of like the parsing of ELF files, there were like 2 or 3 crates for it. And the one I actually looked for was one where I was actually able to do a pull request on their GitHub repo for like something I didn't quite like. And the thing actually ended up being accepted in a couple of days, knowing that there's like, you know, good active maintainership behind it. Is actually super helpful as well, so people can react to things as opposed to, you know, stuff that's no longer maintained. And we've seen that, for example, with, you know, issues in, you know, SSL libraries and so on, where like, you know, it took a long time to actually get things fixed back in the day. So I think, yeah, like making sure that there's a good, vibrant development community is a big thing for those type of things, and then rely on automated tools to like, you know, flag, you know, things that have known vulnerabilities and simply refuse to build or ship or, you know, roll out the system into production if that vulnerability is there. And yeah, then of course you have a hot potato in your hands.
Maybe add on to Steve's remark about security of all this code that we're pulling into our solutions that we're probably not going to look at too much. We've even been seeing, like I read an article last week of somebody being spearphished by doing a job interview, a coding assignment. If they would just check out the coding assignment, it had a Trojan hidden in it. Very cleverly. It wasn't even obvious when you looked at the code at first sight, but it was pulling in a bunch of code from the internet and executing that to steal things like crypto wallet keys. We've been seeing supply chains attacks where our cloud credentials get stolen and people try and take over cloud accounts. I guess we're going to have to weaponize against that stuff quite a bit more in the future now, don't we?
I guess you're right. I'm not really a security guy, so I don't feel that I've, you know, got anything, you know, deep or unusual to say about this. But as far as I'm aware, there's no shortcuts that we've got right now other than to just pay attention a lot, and businesses have to accept that there's a cost of employing people who specialize in security and giving them the time to pay attention to what's going on, look at the dependency changes, critically decide which kind of vulnerabilities necessitate updating for. You know, there's a trade-off, right? In a certain sense, it would be ideal if you just didn't update your dependencies at all, because that way you're not going to get any new vulnerabilities that someone introduces, intentionally or otherwise. On the other hand, if you don't update, yeah, you got different problems. So, yeah, just accepting that you got to pay that cost. I don't know if there's another way right now.
Well, are you taking active measures today when you pull in new dependencies, like make sure that they run in a sandbox first and observe their behavior? Like what kind of measures are you taking today when you're taking on new dependencies?
Well, I can't speak for everyone else's projects. I do know in the case of mine, we've got certain rules about where you can get dependencies from. For example, we can't actually pull packages from the public NPM feed. There's a special, you know, internal mirrored version of it that somehow goes through some additional checking. I'm not entirely sure what additional checking happens there, but that centralizes this work of vetting dependencies to a team that's, you know, specialized in doing that, and then producing another feed that we can treat as if it's the public feed, but in fact it's locked down in some sense. It also, I suppose, creates internal visibility about what the dependencies are. It means that in some central place, everyone knows for sure whether you're using version 3.161 of a certain thing, and they can come to you proactively if they think that there's some kind of problem with that. Yeah, those are some of the mechanisms I know of. Have you guys got anything else?
Yeah, well, in our case, it's exactly the same thing. Like we have those internal mirrors for all the different kind of package feeds where things kind of get blessed and, you know, get kind of like shielded. And that's also where all those security vulnerabilities, when they're known, actually get distributed to all the things that we know that depend on it. So like that's kind of like doing risk management. Then on the other hand, yeah, well, we do have a lot of, in my team at least, you know, all the code that we run is actually running with secure boot and secure attestation. It's all like signed code all the way from the bottom up. So like, you know, we don't run any untrusted code. It all needs to be shipped through our vehicles and so on, and that's actually strong sandboxing, secure, secure from the root up, right? So like, when anything in Azure comes up, it's all certified all the way to a hardware certificate and to certificates of like whoever built it into the product. But that's obviously, very specific to the infrastructure that we are building. But yeah, I do think like obviously it makes a lot of sense to have your code be isolated in some kind of environment. Do all the secure by default kind of things that we've been preaching for a long time. Don't run as root or like administrator, those type of things. And again, like, with things like containerized technologies, you can actually, put a good shield around, where the code is running and put a good sandbox. And like lately I've been mostly in like Unix-based systems with like bit namespaces, user namespaces, network namespaces, where you kind of like lock down the environment that the code sees. Similar technologies exist in Windows and web and so on. So I think that's definitely a min bar, to use these days.
Yeah, internally we do have a process where things get flagged up internally, and if we have to bring in a new dependency, that undergoes a heavy scrutiny internally before we put that into the product base. But yes, we do have a set of internal tools which can flag to us any security vulnerability that is cropping up, so that we can take action straight away. That's the simple, like, one statement summary of it.
I'm happy to hear that, because you're often one of the dependencies that I take on. So it's all dependencies all the way down, right? Now, maybe to close down, because we have about 10 minutes left. One of the things that I feel is one of our preferred ways to shoot our own feet as developers is making abstractions. We could argue that our programming languages are abstractions to begin with, but then we build abstractions in our code over a lot of things. How do you reason about where do I abstract something? Where do I use the dependency directly? How do I build a frame of reference to doing that kind of stuff?
I'll ask Steve or Bart to answer this first, because I could have biased opinion myself.
No, please, bring the biased opinion.
In the past, I have been an end user of a CMS, an open source software system, and right now I am working on a product as well. So in the past, when I have been a developer developing services or websites for others, the path that I've been taking is, I've had people come up to me and say, Poornima, can we actually develop a CMS? No, you should not, because there is a whole bunch of there's a bunch of developers in a team working on this day and night, making the product the best that it can be. It undergoes security pen tests and it is also widely supported, widely contributed to product. So not something that you should be writing. And in fact, there was someone who approached me with a question of, you know what, in my long run, my dream would be to develop a CMS. And I was like, that would be the day I would show myself the way out. I have actually answered this, because that's something that you shouldn't be doing. If you have a product which is widely supported, there's a bunch of developers supporting it actively, then and it's not something that you can do as a one-person job. Think about it. If it takes 100 developers to develop, maintain, and make sure that the product is always secure, it is up to date with the patches, then that's not something that I would go after and do it myself, no. But when I have used the product and there's been certain dependencies that I want to bring on board, because these are nice functionalities that I would like to have on the website, I was like, okay, there is that dependency, but then should I bring it on board? Because it doesn't have as many downloads. It doesn't seem well supported when I go into NuGet and have a look. It doesn't seem to have regular releases, which means that maybe this is not as well known as some of the other dependencies. So there have been smaller cases in which I have written the functionality myself, like a little middleware to go into the ASP.NET Core pipeline or something like that. So use your judgment. If there is a bunch of developers working on that product day and night, trying to make it better, is that something that you really need to reinvent as a wheel? Because in the long run, you would be having a much not so good version of the same thing, where you have spent a lot of money. Of course, it would be a resume-driven development, but what business value are you adding at that point is the question that I would ask.
That's one of those fun struggles, especially if you're a consultant. Like, either I can have them pay me to write the thing, which will be tremendously fun, but the financially irresponsible thing would be to buy the solution that's already out there, right? But yeah, there's an XKCD about that, I'm pretty sure.
And also get rid of the headache that comes with the process of, yes, it is fantastic to develop docs, security, development, maintenance, passing on that knowledge to the next set of developers, because I was a freelancer at one point. How would I make sure that I develop the CMS and then go to the next job and then hand over everything to my, to my mental peace that I've done the best job that I could? That's something that also is upon you as a developer. So yeah, all these things I would think about.
So when we bring in the product and it provides an abstraction for something laying underneath, which is exactly what Particular does. For those who don't know, Particular builds probably the most popular abstraction when it comes to messaging libraries in the .NET ecosystem. Like, when do you decide that I'm going to bring in an abstraction and not use the thing directly? Because I feel like that is has been the cause of a lot of pain in my career, at least, and I see people struggle with this on a daily basis.
Yeah, I don't know that there's any one rule for that. It feels like a question of taste almost as a developer, or of experience, to decide whether the costs and the benefits are going to line up in a way that benefits you, So obviously there's a cost to any kind of abstraction you introduce. You have to think about what the abstraction is. You've got to define it. You've got to define your terminology. You've got to, implement your own interfaces. You've got to write tests for something or other that you've written code now, so you've got to test it. And then you've got to think, does it really model that thing? Is it going to work as this thing evolves and gets new functionality? There's a lot of costs to it. And what have you got on the benefit side? Well, you can potentially plug in other implementations of this thing, or it's easier to test. And those are real potential benefits, but are the benefits strong enough in that case? I don't know that I could provide a rule for when you should want to do that. You can look around you and see, oh, what are the sort of things that people abstract? Well, like databases get abstracted a lot. What else? Do people abstract over, I don't know, like the file system? Not really. Like, if there's an existing abstraction that your toolchain provides for file systems, then fine, do that. But if you think that it's your job to create an abstraction for file system, well, I hope you're working in some very specialized environment, because normal software shouldn't have to do that kind of thing. So yeah, I mean, I don't know, other than just sort of taste and experience, I could say one way or another. What about you, Bart? What do you think?
Yeah, I think it's about keeping yourself really honest about like the value that the abstraction brings. Like, on the one hand, you may be losing like raw functionality of the thing you're abstracting over, and that is often what you see with the least common denominator effect, right? Like, if you look at anything in like system.io for the file system in like .NET, it has to kind of bend both ways to support like NTFS, but also work on like, Linux file systems. And they have certain differences in behavior and so on. And then the question becomes like, well, is the subset, or is the intersection between all the functionality so big that those little things don't matter? Or is it like the intersection is getting rather small, and like you want to get all those specific things of the different underlying file systems accessible in your application, at which point you lose on portability in that case, right? So that's like one of the trade-offs. The other thing is, in our team, for example, We have like abstractions over like orchestration engines, workflow engines, you know, transactional storage for key value stores, those type of things. And when we bring in one of those new abstractions, like, you know, or common utilities, it's always important to have the litmus test that there's at least like 2 or 3 users of the abstraction, that you're not like kind of sitting in your little cozy world, you feel comfortable about your beautiful abstraction, but then in reality, like it only abstracts over one thing, like, you know, so like there's only one thing behind it. And on the other hand, maybe there's only 1 or 2 things using it. So like you don't really get this, hourglass effect where your abstraction is in the middle. There's a lot of stuff behind it, like different implementations, and there are different users of the abstraction. So like the moment you don't have like this n times m matrix, but it becomes like a 1-to-1 thing, then you're, sorry to say, kind of delusional about your abstraction because you haven't really tested it to either abstract or be useful, right? So that
You're just adding interfaces to existing stuff.
Exactly, yeah. And maybe that can have some value in like mocking and those type of things, yeah, sure. But you know, you should in the first place already have good component boundaries to begin with, where like those testing, that testing can take place, and that's not necessarily as low as like abstracting over a database or a file system. Maybe it's like at a slightly higher level, like maybe you're building a configuration subsystem. Well, yeah, then you abstract over the way the config system works, and you can abstract that out to other users as opposed to putting an abstraction on a commonality, for example, yeah, or commodity. Yeah.
Anything you like to add?
No?
There's one that I want to add. Like, I agree with a lot of the parameters that you're throwing up. And one of the things that I always include in my reasoning is how important is this thing when I zoom out on the thing that I'm building? Because the biggest common denominator might be perfectly fine if I'm building a bit of business software and I need to, let's use and service bus as an example. If I need to get messages from one process to another process reliably, it would very much benefit me to have an abstraction because I don't want to care about all the low-level details. If I'm building something extremely high throughput and I need to be able to leverage every bit of performance from RabbitMQ, I probably don't want a service bus to be in the way of that. And that's not an argument for or against a service bus. It's just like, in the thing that I'm building, how important will it be to get access to the underlying thing? And that's only something you can see when you zoom out a little bit and see that as a component in the bigger thing that you're building.
100%.
Yeah.
So yeah, I think we're almost out of time. I want to thank you all for being here. I hope people have gotten something out of our chat. Is there any closing thing that you would like to add to all of the things that we've talked about over the past hour?
Nothing
Message of
specifically.
hope for young developers, maybe.
Well, I'm just really happy to be here at this event, and it's really great to see that people are here. I'm glad to hear that this thing's growing year on year. It feels like we're at a healthy place in our industry seeing this. And yeah, I'd love to meet some of the people at this event and find out more about what you're all up to.
I think we covered a wide range of topics and discussions. I think it was just fascinating to just hear what others are thinking about the same questions. So yeah, I'm leaving this podium with a lot of points to think about and learn about. Lots of keywords personally as well for me.
Yeah, and come to some great sessions. You know, there's also, you know, less, you know, talkative topics, but like more, foot to the pedal and pedal to the metal kind of situation talks, like real deep dive talks. So there's something for everyone here at this conference, and that's the nice thing. Like, you can go at any level, you know, that you would like to go. So
Now you're just promoting your level 666
yeah,
sessions.
I didn't want to point it out, but yeah, please come to my talk.
Thank you all for being here. Thank you all for speaking at this event, and I hope you have a wonderful rest of your conference.
Thank you.
I think we're good to go. Awesome. Thank you for being here. Today we discuss such an important topic for well, everything, not only software development, but it is data. We're going to talk about data in this chaotic universe of the all-encompassing data that is out there. And I'm joined here, I'm your host, I'm Roelant. Hello. And I'm joined here by three amazing people, three speakers here. So I'm joined here by Guy, Marc, and Lisa. And for the people who don't know you yet, could you introduce yourself? Can we start with you, Lisa?
Yeah, of course. My name is Lisa Hoving, and I work as a data engineer. My area of expertise is mainly on the Azure side of things. So I love working with Azure Databricks, storage accounts, and things like that. Yeah.
Cool. So my name is Marc Lelijveld. I work mostly with Microsoft Fabric and Microsoft Power BI. And 7 years in a row, most valuable professional.
Cool.
And my name is Guy Royse. I'm a developer advocate at Redis. I don't know that I have a specialty. I've been a bit of a generalist and touched lots of things in my career. But you know, I think every developer has an opinion on data, because literally if there was no data, then there would be nothing to process. It's sort of the whole point of programming. So like most developers, I have opinions on data.
And you also have a very interesting hobby with linguistics, right?
Yeah, I do like linguistics. I have a lot of hobbies, actually. It's possible I'm undiagnosed ADHD. But the linguistics is something I like to study, just how languages form and evolve and how they're structured. And I have a talk that I did a couple of years ago where I looked at the impact of the English language on programming and how it impacted the syntax and everything. And so well beyond just like the keywords used, but like the word order and stuff like that. So yeah, I try to take my hobbies and then apply them to something technology related, and then I can call it work and I get paid to do it.
Yeah, that now also all comes back with AI, with the things like embeddings and vector databases. Do the linguistics part help there as well, because it's all language, right?
Yeah, I don't know if it does or not, honestly. I mean, it helps me understand it, but I think the models are learning the syntax and the linguistics as a byproduct of studying just mountains and mountains of text. It turns out you can learn things from reading too much Reddit.
And you had your session this morning, right? This morning was about embeddings?
Yeah, it was. I was focusing more on image embeddings, but text embeddings were talked about. They kind of do the same thing. It's turning the meaning in text, or the meaning in an image, or the meaning in audio, or video, or some form of unstructured data, and turning that into a vector that you can then use to compare to other vectors.
Cool. Always bring it back to the data. That's good.
Yeah.
So we have some questions here prepared. So if of course interaction, please do. I mean, I'm only here to facilitate your conversation. So if let's go the way it goes. So we have some questions to just get it jump started. So every company says data is the new oil, but most of them are still drilling in the wrong place. So let's start with the big picture. What is holding organizations back in this data exploration journey?
Well, most of the customers I work with kind of expect nowadays with AI that if they just ask natural language questions to their data, that magic happens, and suddenly they get an answer to that question. But it all starts with proper data governance, knowing where your data is, setting up definitions. Well, the previous topic of linguistics already triggered me a little bit, because in semantic modeling, and what I do a lot with Power BI, adding the linguistic schema and basically defining like what are the typical terminology that you should be using to interact with this piece of data, that's often forgotten and in the past not prioritized by customers. And now they have to if they want to start using their data with AI.
Yeah, definitely. And that, in a sense, you're talking about like data depth, like we have technical depth in software. There's also this data depth. Is this? How can organizations prevent this or remedy this?
So you're asking how they can prevent the data depth, or
prevent the data depth for actually happening, or to pay down. How can they pay down on the data depth to?
Well, I think context is all that matters, and very often documentation was not prioritized, or adding descriptions to what something means in a model, or what something means if you look at the data. And metadata has become even more important than it was before, because that defines the context of which data to use when, if you start interacting with that data with natural language, with AI or any other language model.
And they probably will get into the things of data heritage and the data classifications in the bases, which is a hassle. And all the organizations I've encountered this is with these migration stories from one data store to another, it's always finding data owners. Just the simple, who is going to take ownership for this data and who's going to classify it, it's almost impossible.
Well, I think it already starts with what is data ownership. Most of the companies don't have that even defined. They don't even know what a data owner is and what they're supposed to do if they are assigned to be a data owner.
Yeah, that's strange. Is there anything you want to add to this?
I have a slightly cynical thought. You're asking, how do we pay down data debt, in an organization, or how do you avoid it? And I cynically kind of look at our track record of doing that with other forms of technical debt. And I think the answer is that we're not going to.
Or we're going to use AI to do it.
Yeah, we'll just spend a lot of money on it. We'll spend more money than is necessary, and projects will be harder when they don't have to be. Maybe I'm a little too cynical, but I've just seen that pattern a lot, and you're smiling, right?
Yeah, that's true. I think that is the practice where we all have to deal with. But also, are there tools available? I really don't know. But to make this, to have the insight into your data depth, what is your gap in classifying your data, or?
But is that kind of depth avoidable at all? I'm not really sure, because as the world develops, these kind of depths kind of arise. So it's also up to us as developers or as engineers to keep putting time and effort into clearing that depth and to really tackle that. But yeah, when it comes to knowing what kind of technical depth you have, for the company that I work for, we use Calibra, which is on and off good, if you get what I'm trying to say. Yeah, you need to do a lot of handling for that, for sure. Yeah.
It's a lot. So there's still humans in the loop. There's still room for us as humans to have a job and to actually interact with data.
I would surely hope so. Yeah.
I'm pretty sure there is. I very often, because I work a lot with customers that are coming from a background of reporting and dashboarding, and they ask me all the time, like, so do you think the future is going to be that we just interact with data with chatbots? I'm like, no. Yes, it is going to be in the future, but it's not the only way that we're going to do. We will still have reports and dashboards. You will still have your monthly report that tells you how your company did financially and all of that. You're not going to solve everything with AI, so I'm pretty sure we will still have a future to work with data ourselves.
Interesting.
I think we have another thing too with, I was just thinking about the data debt. You've got patterns and anti-patterns in software development, and some of the anti-patterns took us a while to identify, just like it took us a while to identify the patterns, because we had to have enough sort of global knowledge in how this thing works to recognize that it's even a problem yet. And I think there's probably data debt patterns that we haven't identified yet because we haven't gotten to like that critical mass where they're obvious yet. And so I think, because some of the tech debt that we inherit is not that people were irresponsible, it's just that it was not obvious looking out 20 years later that was going to be debt. And now it is. And we're going to have the same pattern in data.
But is that necessarily a bad thing?
I think it just is a thing. I mean, it's just kind of how it is.
Yeah, it's
which is why we'll continue to have jobs as developers or data, as technologists. I think that would be a better, more generic term, because that problem is not going to go away. And you can kind of put LLM on top of LLM on top of LLM, and keep kind of trying to, but there's always a person at the top of that stack.
Yeah, with so much probabilistic nature of things, you're sure things are just going to hell there. Yeah. So
you can't trick me. It's LLMs all the way down.
No. Was it last week the AWS outage? It was last Monday, right? So
yeah, our Alexa stopped working. Yeah.
Yeah, almost everything stopped working. So we saw a lot of impact of these services and AI, or not even AI, other services just stopping working. But do you have advice for software teams? Should they rethink their assumptions around data availability? And especially in regard to Redis, probably you have something to add there?
Well, I do think, actually, my thoughts there are not so much about Redis. I think there is a degree. The example that's coming to my head was the bed. Did you hear about the automated bed? That it had to have the cloud to function properly. When it didn't have the cloud, it just turned the temperature sensor, the heating in the bed up to max. And, and so people got woken up in the middle of the night at and it's like, why is my bed 120 degrees Fahrenheit? I don't know what that is in Celsius, sorry.
Oh my gosh.
Really hot, 50 maybe, you know? And so thinking about, about you can put Redis in front of things to make that reliable, but for like an embedded device like that, you're not going to put Redis in your bed. Right? Bedis, I guess. But there are ways that where you can use Redis. Like we've had scenarios in production with Redis where I've heard this from multiple customers. They're like, we didn't know our database was down for 3 days because Redis was in front of it. And so you can guard against some of these things using that, but usually you're deploying Redis in that same cloud and it's going to go down in the same way. And so that outage is, so the real solution there is, I think as developers building applications that are tolerant of network failures and aren't so tightly coupled to that. And also multi-cloud solutions, which is what everyone starts talking about every single time one of these outages happens. So it's like, oh, we need a multi-cloud solution. And then lots of people stand up and say, we'll sell you a multi-cloud solution. But I think fundamentally Redis is in that same cloud, and so it doesn't help unless it's running somewhere locally.
But to be honest, how much customers do you actually have that run multi-cloud solutions?
Not very many, yeah.
Yeah. So
exactly.
if
well,
one of the clouds
everyone,
go down, then they're screwed anyway.
Well, and I mean, the US East 1 going down for AWS is the poster child for this pattern of people can't even bother to put it in the non-default data center, let alone think about multi-cloud, you know.
Of course, you can. I have a lot of customers that prioritize things like they want to make sure all their data is replicated to another data center as well. And I think that completely makes sense. But in the case of the outage of AWS, like it went completely down. Like, there's nothing you can do against that other than replicating to a different cloud vendor.
Yeah, but then you have your data, but nothing to act upon it because your solutions are probably in the other cloud.
Exactly. And I always tend to say to customers that start a conversation about this, like, okay, sure, you have your data, but the companies you work with as a company, they're also down. So you're not going to get any new data in. So good luck with your data, but you're not going to be able to process it or do anything with it.
But at what point do you think you should look into going multi-cloud then? Because I know for the company I work for, we do have multi-cloud, but that's more related to the technical depth side of things, so not really to fall back. But I kind of feel like if my jobs aren't running for a day or maybe even a week, I'm not sure if I dare to say, like, I mean, they say they want to have it real time, but do they really care so much? Yeah, I don't think so.
I always tend to ask them, like, so what if it doesn't run for a day? Who will die? Probably nobody.
Not where I work, no.
No. So if you work in healthcare, sure, might be a different story. Any of the critical industries, I think they should care about multi-cloud and making sure that they can just fill over to a different cloud vendor if they need to. But for the majority of companies, it's mostly a lot of cost and a lot of complexity that they don't need.
I think there's this might be a slight tangent, but I'm going to go here anyhow. There's this idea of the local first software architecture. And the best example I can think of that is Obsidian. So everyone's using Obsidian, it seems now. And it stores all your data locally, but then replicates. And so there's ways that you can do that to keep your data resilient so that your apps can still function. But then when the network comes back, it can sync. So using like conflict-free replicatable data types and things like that are ways you can hedge against these sorts of problems. And, because it's going to happen again. I think you're right. Lots of times we think we need more. If you ask some vice president, do we need it to be real time? Like, yeah, we want real time. Real time's amazing. That sounds badass. I want that. But in reality, it's like, do I really need a real time to-do list? No, I don't. I mostly need my to-do list to be on my computer in my house. And then if I can sync that across my devices on the cloud, that's fantastic because sometimes I have my phone, sometimes I have my tablet, sometimes I'm at my computer. But if that doesn't work for 4 hours, then I'll just go to my computer.
Yeah.
And talking about real time, the never-ending discussion that always comes up is like, yeah, we want to have everything real time. It just needs to be there. But in the end, you're always as slow as your slowest data source.
That's why you should use Redis.
Still, your slowest data source is going to define how fast you are.
Yeah, usually then your network usually becomes your bottleneck at that point, yeah.
Yeah, and in the end, of course, costs come to play as well.
Yeah,
Because
yeah.
if you're going to say on real time, well, it's going to cost this. Okay, near real time is good enough.
Yeah.
And then other...
Are you suggesting that RAM is more expensive than disk?
Almost,
Craziness. Yeah.
That's what happens at my company, at least. And we say, okay, you want it real time? It's fine. It will cost a little bit more. And they're like, no, once a week is fine. Yeah, that's fine.
And you actually do your session is about how expensive Databricks can be, or at least how to make it not so expensive?
Yeah, so that's the thing. A few years back, I did a workshop in Copenhagen on building a data lake for my pet python. I have a pet python. His name is Fluffy. I mean, you already know that, but other people might not. So he's about 1.5 meters long now, which is totally beside the point. And I built him a data lake on Azure using like the telemetry data and sensors. And I was loading that data real time using Databricks Autoloader, which is like Spark structured streaming, if that's what you're into, but then a little bit different language. And what happened was I did that workshop, and then I was a little bit tired, and I forgot to switch off my Databricks cluster for 2 days.
Ouch.
And yes, you know where this is going. The bill was about 900 euros, and then I thought, that's quite a lot. So in that workshop, I'm trying to decrease the bill step by step.
That's part of it. And your session is at 4, 4:15?
For tomorrow. So there's...
Oh, sorry, tomorrow. Sorry,
Yes.
so Wednesday, tomorrow, so you have all the time in the world. Yeah,
Exactly, yeah.
for everyone here, so 4 tomorrow. And then if we're now doing sessions, because when was your session?
My session is today at 5:15. And I'm doing a talk about data modeling 101. So it's really focused on semantic modeling for Power BI to get the best performance, and what are the do's and don'ts basically in semantic modeling.
It's good. It's very important, especially for like software developers not really into the data modeling things, to have those basics and the fundamentals. So I'm looking forward to the session. I'll definitely try to make that one.
Yeah, exactly. Because I would say like data modeling in itself is a very broad topic, but data modeling for analytics is a different story than data modeling for applications.
Definitely. Yeah. It's an entirely different beast. And Guy, you also have a session tomorrow, right? And I think it's during the same time slot as Lisa, so you're making us choose.
Really?
Yeah. My talk's at 4 o'clock tomorrow as well. Yours features Pythons?
Yes.
Not Python, but Pythons. Or both.
Probably both, yeah.
Por qué no los dos, eh?
I mean, what better language to program for your Python than Python?
And I got to admit, Fluffy sounds like a name of a Python library.
Yeah.
And if it isn't, you totally need to make one.
I could.
Yeah.
Yeah, that's a great idea. Yeah.
My talk is going to be about UFOs.
Oh.
It's about probabilistic data structures, which it's a talk about data structures, but the probabilistic ones where you can sacrifice accuracy to get orders of magnitude improvement in scalability, both in terms of like space complexity, how much space you're storing the information in, and how much and time access. So you can get like store 1 billion things and get O of 1 operations against it, even though there's 1 billion things in it. And they actually are really quite interesting data structures, but you sacrifice accuracy to get it. So they do things, they'll lie to you, and they won't be truthful all the time. But they're true enough that for the scale.
Like an estimation?
Kind of. So one technique is you can do like counting unique items. So you say you want to count unique viewers on a YouTube video.
Mm-hmm.
You could just add each user to a probabilistic data structure and then say how many things are in there. And it will give you a number that's like 98% accurate, which for small numbers, it's going to be perfectly accurate. And for large numbers, it's like, well, if I have 1,000,007,000 or 1,000,009,000, that's close enough. I don't care, right? And so it solves those sorts of problems. But if you wanted to get an accurate count of 1 billion unique users, you would have to do something like select star from users where, counts, and that's not going to work, right? And so when you need to scale up, these probabilistic data structures are there. Like if you're, say, Facebook and you need a unique username. Well, Facebook's got, what, 1 billion users or something like that? I don't know how many of those are bots and how many are real, but it's got a lot of them. And those, if you need to find if a username's taken or not, you can't just select from the database and see if the username is available or not. You need to do something else. And so these data structures solve those sorts of problems.
Oh, that's awesome.
Interesting.
Yeah.
Good. Well, definitely. Well, we have to choose, but maybe we can do.
Life's full of tough choices. I'm sorry.
It's true. It's true.
So let's do another question of the amazingly list of questions that were prepared for us. So if it's a smart question, it's definitely my question. If it's not a smart question, then it's someone else's fault. So data lakes, warehouses, lake houses, meshes, fabrics. We've gone from simple pipelines to usually full-blown enterprises and ecosystems. How do you make sense of what to choose what, and just how do you keep up with all these things changing?
You don't.
You don't.
I was going to say the same thing.
That's kind of the answer, yes. Every day there's something new, and when you learn something new, you're already behind again. So you kind of don't. You just look at the use case you have and then find the best to your knowledge what you should be using at that point in time.
Yeah, but usually the data structure is always very proven. Like the data is where we base all our actions on. These are the facts we act upon. And for things like AI, we can go nuts and we can use every new cool thing because it doesn't really matter because we're not using these things in productions. But these data structures and these data sets we are. So I can imagine you can't just go head first for the new best thing.
I'm not sure though, because when I started data engineering, I put a lot of thought into that, like what is the most effective tool for what use case, and I even did workshops on that at some point. But if you think about it long enough, you kind of figure out that a lot of these tools, they have overlap in functionality, even on just the Azure platform side of things. And then you can do, with one use case, you can use maybe 3, 4, 5 different tools. And then you kind of sit down and you think to yourself, well, if it's cost effective and I know how to maintain it and it works, then it works. Yeah, that's how I usually go about it.
It very often comes down to cost of ownership and performance, I would say.
Yeah, true.
Because I can store structured data in a Fabric warehouse, I can store it in a Fabric SQL database or just an Azure SQL database. In the end, it will give me the same result. I can just query that with SQL or any other language I want to. But depending on the use case, one might perform better or has a lower cost of ownership than the other has. So it's also a matter of priorities. So I'm going to give you the consultant answer. It really depends.
And Fabric now has been around for, what was it, 1.5 years, 2 years or something?
2 years, I think.
About?
In November 23.
Because you do a lot with Fabric, I think?
Yes.
Why is the ramp up so slow? Is this because of the same reason that it is new? And
I would say, actually, I don't think it is slow, to be honest, because I tend to compare it to how Power BI started 10 years ago. Power BI was also not from one day to another having 10 million users. It also took some time. There were some errors in there that where you think like, well, they should have prevented that. And that's the same pattern I see with Fabric nowadays. Like, there are things that are not perfect, and you have to make your way around that, work around it, do some. Every now and then, you use some Azure technologies outside of the software as a service that Fabric offers, just to get your job done. And you create technical debt, definitely, but you also know that you can just list it down, put it on your backlog. Like, once Fabric is able to do it, we can solve this. Probably you never will, but you can put it on your backlog.
Yeah.
And I think one of my first Fabric projects that I did was typically where we had this, the challenge, like we wanted to connect to on-premise data, but Fabric pipelines were not able to use gateways yet. So we could not set up a gateway or an integration runtime to get to that on-premise data. So we ended up just using Azure Data Factory, creating additional Azure costs. Microsoft should be happy with that. Just to bridge that gap between on-premise and Fabric. And in the end, we landed that data just in one lake, which is essentially just data lake storage. But we landed it in Fabric to further process the data in Fabric. So I think there are always some minor things where like, it's not perfect. and probably will never be perfect because we are defining the requirements of where Microsoft is going. So we are defining the things that we want that are not possible yet.
Yeah. Good point. Yeah. And what is the coolest thing you've seen, like in the past 6 months, data-wise? What did you spark something, made you very happy?
Oh, that's a good question.
Oh, I can go first then. Of course, I'm biased to the area of the work that I'm doing, but I'm really excited about two things in particular, and one is Fabric Data Agents. It's basically both an MCP server as just the chat interface that you can interact with to ask natural language questions to your data, but you can also position it as an MCP server to AI Foundry or to Copilot Studio or any other technology you want to use to interact with the data that lives in Fabric. That's one that I'm really excited about and really in the area of AI. Another one is Fabric Semantic Link, and I think most of the people have never heard of it, but it is actually a Python library that only runs in Fabric notebooks, but it allows you to programmatically interact with your semantic models and to script a lot of things that usually will take you like 15 mouse clicks. And I know I need the pattern again tomorrow, so I'm just scripting it and then just creating a notebook for it.
That's good. That's actually two things you're very excited about. So, anything for you?
Well,
Anything, Spark?
I had some time to think about it, of course. There's one thing that I was really excited about that I saw a week back, and it's really specific. But for Databricks, when it comes to cost, one of the things that makes it really complex is that you don't only pay for the usage of the cluster, so the DBUs, but also for your virtual machines and everything that comes with it, of course. And one of the things that Databricks does with Unity Catalog, which is really great, is that you can monitor the usage, but it's only on DBU side of things and not on the VM side of things. So I saw a week back that they created a new table where you can actually monitor those things, but it's still in private preview. So I'm really looking forward to that becoming more like public preview and
You're
seeing.
actually searching for the private preview list now.
Yes, because if you monitor the cost on Azure, it will be there in like 48 hours max. And for some use cases like mine, for example, that's too late. So yeah, really looking forward to
Interesting.
that. Yeah.
Looking forward to that. For you, this is of course a perfect to plug in a new Redis functionality.
You know, I hate to sound like a shill, and I will say that I'm going to totally sound like a shill here, but this is a legit opinion. So we just released this new product called Langcache, and the idea behind Langcache is it's not honestly that complex of an idea, but it's the idea that you can use some sort of caching mechanism like Redis and front it with use it as a way to cache LLM responses. So if you ask something of an LLM that is semantically similar, you can cache that response and then return that cache response. So for example, if I ask, why are my photos blurry, then the LLM gives me a response, and then we wait a few seconds, the LLM responds, right? Whereas with Langcache, you can say, why are my photos out of focus? And now that's been cached already, instead of why are my photos blurry, why are my pictures out of focus? It's the same question semantically, but you can use the embedding of the question to cache the result of the LLM and then return cached LLM responses. And we've productized this, and it's on Redis Cloud and everything. And I think that's really cool. But I think the idea is actually the more interesting part, because this isn't rocket science, right? You're literally taking a prompt, you're creating an embedding, and you're storing the response in some sort of fast data store. Redis is an obvious candidate. But yeah, so that's the thing that I've been most excited with lately. The thing that is the challenge with this, I think, is that if you've got a conversation history with an LLM, the cacheability of its responses drops off pretty quickly because that context becomes part of that. And then you just get such a unique place that there's no point in caching it. And so I want to play, I'm going to play around with, but I haven't yet, the idea of asking the LLM if its response is cacheable when it also gives me the response. So give me a response and tell me how cacheable you think this is, or if it's cacheable.
That's good, yeah.
And then cache it based on that. And you know, maybe that'll work, or maybe it won't. Well, you know, I'll find out. But so that's a pattern that I think is kind of really cool.
Did Redis already have a service for like LLM agent memory? Is that something?
We have one of those as well. It's called Agent Memory Server. Nothing but the most imaginative product names, right? And actually, one of my coworkers, Andrew, wrote it. And I've been playing around with it and honestly trying to figure out how to get it deployed to Azure and get it to work, because it's a Docker image. It exposes an MCP interface. It's got just a simple REST interface, so there's some Python libraries. And it uses that same capability to store your history of your conversation, and will automatically compact it once it gets beyond a certain size, and will automatically extract significant facts from that conversation and store them as long-term memory. And so that's another thing that we have. And thank you for letting me show all our stuff. It's fantastic.
No, but it's very
You're a
interesting.
fantastic
and
host.
So now I learn as well. So that is, but and this is, we're now going almost off rails for this specific, very specific topic. Right? But are those embedding models? Are you using your own like embedding models, or do you provide can we provide our own embedding models?
In the case of Agent Memory Server specifically, you can provide either an Anthropic API key or an OpenAI API key. I don't think you can bring your own models into that. It is open source, so you could certainly fork it and then bring in your own models. There's probably really no reason why you couldn't use like even a local model that's not in the cloud. It's not configured for that, but I don't think changing the code to do that would be a monumentally difficult task.
No, the other models are fine. That is.
Yeah. You should be able to make it work with Olama. Yeah.
Good. Turning data into decisions is the holy grail, but also the hardest part. There's a huge gap between what's possible and what's actually used. How do you bridge the gap between data engineering and business insight, making your data actually actionable?
I really believe in teams where you're close to the consumer, let's say. So for the company that I work for, that's a really difficult task because we are huge, of course. But still, if you can be in a position where you are very close to your consumers, or even within the team of people creating the dashboards and creating the insights, then that for me would be perfect.
To add to that, I think it's crucial that the analyst, or whoever you call that person, that's building the reports or the dashboards, that should be in the same team or very close to the data engineers preparing the data. If they're too distant from each other, then you end up with suboptimal solutions built in tools like Power BI, Tableau, or whatever you use, because they're doing a lot of data transformations and data cleansing there, what should be done in the platform, what should be done by data engineers. And if you then ask me how you turn it into actual insights, and probably the next thing is going to be turn it into action, that's the point where very often reports and dashboards contain by far too much content. It's like, oh, we have a little white space here, let's add another visual. Oh, we have a little gap here, let's add another pie chart. Don't. Just focus on what matters. What is the key thing you need to see to make a decision to scale up your sales team, to whatever your business is and whatever you need to do. Only focus on that key thing that lets you make a decision. All the other stuff is just clutter.
Valid point, yeah.
I don't know that I have anything to add, so.
And how do you think AI will change this? Because we've been creating reports for decades now, and now we have just a chat interface to get trends and to pull our data out of that. But how do you see this market developing?
Well, if you ask Microsoft employees how AI is going to help you in this area in finding patterns, they're probably going to all shout Copilot. I think it's in their contract that you have to answer that. To be honest, I'm not too big of a fan of Copilot, basically because it always comes up with kind of useless patterns as well. Like your index or your ID is trending upwards with your over time. No shit, Sherlock. I could have imagined that myself as well. But those kind of insights also appear. And I think if you use AI to find these insights, the crucial thing is going to be that the person looking at those insights, that's the person that needs to judge whether it is valuable or not, and whether that's actually the insight that you're looking for. Because we all know that AI can also hallucinate and come up with random things every now and then.
I think what you're describing is a little bit of the killing a gnat with a bazooka, right? So, like you said, the line goes up. No shit, Sherlock, right? You don't need an LLM to tell you that, to parse the data. You don't need to, here, let me hand you a big pile of structured data, tell me a story, and it says, oh, the line's going up. It's like, there are tools that do that already, and I think this is sort of, there's a broader point here where we have this tendency to use the golden hammer to solve for all the cool problems, and you point at that without saying it, which is that, lots of times for the analytics, for the things you need to see, maybe you don't need an LLM. You don't need to use AI to solve that problem. There's well-established tools that solve a lot of these problems. Use it for the thing that it uniquely can do.
That's a good point. Yeah.
To add one more thing to that, I think analysts and people that, typically business analysts that understand the business very well, they are crucial in this part, because whatever the output of an LLM or a report or a dashboard is going to be, whether you talk about a visual on a report or you talk about the output of an AI algorithm, it's always up to the person interpreting that result. And you can only interpret it correctly if you understand the business behind it.
Well, it's exactly the same pattern when I'm using it to code. Like, it'll generate a bunch of code, and if I just vibe code and ignore it, then I get what I deserve. Right? and I have to look at what it generates and say, nah, that's wrong, that's wrong, that's wrong, or you don't see the larger picture, you're guiding it. I think you can sort of come up with this pattern of vibe analysis, where you just throw the AI at the data and it spits out an analysis. It's like, yep, let's go. And it's the same, it's the same pattern.
Fingers crossed and hope for the best.
Yeah. But I think we need to say, just let everyone know, today, right here on the stage, we coined the term vibe analysis. So.
Yeah, this is where it all started. Yeah.
Yeah. This is where the stuff is happening.
So we still need data analysts and scientists in the loop. That is what we're saying.
Just like you need a developer in the loop when you're coding. Yeah.
Definitely. Yeah. With the amount of data, how fast data is growing, so it's faster than we almost can comprehend. If we look a couple of years ahead, where is this all leading? What will define successful data-driven organizations in 3 or 5 years' time?
I think knowing what you need and really defining, like, okay, I have this project, I want to achieve this, and therefore I need this and this and this. I think if you don't know how to do that, you're never going to be successful.
I'm not sure I have much to add to that. I think everything around us and everything we own as human beings generates data in some way. So there's way too much data, and it's all coming down to being able to find the right data to serve your needs. Which brings me back to a topic we mentioned before, data governance, data cataloging, knowing what it is, what the quality is, where it is, etc.
If you have it and you don't know that you do, then you cannot use it for sure. Yeah.
So I have a good friend of mine who's an attorney, and he said that data is kind of like radioactive materials, like particularly customer data, like information about people. And now he works in healthcare in the U.S., and so the personal information privacy laws are a pretty big deal, and if you break the fines are very significant. So part of his job is to say no, right? But he lots of times will keep data that we think could be valuable, but the value in it is not anywhere near the risk of if it gets out and it gets hacked, or there's just a risk associated with having too much data on individuals as well. I'm not going to go down the whole, they're tracking me sort of path, but although they are, but that volume of data, it's like, well, we use this and we can do this extra thing. Like you said, we don't necessarily need all of it. What are our goals? We need to keep enough data to serve those goals, but not any more than that, because there's a risk exposure there as well.
That's a good point. And
sorry to bring up lawyers, by the way.
And we saw, of course, data breaches are of all times, but we've seen a couple of huge ones in the past couple of weeks and months. What do you see? What is your experience that organizations are lacking, are not doing in regard to governance, in what they should do? What should they start doing immediately?
Well, let me start with, obviously I'm not going to mention the name of the company, but I recently encountered a situation where a company said, like, well, yeah, we're an ISV and we have a lot of data from our customers as well. And what they actually said was like, yeah, but by contract we have 3 days to fix it if there's a data leak. I was like, well, you should prevent the data leak, not just saying we have 3 days to fix it.
And how can you fix a data leak, right?
Well, figuring out what the gap is that they should close, but the data is already out there. It's already gone. And they said like, yeah, but we put it in a contract that we took our responsibility to deploy the fix and make sure it is protected after that. But in the end, I think it all comes down to taking it seriously, and it is a serious topic. You should always prevent things from happening instead of just putting on the fire hose when it happens.
I think we can also use some transparency so that we can really learn from one another when something goes wrong. Because, to be honest, I was part of that breach in the Netherlands with regard to cervical cancer. And nowadays I get like spam calls all day, every day on my phone, and it really, really sucks. And it's not just my phone number, obviously, but also my BSN number. And what I kind of found was that I wanted to know, like, but what exactly went wrong, and where did it go wrong, and so that I kind of know what is going on. And also, as an engineer, I'm curious. I want to learn from that, but they don't provide it. It's really difficult to search that. And of course, I do see some people talking, like Martijn Goed, about this breach and how that worked, but it's not really public knowledge or, for me, easily searchable on the internet, and I think that sucks.
It was this cool example of how not to disclose, because I think they kept it silent for days, and then they said, well, it's only a couple of users, and then 3 weeks later, it was apparently the entire user base and the entire database has been leaked, and that was very privileged data. It was sensitive data in there. So
really, yeah.
I honestly think that government in these kind of examples should lead by example. To tell you a little story, if you're a freelancer in the Netherlands, I'm not, but if you are, and you sign yourself up for taxes and everything, you get a number, your tax number. Guess what? That's actually your social security number. I think that is awful.
That's crazy.
They should just assign it a random number and not use your social security number for that.
Yeah, I never knew that. Good point.
I think that a lot of these leaks are too, there's, particularly in the US, is that it's an externality that doesn't cost the company anything. I mean, it does, but not commensurate with the benefit of having that data in the first place. And so, well, yeah, we'll fix the leak and we'll disclose it. And then it turns into, oh, we're out a few $1 million, but we made $1 billion, so it's okay. And so I think, honestly, there's a legislative aspect to this as well, where you need laws where there's penalties so that externality is not free or cheap or effectively free. Now, sometimes they're not. I mean, sometimes they're a very big deal, and lawsuits happen and all that. But I've gotten, I don't know how many times I've been part of a data breach. And what I end up getting is an email, maybe there's a class action lawsuit, I apply for it, and I get a check in the mail, 2 years later for $5.
Yeah.
And then they give me 6 months free of some sort of identity theft protection insurance, a thing that monitors, and then, which is great because I never had to pay for identity theft, monitoring services, because there's always a breach every 6 months, and so it renews. But this isn't costing these companies a ton. And I think that's, not that I'm down on big companies or anything like that. I mean, I work for a company. We all work for companies. But I think there is an aspect of just accountability there. And I think kind of what I said earlier, too, about maybe you shouldn't keep that, because if it gets out, that there is a cost to that. So it kind of goes back to that a little bit, too.
Yeah, we do have the legislation here in the Netherlands that you have to disclose, and of course there are penalties, but still, companies are just not disclosing because they fear like the reputation damage.
Yeah.
And, yeah.
I'm just waiting for. I think the IRS in the United States had a leak not that long ago. That's everyone.
Yeah.
Or we had a major healthcare provider. It was in the news. I'll name them. They're not a customer or anything. Called Anthem Insurance, and I mean they got like I think everyone that has a job that has health insurance in the United States has had Anthem at one point in their life. So it's just a data breach for everyone. And
it's also almost impressive how they got that data sent out there, because that's huge, probably.
Yeah. I mean, I know that all the social security numbers in the U.S. are out there and available.
Yeah. But any things come to mind? How can we make the world a better place in regard to this topic?
Yeah, maybe I'm a bit naive, but I always like the idea of if you just disclose it and if you're just honest, then we together can learn from it. Maybe that's a bit of the indoctrination I got from the bank that I work for, where they say, yeah, together we learn and we learn from our mistakes and you can disclose it and stuff like that. But yeah, I truly believe in that.
And it, of course, starts with insight and just knowing that it happened. So it's a good one. Let's see. We still have 12 minutes. So let me get an amazing question out here.
Did you go through all questions?
Well, I'm just browsing. I want to talk to you guys and not read the tablet continuously.
Well, you're doing a great job.
I'll also just.
I was serious. That wasn't meant to be a joke.
We could do the closing thing, and you will just take 4 minutes to answer, and then we're perfect. So, if you would have that one piece of advice in regards to either this topic or in general, it can be, if it's valuable advice, we're not going to limit you to the data topic. So what one piece of actionable advice can you give our viewers and the audience here?
I'll go first here. And it kind of relates to what I'm personally doing a lot. And my advice is centered around how do you stay ahead of all this or keep up with all this technology, and how do you make sure that you can also learn while you might not be on a project that allows you to work with that new technology. Because maybe there's something new, in my case, something cool in Fabric, but and I want to learn from that, but my current project doesn't allow me to because that's not in the scope of the project. What I started doing up till a point that my wife's a little bit annoyed with it every now and then is literally automate everything in my home. And every single click of a light switch generates a point of data. The whole home automation thing is for me just a source of data, which kind of explains my behavior. What time do I arrive at home? I can bring in some external data, like the weather forecast. Is it that I switched the lights on earlier if the weather is bad, or those kind of things? It kind of gives me a data set to play around with, which is not super sensitive. So I can also use it for demos and inspirational sessions to my colleagues. But I think what for me is really crucial is, and an advice to everyone, find that data set that's familiar to you, that you are very confident with, and you know exactly, like if you try do something, then you see, okay, this is correct or this is wrong. But it allows you to have a data set that you can just play around with. Try that new technology. If you see something cool that's recently announced, or what Lisa just said with a private preview, you really want to try it out, you have something to test it, instead of waiting till that one project comes along, which can still take a year or two.
But what kind of tools do you use for this, I wonder? Because, yeah, not everything is as cost-effective as the other tools. So now I'm kind of curious, what do you use?
It's definitely not cost-effective. I recently, I'm still in the middle of a renovation of my home, and I don't dare to count yet how much money I spent on home automation.
I feel the same, yeah.
But I'm kind of locked into the whole Apple home automation system, so I have HomePods all around my house. But all my lights are now Philips Hue lights, but also all the windows and doors have sensors, so I can see exactly when a door is opening and closing. Up to a point that recently, and this is definitely not marketing, I have nothing to do with them, but Philips Hue released a new bridge, and that bridge allows you to have 3 lights in one room, and those 3 lights are in continuously communication with each other, and they're measuring the signal strength. And if that signal strength is suddenly dropping because somebody walks through that signal or walks into that room, that's acting like a motion sensor.
Cool.
Oh.
So I saw that new announcement, and it took me like 3 seconds to order that new bridge.
Are those Hue lights, are those still Philips, Dutch company Philips, or is that?
Yeah, I think it's part of Signify or something, which is a company behind Philips that is developing these lights.
And to bring it back to the data, because my mother is almost 80 years old now, so she wanted to buy a new TV. So I said, well, just buy Samsung or Golden. but she ended up with a Philips. So I installed that for her. But that was the Chinese bought Philips name. So to bring it back to the data topic, you had to agree that your data was shared with 982 different companies, and you had to turn them off one by one.
Oh my gosh.
Yeah, what I did to prevent those kind of outgoing connections, and then I will stop with my topic to give the others room as well. I set up a separate Wi-Fi network in my home, on which my home automation is running. And for that separate Wi-Fi network, I just closed all the external outgoing connections.
Smart. Oh, very good.
Well, I have a fun data source that I like to use. So I'm an amateur radio operator. If you're an amateur radio operator, my call sign is Whiskey 8 Golf Uniform Yankee. And so I've got a ADS-B antenna on the roof of my house and a software-defined radio, and I can take aircraft transponder signals. And it's on like a 25, 30-foot mast, so that'd be like, what, 10 meters maybe? I don't know. I don't metric that well. But, and so I'm able to pick up things in the entire state of Ohio where I live, which is, a fairly good-sized state. 3-hour drive in any direction to get to the border. I can gather all that transponder information from the aircraft, their heading, their altitude, their speed, their flight identifiers, all that kind of stuff. And that's and I pick up about 500,000 transponder signals an hour.
Cool.
Which is a lot.
Yeah.
And so if I need data, that's a really fun and interesting data set to use. And I've used that in demos for talks and stuff as well, because it's something that everyone can really understand. Because to your point, you need a data that's in a domain that you understand.
Yeah, agreed.
Yeah, I saw an interview with someone we're talking to at Redis. No spoilers, but she used like her personal health data for her examples, because it's something that she understands really well, and so that familiarity with the data, understanding that domain is really important. And an aircraft is something that I fly a lot, so I feel like I understand that fairly well, and it's fun to see it's also kind of fun to watch the flights go overhead and everything, and you can mix that with weather data and all sorts of stuff in really interesting ways. So, not quite the thing you're asking for, but it's another fun data source. So
that is good. But there was one of my questions, because of course we had Fluffy and we had home automation and now aviation. So
yeah,
that's good. Do you have any actionable piece of advice you want to give the viewers?
Can it also be like more soft skills?
Of course.
Of course, yeah. So next to more technical topics, I mean, you mentioned the ADHD side of things previously. Yeah, I also have ADHD, and I'm also autistic, and I give talks on that as well, on neurodiversity. And very often I have people coming to me that are neurodivergent, and they're like, hey, I kind of feel like I'm in an environment where it's not very welcoming towards me, or people don't really understand. And one of the things that I always tell people is that your career, in the end, is up to you. So it's up to you to put yourself in the place where you can shine and people appreciate you. And the unfortunate thing is that sometimes if people don't want to listen, you cannot make them listen, which is very unfortunate. So if there's one piece of advice that I could give people, it's like, if you feel like you're in a place where you're not appreciated, put yourself in a different place. That's what I would say.
It's very good advice. Yeah.
Very deep, yeah.
Thank you.
Sorry, I made it awkward.
No, I have nothing to add to it. I was just listening and agreeing.
I haven't been diagnosed with ADHD, but my son has. And when my son was growing up, he's 20 now. I have 3 sons, but he's my middle son. He's 20. Or no, he's 22, sorry. I got a 19-year-old, 20-year-old, and 24-year-old. So the 22-year-old, my relationship with my wife got better when she realized he did the same things that I do. And she realized, oh, you can't help it, can you? So while I haven't been diagnosed, he has, and I'm just like him. So
it's usually genetic.
Yeah. So what I'm saying is I need more stimulants.
And then again, all good things start with insight. So yeah.
Well, and honestly, I'm in my 50s and I've made my life work. And so, you know, strictly speaking, I don't need Medicaid or anything like that, but it's nice to know that that's a pattern so I can plan accordingly and see things coming.
Yeah, I feel the same.
Definitely. Well, thank you so much for being here, for having this panel, this discussion. I thought it was wonderful. So thank you so much.
Yeah.
Really looking forward to your session still. And yeah, I hope you have an amazing rest of Techorama.
Thank you so much.
Thanks a lot.
Thank you for having us.
All right, welcome to Techorama TV.
Testing.
We are here today exploring one of the most transformative topics in our industry at the moment, which is artificial intelligence. Now, we're going to talk about how that's reshaping all sorts of things, from development, creativity, just our roles as developers. And to help unpack that, I'm joined by these three incredible guys here who are going to help us answer some of these questions that we have about AI. First, Alan Smith, who's been bringing AI into the hands of real-world developers for quite a while now. Jeff Prosise, who makes complex AI understandable and practical, just get our hands on it and tangible. And Scott Addy, who helps developers integrate AI responsibly and effectively kind of into their everyday solutions that we're building in tools. So, with that, let's get started. I'm going to start by just kind of centering ourselves and grounding us on how we're using AI. Are we using AI well today in what we're doing? Because it's everywhere right now, but how well is it going? So, the first question I have for y'all, feel free to jump in, whoever has some thoughts here, but what's the biggest misconception you see about AI in software development today?
Yeah, I think all of this, the code generation, that developers are going to be redundant and AI is going to be creating apps for us. I still write lots of code. I've been writing code for money for 30 years, writing code for no money for quite a few years before that. And I find, even with such a long experience of programming, probably you find this the same. How do I save this to a JSON file in Python? Or how do I load up this CSV and split this and display this as a graph? The stuff that everybody's done before, it's just so easy to just have the Copilot create code for you. But anything that's kind of just off the script, I'm doing a lot of coding with music now. If I want to do like harmonic embedding of music, then it's like the Copilot is just like having an annoying code programmer with an extra keyboard connected to the computer that will just suggest stuff that's not really anything like what you want to do. And I think programmers will find that, if we're doing anything that's, their niche, their problem-solving ability, the AI is not going to be the best tool for solving that. And you do need, somebody to actually think through the problem and solve that. So the problem-solving abilities I see, that they're not good at solving problems. They're good at remembering facts and remembering that they've seen code somewhere else to do something, but not to come up with an original creative solution to a complex problem.
To follow up on that a little bit, isn't everything that we do just derivative anyway? It's just taking other ideas we've done before and kind of composing it together in new ways to solve new problems. Why wouldn't AI be able to kind of help us in those ways?
I think, just the code generation, it's seen a lot of code, it's seen everything on Stack Overflow. And there used to be this, when you're working with anything, a new language, a new library, you hit an exception, you copy-paste the exception into Google, then you get a link to Stack Overflow, and you get the solution, you copy-paste that code from Stack Overflow into your solution, and it works. And the AI is just basically doing that for you. It's able to, kind of create code based on what you do as a comment. And they're good at being able to predict based on this particular comment, what is the method that comes after, what is the code that comes after this particular comment. They're, sequence generators. They're good at being able to predict what comes next in a sequence. That's really what they do.
So that workflow that Alan just described of we do something, we get a response back, we might have some errors, we go search Stack Overflow or Google, which ultimately takes us to Stack Overflow, we get an answer, we go try some things. Has anybody used the feature in Visual Studio now that's like debug with Copilot? Have you seen this?
Not yet.
Okay.
But I guess I'd like to piggyback off what was discussed here. It's this whole vibe coding wave. The idea that I can not necessarily be a well-versed expert in the tech stack that I'm expected to use, but with a simple prompt that maybe I feed into GitHub Copilot, I can have a full-blown application produced for me in minutes. And the idea that workflow can replace an entire development team, I think getting back to your earlier question, that's a misconception in my opinion. There needs to be a talented engineer or two, possibly more, to keep that AI on the guardrails.
You know, just to add a little bit to that, it's everyone's talking about vibe coding, really interesting. I would contend that vibe coding or AI-assisted coding is a force multiplier. If you start off, you're not a developer, well, something times 0 is still 0, right? The better, the more competent, the more experienced you are as a developer, I think the more you are likely to get out of AI coding and not expect it to take a one-paragraph prompt and generate a 100,000-line enterprise application. We all know you get the best results when you do things in an incremental way. Always tell folks, as you probably do too, that you get out of an LLM what you put into it. The prompting is very important. What's really interesting to me is, I think proper command of the English language or whatever the native language is may be a developer's most important skill going forward, because if you can't describe it to that LLM.
But not exactly, because you still need to understand the code in the programming language. Like you can't just hand it off and expect magic, even though that's the icon we use for AI everywhere. You mentioned fire. Are you seeing these AI coding assistants and coding agents being a force multiplier and really boosting productivity for developers?
I am. At our company, we give every engineer a choice of GitHub Copilot or Cursor. Probably 60% of them have chosen Cursor, the other 40% GitHub Copilot. I'm very blessed to work at a company with a lot of really smart and talented engineers. I can guarantee you that it's a force multiplier for us. And my observation is the better, the more experienced, the more talented the coder, the more quickly they grasp onto it and the more they get out of it. I saw a study recently, some of you might have too, that said that 95% of the companies that are investing in AI are not getting a return on investment for that. And on one hand, it's hard for me to believe, but on the other hand, I would say, and I hope this doesn't sound too arrogant, they're doing it wrong. Because the rewards, the ROI is real, but it doesn't just happen. You have to know a little bit about what you're doing to get that ROI.
So on that note, if we continue down that path, you all I think agree that it's not just this magical thing that's just going to do the developer thing. We often refer to it as a co-pilot, and I think that's a good way to think about it. Doesn't sound like you think it's going to get rid of developers. What are the things that you have to do it well? You've kind of alluded to like, oh, there's some things you have to do it well, to take advantage of it well, because it's not going to just go out and build the enterprise system for you with a paragraph. So what are those things that people need to be doing to take advantage of this momentum, this wave?
One thing I heard last week that I really liked was somebody saying that these AI is teaching us how to write good specifications, because we need to get that right information into the prompt. We need to be very precise, otherwise it could misinterpret what we say, which is typically what developers may do anyway. So actually having the prompt being a detailed specification document is telling managers that you do have to be precise when you say something, otherwise the AI may misinterpret and create something that it shouldn't be doing. So the detailed spec is good in the prompt, and I think that's going to help people to formulate that for. If a developer is building something, to see a much detailed spec is going to be much more helpful.
Again, I'll echo this. It's the quality of the prompt. What you put in, and you made this point, the quality of what comes in dictates what comes out. So there is the necessity to build up that skill. What makes a good prompt or a good PRD, a spec?
I think it's also, at least in my experience, an incremental approach is better than trying to do too much at once. The day may come when we can feed in a 100-page specification and we just magically get 100,000 lines of beautiful code out. Maybe or maybe not. We're certainly not there yet. And getting back to the term force multiplier, I don't expect AI to write an application for me. What it does do for me is the 80% of the time I spend on 20% of the code, just little boilerplate stuff. That's not difficult, but I've got to go remember how to do it, that kind of stuff. It's just so easy with a little prompt. to have AI spit that out. And now, instead of spending 2 hours doing something that's not hard, but haven't done it in 5 years, you know, the code is just right there. And the nice thing is, too, we've done it enough that we can look and tell whether that's good code or bad code. The chief architect at our company lives in Sweden. He's an amazing guy, one of the smartest people I've ever worked with. It was just a few months ago that he really started investing in AI-assisted coding. He was very, very skeptical. I wish, when he and I sat down for a couple of hours and kind of started showing him the ropes, I wish I'd counted the number of oh my gods that came out of it. I had a message from him on Slack yesterday that said, I asked it to do this and this and this, and it wrote better code than I wrote. On the other hand, you often hear people say, yeah, but it writes trash code. It does. It's not perfect. But, you know, maybe that's because we weren't giving it the instructions that it needed. One thing about an LLM, you can be as vague as you want. It will rarely come back and say, hey, can you give me more details? Sometime it will. More often than not, it'll just make assumptions. That's when we get into trouble.
That's good. Have you been surprised at all by the adoption, the speed, the rate of adoption that AI has just kind of taken over, and then the acceleration and the rate of change in this space? Has that been surprising, difficult? What's your experience like there?
I can speak to this. I actually see it as a spectrum. On one end, you have the large enterprises that are highly regulated. Let's take healthcare or financial services as an example here. They're still looking at AI, and they're absolutely mesmerized by like the terminology that's thrown around. They're still at the phase where they're trying to grasp what do these concepts mean and what should we be doing with it in our organization. Once we understand that, how do the various regulations in our industry get in the way? HIPAA, for example, in healthcare. Or maybe you're in financial services and there's a Sarbanes-Oxley audit that determines what you do. But then on the opposite end of the spectrum, you've got the individuals working maybe in startup type environments, and they're being told, unless you figure out how to become more efficient with the various AI tools that exist, you will not be employed a week from now. You know, they're really being pushed to be on that bleeding edge and figure out ways to innovate and make their business more efficient.
You mentioned something there, which is they're trying to figure out what it can do for them, where to use it, things like that. How do you approach that? How does an organization say, hey, I hear all this buzz in the industry about AI. I want to use AI, but where should I start? How do I plug it in?
Go ahead.
So I have a very strong opinion on that. Doesn't mean it's the right opinion because I'm wrong very often. In my former role at another company as chief AI officer, my job was to work with customers to understand their businesses, understand the challenges they were facing, and then help them come up with creative ways with AI to make their businesses better and more efficient. And one thing I've found kind of interestingly is that there's a huge fear factor out there. Companies are afraid that if they don't get on top of this, their competitors are. I actually had one guy call me. He was head of engineering at a manufacturing firm in the US, and he said, hey, Jeff, he said, until 2 weeks ago, I didn't know what AI stood for. Now my CEO has said, I got to figure this out before our competitors do. Can you help me there? But my strong opinion is this. A lot of companies are investing heavily in AI. Some companies are seeing an ROI on that, some are not. My observation from working with customers is when the innovation comes from the top down, a lot of companies will set up an AI council or an AI advisory committee, oftentimes staffed with people who don't know a lot about AI. And in my experience, that often doesn't go far. What does work, at least from what I've seen, is you take the people that make the company go from day to day, the engineers, the people in marketing, the people in sales, and you train them up. What we did at our company is we put all of our engineers through a boot camp. And guess what? All the good ideas are coming from the engineers, the people who know where the efficiencies are, not from the CEO level. So I think that's my long way of saying I think a bottom-up approach as opposed to a top-down approach is a much more effective way to infuse AI into your company and benefit from it.
Any other thoughts on that?
I think also understanding about there's many different disciplines with AI and machine learning. I've been working with it for probably about 8 years, and I started out working, through PyTorch and TensorFlow books, doing the standard, the handwritten digits classification, cats and dogs classification. So I've done a lot with the object detection, image classification, working with video analysis, tracking, object tracking in videos, and that is still a big aspect of AI, where understanding what model to use is going to be really important. And I've seen so many teams and companies and individuals just want to throw everything at a large language model and saying, I can send this image to an LLM, and it can tell me if there's a cat or a dog in the image. And there's much better, more accurate models to use. So, I mean, that was kind of niche. I mean, I've worked at a .NET company. I was pretty much the only person doing Python, the only person who'd trained a neural network. And there's still all of that aspect of, the GoFi or good old-fashioned AI that we do need to take into account that's there. And I've been on courses where, teaching workshops and people saying, well, how can I use a large language model for anomaly detection? And you probably don't want to use a large language model for anomaly detection. There's anomaly detection models and technologies to do that. I think understanding that, AI is more than LLMs is important.
It's good. So what I'm hearing is a lot of the same things we've always done. It's just we have some new tools to do it with. And so I would imagine the same sort of conversations with engineers and the business, trying to understand the business problems, bring technology to that, make sure your engineers are well-versed and educated in this way. We're solving problems in the same ways we've always done. We just have new tools to do it, which is great. It's exciting. When we are going down that path and we're engineering these solutions with AI now, bringing these new tools to the solutions, what are the biggest obstacles or mistakes that you see people make when trying to infuse AI into their solutions?
I'll chime in here because I see this a lot. One of the biggest mistakes that I see being made is security is still an afterthought, right?
That's not a new thing. So it's just like what we've always done, right?
Correct.
Okay.
That's always been the can that we kick down the road. We acknowledge it's important, but hey, I just vibe coded something, deployed it to Azure, it works. Let's just forget about why that works. It works, and we can move on to the next task. But eventually, that'll come back and bite that individual that produced that application. Maybe they deployed to Azure, and they should have been using a managed identity and assigned an RBAC role, but it turns out they're using an API key. And when their security team finds out about that, there's going to be an unpleasant conversation.
Yeah, that's good. And security is definitely one of those areas today where this is fluid and still developing. There's a lot of challenges and holes here that we're trying to figure out and navigate through as we start delegating things to agents and making sure it's doing things in a trustworthy, responsible sort of way. So that's good. Yeah.
Yeah, one of the mistakes I see companies make, and you probably see it too, is fine-tuning LLMs when they don't really need to fine-tune them. One thing I tell them is technically there's nothing you can do through fine-tuning that you can't accomplish through prompting. But one reason to fine-tune, one justification to fine-tune an LLM is to reduce the volume of those prompts, especially when the volume is getting very, very high. But there are a lot of things to consider with fine-tuning. It's not free. It costs money. Most companies no longer charge you to maintain the models they did in the early days. But now if a new version of the base model comes out, there's no way to magically transfer the information you find fine-tuned into the LLM to a new version of it. You've got to go back and do it all over again. So there are cases where it's justified, but in my view, it's not justified as often as I see companies actually resorting to it.
I definitely agree with that, with getting the prompting right in the first time. We had a customer I was talking to, and they had a really interesting case, and what they wanted to do was do like reinforcement learning with human feedback. And I've done lots of reinforcement learning with like gaming AIs, and thought, oh, this will be interesting. So they explained the situation about how, we're not getting good answers out. If there's not a good answer, we want to click thumbs up or thumbs down. We want to be able to, have the users say why it's not a good answer and use those results to, retune the model to make things better. So we looked at the solution, then we looked at the actual system prompts that they were using, and okay, well, we can do a lot to improve the questions by just writing a good system prompt and improving that, and just starting with the basics and making sure that that's correct. And I definitely think, those explanations, and it's still kind of a bit of a mythical science, this prompt engineering. There was a time when people were setting that as their job descriptions on LinkedIn, and it got a lot of hype for a few months. But I don't know if anybody fully understands how to do it correctly, all of the various techniques that we can use, because it just seemed to be more of kind of one of these mythical sciences where there's all of these various rules. If you offer the large language model $10 for answering the question, then it's going to improve the quality of the answers and stuff like that might work, but there's not that much science behind it. I think also being able to have a reliable way of being able to test and monitor the actual results. So we worked on a project where we just basically wrote an exam for the chatbot, and we could give it 300 questions, go away, take lunch, and we got a percentage score that the chatbot got in the exam. And if we modified the prompt and this score went up, then we've probably done something that's good. And I think as well that the testing is challenging, because we're used to, we run unit tests, things go red and green, and you can't do that with LLMs because we're really looking at a floating point score for how well it's answering the question.
So I've heard a couple of things. We've had a great conversation, continuing like this thread a little bit. I've heard prompting come into the conversation, like downplaying fine tuning. At the same time, I've seen, you mentioned like the job descriptions. For a long time, you saw these job descriptions for prompt engineers for, these huge $300,000 a year salaries to prompt engineer. And then I've seen articles lately saying, well, prompt engineering is dead. Like that's a thing that's not a thing anymore, and those jobs don't exist. But yet you're still emphasizing the prompting. And I've heard English being like, this is the new language. So you still think that is essential in this process, is really prompting well? And then what are the techniques that people should get familiar with, and how should you get good at prompting?
One thing I tell engineers is explain it to the LLM like you would explain it to a teenager. It's really just common sense, but it's not that easy to do, and it's something that sometimes engineers struggle with. It really is a matter of being succinct, accurate, think about where the gaps are, fill in the gaps, and that will get you a long ways. It's absolutely true that prompting is everything, but I'm like you. When this discipline of prompt engineering first started cropping up, I was like, really? That's kind of interesting. So I'm not sure that I would pay $300,000 a year for a prompt engineer, but give me an engineer who's a competent engineer, a competent developer who can explain these things to an LLM the way they explain it to a teenager, and I'll hire that person.
That's good. So succinct, accurate, direct, probably. Those are all good ways to think about it. You alluded to kind of cost when we were talking about LLMs in here as well. What do you do how do you manage that? How does somebody approach this when they're concerned about what is this going to cost me? Because it's kind of this morphing sort of thing of you're paying for tokens. I don't know how many tokens you're using. So how do you get a handle on that? How do you manage that through the process?
I don't have a great answer to that question, but what I can say in talking to, for example, universities out there, they're looking at AI and they're recognizing that we need to be using this, but the cost is always a factor. How do we regulate that? If we roll this out to our professors, to our students, things quickly become out of control. There needs to be some sort of a governing body that limits what that total spend can be.
Good. So policy somewhere that's going to monitor and control that. So again, same fundamentals of in blocking and tackling that we would have done with any sort of consumption pay for use resource, it sounds like, which is great.
And that might be somewhat temporal too, because until we come up with something better than the transformer architecture to do the things that we're doing today, so assuming we stay with language models for a while, small language models are getting better and better. They tend to be open weights. In fact, I think all of them are open weights. It's not that they're free, because you still have to have some hardware to run them on, but you're not having to pay for those on a per token basis. And one trend that I see is, we have SLMs that are distilled from LLMs, but are designed to do specific things like Code Llama. Yeah, it can generate prose, but it's really good at generating code, maybe as good as that kitchen sink model that has 2 orders of magnitude more parameters. So I think the future, we'll see companies using more and more SLMs, which they're hosting themselves. They're not paying on a per token basis, and they probably won't be using one SLM. They'll be using several. One to help with code, one to help marketing, write marketing content and stuff like that. So right now, yeah, we're paying on a per token basis. I don't know that we'll be doing that forever.
That's interesting. You mentioned, Jeff, that you might use one model for this thing, you might use another model for this thing. As an Azure guy, I approach Azure AI Foundry and I look at the 11,000 models in the model catalog. How do I know what to do, like what to use, what models to pick? Because they might have, it sounds like, strengths and weaknesses.
There again, and I'm glad you brought this up. I see it all the time. There's this analysis paralysis that developers encounter. They see that inventory of models that are available to them, but oftentimes when they see that list, what they don't see is, which capabilities does this particular model excel at? And once I figured that out, what is this going to cost me? Okay, maybe that's too expensive for the budget that I have. Well, what do I do now? That's another big problem I see out in the wild. If you look at just GitHub Copilot and the tiny drop-down of models that you'd see when, for example, you're using agentic mode or maybe ask mode, there could be a dozen models listed there, but really no further context on which one you should be using. Is it Claude Sonnet? Is it a GPT that I should be using? Who knows? And so what some customers will do is just skip around, try the same prompt with different models and do it that way, and it's not super efficient.
So like do a bake-off or just kind of test them out every now and then and see, is this one doing better or not? It's a reasonable approach. I don't know how else we would go after it. But so are you using, the three of you guys, are you using tools like GitHub Copilot regularly as you're building stuff, or ChatGPT, or?
As a product manager who's come out of software engineering, I find that on my team, I'm expected to know various programming languages, some of which I've never touched in my life. Let's use Golang or Rust as perfect examples here.
Great.
If my engineers in those languages are tied up and they're on the critical path trying to meet a deadline, you best believe I'm going to do my best to fire up agent mode and feed it a prompt and tell it, try and generate a function in this language. Thankfully, I've had very good luck in doing that, and I've been able to, not distract the engineers who, again, are trying to meet a deadline.
I don't think I could do what I do anymore, because I still write code on an almost daily basis without tools like Cursor and GitHub Copilot. Years ago, I used to pride myself on doing conference presentations where I wouldn't use an IDE. I'd just type it in a notepad in C#,
CSC.exe.
Exactly,
Yeah, okay.
Exactly. Then I discovered IntelliSense and realized how dumb I had been. Got to the point I couldn't live without IntelliSense. I feel the same way today. I'm so used to using these tools now. It's not that they write all the code for me. They go in, they do surgical strikes and do the stuff that's just going to take me a long time or something like that. I couldn't live without them. You know, something else, more and more we're all gravitating towards open source. Open source is great. You look at all the open source agentic frameworks out there, there's some great ones. They change every day. So, and the documentation rarely keeps up. What I have found AI tools really good at doing is point them at a repo, point them at a source code file and say, hey, I want to build some code that, let's say, creates an agent, gives it memory that's stored in SQL IDB, and AI, in much less time than I can go into that repo, figure out what that code looks like. So it gives me a jump start, and I'm just instantly more productive. I literally I can't imagine working without them anymore. It's that big.
It's good. So Alan, when building these solutions, we've said, you know, maybe fine-tuning isn't for everything. Prompting is where it's at. When we're doing that, one of the questions I commonly hear is, how do I get my own data into the model? And so kind of feeding off of what Jeff just said, you know, there's these open source maybe models out there. Can I train my own model and feed my data into it and use that as part of the training set? Is there a better way? Like what approach should I take to try to get my data into the LLM, if you will, and then get some responses back with my data?
Yeah, so this comes to like all the agents and tooling, and what we can do is we can provide the language model with tools to be able to retrieve information. So we've got this whole pattern called RAG, Retrieval Augmented Generation, and everybody's talking about, oh, we can chat with our data. And one thing I find that's really assumed when we talk about chat with your data is that your data is going to be a PDF document. And really chatting with your documents is one thing, but I see retrieval augmented generation as being able to just access any external system. You know, so many companies have still got data in a SQL Server database, a relational database. So you can take a user's question, and the language models are great at creating code. So they can write a SQL query to retrieve the information for that particular question. You can query the database, the language model gets the results, and it can then inform the user. And if the LLM has access to the structure of the database, it can figure out the tables, it can figure out which tables to run a particular query and give these responses. So that's quite easy to do. However, you do need to take care about the security, because I did a demo with Nobel laureates that was actually a request we had from the Nobel Institute to answer questions more accurately by using data in a database. You can ask it to change the city where Albert Einstein was born, and it does an update statement. I asked it to add myself as the Nobel laureate for AI, and it inserted me in the database. So this is coming back to the security. If customers aren't, if you're not thinking about security when you build these systems, you could build a customer chatbot. And the customer says, you know, how much is this mobile phone? And it says, oh, it's $1,000. And the customer says, you know, I wish it was half that price. If it was $500, I'd buy it. And then the LLM may update the database and change the price. Now we've changed the price to $500. Do you want to buy the phone? That's kind of a bizarre example, but I mean, that could very easily happen. And I think one thing that kind of getting into the security is that many vendors are providing tooling where you can just create a chatbot without knowing anything about AI, anything about security, anything about code. You can go into these tools and you can just write a description of your chatbot, and your chatbot appears and it can talk to your internal line of business systems. I see a danger with that. I see lots of advantages in that it's a way of being able to create something very, very quickly. But if you're not understanding the security implications of that, that is going to create some really bad vulnerabilities, I think.
So when you mentioned retrieval augmented generation and RAG,
yeah,
as a technique to get your data in here, you mentioned documents like PDFs or what have you, and that's a common thing. How do I do that? So how do I make the RAG thing work? Like what's involved in that?
It's really about getting the correct information into the prompt. So we've talked about how the prompting is important, so having a very well-structured prompt. And then extracting the correct information, the relevant information that's going to be relevant to the question that the user is asking. And one of the things that can help with that is doing embedding and a vector-based search. I did a demo in one of my sessions a couple of hours ago where I'm putting some text into Azure AI search, and then you type in a sentence, and it does a keyword search and a vector search and displays the results on the screen. With a vector search, if you ask the question in French, it finds the correct information because the embeddings or the sentiment of that text is similar when you're crossing language boundaries. So embedding can help as well. And then there's also the challenge of document chunking. So I've been on projects where they give you a 450-page PDF. We want to ask questions about this PDF document. Well, you can't. Well, I suppose you could with the larger models. You can actually throw in the entire document, but that's going to be slow and expensive and not the best way. So you need to break down a PDF document and do it not by page or not by 1,000 tokens in each chunk. But each section of the PDF document is its own chunk that can be retrieved and put into the prompt. So when they say, how do I, do my time reporting, or how do I get a new mobile phone, it finds that section from the document. And if you've ever tried to parse a PDF document programmatically and find the headings and the sections, it's not fun. So, I mean, there is in Azure, there's something called the Document Intelligence Service, and that can figure out all of the headings in various documents. And that's a great help of being able to split a document. Another thing that I have a success with is the custom question-answer service that can parse a big document and generate these question-answer pairs. It's a bit legacy in that it's considered to be legacy because it was used with a bot service, which nobody talks about anymore because we've got chatbots, which are so much better. I hate the bot service. I used it once and never again. But that method of being able to very quickly parse an FAQ website or a big document into the individual chunks very, very quickly is useful. And I've had one case where we've used that is a customer contacted me and they wanted to know how long it would take to build a proof of concept to answer questions from an FAQ on their website. In 90 minutes, we built that proof of concept and published it as a website using the AI Foundry. It's not a ready product, but it's the proof of concept, and that took 90 minutes, and we just used custom question answer to do the actual parsing and generating the question answer pairs from that website.
It's pretty cool. Every time you guys talk, I feel more and more encouraged because it sounds like this is just the stuff we've always done with just different tools, right? We got to, garbage in, garbage out. That's always been the way it is. So we're just doing it with new tools, and we have to make sure we're not feeding garbage in so we don't get garbage out. So this is great, encouraging. So Scott, we have all these great developer tools. Jeff's talked about Cursor and GitHub Copilot, and we use Visual Studio and all those sorts of tools every day. What's the big gaps still of improving this developer experience or getting to this sort of end state that we're marching towards in the developer experience?
So a couple things come to mind. I think if you look at what's happening in the IDE space, you see VS Code very much leading the way. And then you've got a large percentage of .NET developers hanging out over here on Visual Studio, the larger, older IDE. And that's lagging. It will eventually catch up, but for now, I see a lot of customers moving between the two, doing their actual hardcore development in VS and hopping over to VS Code to take advantage of the latest and greatest AI innovations there. Another thing that came to mind is MCP servers. You were talking earlier about chatting with your own data. So this ability to stand up an endpoint, I'll call it, that is providing additional context to a model. It's based off of Anthropic's specification. That MCP server, let's say you've deployed it remotely, can expose various tools that provide capabilities. And so as a customer, I can be, let's say, inside of VS Code or maybe even in my own agentic application that I've created, calling off to these tools that the remote MCP server is calling. Maybe I integrate with Stripe's MCP server and I say, create me a payment link for this particular product in this currency. And it's just super easy.
That sounds like a great thing just sitting right inside of my IDE. If I could tie that in with all of the tools that I use, all my DevOps things, and then just interact with it in like natural language in my IDE, that'd be great. It sounds like you guys are making progress in that way in all these IDEs with Visual Studio and VS Code and what have you, right?
And I guess I'll add one more thing. I guess the industry as a whole is in this place where they're trying to figure out what does the future of the IDE look like with all these agentic experiences popping up on a weekly basis.
Yeah.
How does that IDE evolve? And we don't have the answers yet.
So I find myself doing exactly what you described. I've done it for years. I've switched back from Visual Studio to VS Code. But for years, I've done it just for the Git tooling, because the Git tooling I feel like is better in VS Code. But now I find myself doing it as well with the AI tooling. So I'm excited for Visual Studio to give me all the cool things that I love in VS Code there too, which sounds like it's coming, so that's good. So when we were talking about kind of building our AI systems, we've talked about fine-tuning. We kind of downplayed that for a second. We focused on prompt engineering. We talked about retrieval augmented generation. When should I use fine-tuning? We talked about, like, we shouldn't overuse it, but what are the scenarios where it makes sense? When should I use fine-tuning?
So I'll give you one example. Had a customer come to us a couple of years ago, and they wanted us to build an LLM-based app that would write emails for them, which very, very easy to do. But there was a gotcha. It has to write emails in the voice and style of our CEO. So that adds an additional constraint. So that was actually an example of a case where I felt fine-tuning was justified, because we can take 10 or 20 or 30 or 40, 50,000 emails from that CEO, fine-tune with that, and yes, that LLM will be perfectly capable of generating a new email in that style of voice. Now, it is absolutely true. Again, there's nothing you can accomplish with fine-tuning you can't accomplish with prompting. But do you want to submit, let's say, 25,000 emails in every prompt just to say generate a new email that says this in that voice? No. Fine-tuning is entirely justified in that case. One other case I've seen where, in my mind at least, it was justified is Alan mentioned LLMs are very, very good at converting natural language queries into SQL queries, and we can use that mechanism to give an LLM access to a database. One thing we found empirically is that we're much more liable to be successful if we communicate the database schema in each prompt, typically using the DDL, the create table statements and all that. Sometimes databases are quite large with hundreds of tables, which means you're passing all that information in redundantly in each prompt. It's actually not too difficult, and usually doesn't take all that many training samples to fine-tune an LLM to understand your database structure. So now with a simple prompt, you can generate syntactically correct queries against that database 99.99% of the time. So 2 examples where I felt it's not only justified, but absolutely the right way to do it.
Style and tone, and then maybe some
database schema.
Yeah. Okay,
Yeah.
that's good.
Yeah, I mean, you can do all of this again. One other criteria: if you can do this by adding, let's say, 200 lines to your prompt, don't worry about fine tuning. If it's going to take adding 20,000 lines to that prompt, think about fine tuning.
And when we're talking about fine tuning, what's really happening inside that process? Like, what does fine-tuning really do?
So fine-tuning has been around long before LLMs. When we train a neural network, what we're really doing is arriving at values for the weights and biases that define that thing. Fine-tuning means training with an additional set of training data, typically much smaller than the first one, at a reduced learning rate, so that you're making smaller, more incremental adjustments to the weights and biases in each backpropagation pass. The goal of fine-tuning is to instill new knowledge in that model without taking away from the knowledge that it gained in its original training regimen.
So you're really just moving kind of things around in that model, like the weights of things. You're pulling some things down and boosting some things up.
Just making little adjustments to little numbers that make that thing smarter. It's actually quite remarkable when you think about it.
It's pretty cool.
It's actually also focusing on a specific section of the model as well. We do that a lot with vision because the vision AIs, they'll start out with like line detection, shape detection, and it's right at the end when they're doing the more complex features. So you freeze most of the model and then just fine-tune the end part of that model. That's also possible to do it in LLMs because these things are really big. They fit on more than one GPU. And if you're just using a smaller section of the model, it's going to be less expensive to host. And with fine-tuning, it's really the monthly hosting cost. It can be like €1,200 a month to host a fine-tuned model because GPU memory ain't cheap and it has to sit on a GPU somewhere in memory. But you can also do it for batch processing, so you can just spin this thing up and use it for a few hours and shut it down again, and that could be more cost-effective if that works for your scenario.
Okay. Scott, when you were talking about people using Visual Studio, this older, bigger IDE, people that have been doing .NET development for a while, I thought about Alan because he is the only guy that I know that uses, he's like the OG, he's been doing this for a while, been doing Python development for a while, and he's like the only guy I know that uses Visual Studio for Python development too, at least personally. I know there's others out there. So I say that to say, I know Alan's been in this machine learning and AI space for a long time. Jeff's been in this space for a long time. How is the industry and the conversations, how are they changing with all of this generative AI and large language model conversations from like what they used to be? And is there still a place for those other kind of traditional applied AI models, those machine learning models? Is there a spot for people to still build those?
Yeah. One thing I thought of as you were talking there was, you mentioned Visual Studio. I always wondered who's checking that Python workload in Visual Studio.
It's Alan. Yeah.
So they do exist. How the conversation has changed over the last year or so, let me address that point there. If we go back to the Build conference, the last one that took place, we heard a lot of customers say, hey, I'm a .NET customer. Seems like I need to learn Python now with this explosion of AI. Turns out that's not the case anymore.
Well, I'm delivering a session tomorrow morning on Python for the .NET developers, so don't tell them that yet. Wait. Yeah.
So I'm not going to steal your thunder here, but you now see us collaborating with external companies. OpenAI is a fine example here where we took over ownership of a community-owned library for .NET developers, revved it from V1 to V2, added all sorts of goodness in it that includes our best practices. Now all of a sudden those same .NET developers that were complaining can come along for the ride and do many of the same things that JavaScript and Python developers have been able to do for a very long time. So that's how I see the conversation changing. We're meeting those customers where they're at instead of expecting them to pivot in their tech stack.
That's good. Things like semantic kernel, which now is like Microsoft Agent Framework, is a great example of that. You know, before that, it was LangChain, and it's still that's a great tool, LangChain, LangGraph. But you're meeting developers where they are with the Microsoft Agent Framework. They can do it, they can approach it in their .NET stack as well, so that's fantastic, yeah. I'm actually going to be on that same sort of topic, so I'm delivering the session tomorrow on Python for .NET developers. This afternoon, I'm delivering a session on polyglot notebooks. So another great example of bringing capabilities like Jupyter Notebooks, what we think of as these notebooks, to .NET developers. And so we can do those same kinds of things, which is fantastic. So I do love that. I love that.
Do you remember Azure Notebooks? They've been gone for 2 or 3 years. They were awesome. Yes. You could even select a C# kernel for those.
Yes.
Such a shame they went away.
Yeah, and so now it's in VS Code, right, with the polyglot notebooks. But yeah, it is. Azure Notebooks were really cool for a little while. So yeah. So in terms of like the ML conversation, though, is there still a need for building your own ML models for things?
Absolutely. In some cases, fraud detection is a good example. Worked with a group of engineers in Costa Rica who built the fraud detection model that checks every transaction at Starbucks at the point of sale for fraud. could an LLM do that? You might twist it around and do it, but no. Because it was trained on a lot of data that was very specific to Starbucks. There are many, many things that we, in years past, would have had to build a model for that we can now accomplish with an LLM. But one thing I think we miss sometimes is AI is about much more than LLMs. Vision models, traditional machine learning models for fraud detection, things like that. Still a place for it. One thing I worry about sometimes is, you've heard the expression, when all you have is a hammer, everything looks like a nail. Sometimes the LLM is that hammer, and they're not always the best solution. In fact, they're oftentimes a poor solution. You know, you mentioned custom object detection. We used to build custom object detection models. Google's Gemini models does do object detection really well, but they can't do them in real time. A self-driving car doesn't have an option of using an LLM to do, a multimodal LLM to do object detection. It has to have that custom one that can work at 30 frames per second.
That's a great example. Yeah.
I mean, the smaller models are so efficient. You can just run them on a really tiny device. So if you do need to run anything on the edge, not connected to the cloud, the device can do object detection. Built in. There's so much machinery. We see you go to the airport. There's all the baggage scanners, security things. You can't feed everything up to the clouds to process that in an LLM. And one analogy I have is it's the energy costs as well. It's responsible to think about that as well. Just because you can. You've got a big SUV and you can drive your kids 200 meters to school in an SUV. You can also, walk with them on a bike, take them on a bike to school, save a lot of energy, and that's very often it's the most convenient way to do things is to use a much smaller, custom domain-specific model for that specific task.
So what I'm hearing is you want to pick the right tool from your toolbox for the job. Again, the same things we've always had to deal with. How do you know what the right tool is from the toolbox, though? We've been talking in this new LLM like Gen AI space about evaluations. What does that look like? How do we know how well the model's performing, what the right model is, what the right tool is? How do we approach that and solve that?
Going back to something I said earlier, I think there's a lot of kind of benchmarking that needs to take place. Pick a couple of good candidates and just compare the two. Manual testing. That would be my approach.
There are evaluation frameworks for sure, but for development teams that have never worked with LLMs before, the thing that tends to be the most shocking to them is how difficult it is to write tests. Little things that we've taken for granted over years, unit tests, integration tests. I mean, think about it. As software engineers, we're used to, you give it an input, you get a very precise output. Now we give it an input, we run it 100 times, we could get 100 different outputs. It makes testing really bad, and it also makes evaluation really difficult because, you can't just run a simple set of tests and say, well, this LLM does a better job of generating SQL queries against my schema than anyone else. It's not that simple.
It's good. You are kind of alluding to something that I think is important here, which is it's not deterministic. And so going back to your, when you have a hammer, everything looks like a nail, you might try to throw an LLM or generative AI at every problem. Might not be the right thing to do, but it's not deterministic. So what are the cases where you shouldn't think about using AI? Instead, you should think about just using some other deterministic method.
I think you need to take a look at are there efficiencies to be gained by using some form of AI tool? If not, you may be wasting your time. Take a look at that.
I would say if there's an algorithmic, deterministic way to do what you want to do, you should absolutely go with it. Don't use AI if there is an algorithmic way to do it. The beauty of AI to me is that, especially LLMs, it makes it possible to do things in software that weren't possible 3 years ago. For example, take the user input. The user asks a question where, like, What 10 countries did I achieve my top sales figures in last year? And you want to say, okay, I'm either going to provide a textual answer to that question or I'm going to produce a pretty chart and graph. You would never algorithmically be able to look at what the user asked and decide accurately whether to produce a nice pie chart or a piece of text. But with an LLM, that's like AI 101. So use it when you want to do things that are not possible algorithmically. And I think that takes care of 99% of the cases.
It's good. Yeah, I have that same sort of approach as well in the way I think about it. If I'm going to do something that's deterministic, oftentimes we talk about agents being, LLMs being required to build agents. And it's like, well, no, if I'm just using my agent to book a hotel room or something like that, I really don't want the non-deterministic nature in that. I might want the agent or the LLM to deal with the control flow logic, but I want it to book the hotel room every time in the same way, right? So that deterministic process, like write the code just like you always did in that deterministic way. And I think that's a good way to think about it. So this has been helpful thinking about just all this kind of blocking and tackling fundamentals. That's really the same, like DevOps processes, testing and evaluations, all those kinds of things. One concern I have is that AI coding tools and coding assistants and agents are taking entry-level software engineering jobs. And the reason I have this concern, you all have said, well, it's not replacing the software engineer. You still have to understand software engineering. But if we're not bringing in new entry-level people, how are we developing those people into the future senior-level folks? And so I would just like to hear your thoughts on this and your advice for companies and organizations and how to think about their software engineering teams and organizations and developing talent in their teams going forward.
I actually see things kind of going back in the other direction eventually. I think many companies have sort of over-indexed on, AI can, save us so much cost in terms of, junior level developer salaries. We don't need those 10 developers we previously would have needed. But I think the harsh reality will eventually hit some of those companies, as unfortunate as it is, and they'll recognize that, hey, that summer internship program we used to run, those folks are needed. Eventually we'll have a wave of very talented engineers that will want to retire, and who will replace them? Again, my earlier point, at some point you need a talented senior level engineer who can keep AI on the guardrails. And if that next generation isn't being built up, you're going to have a big problem on your hands.
That makes sense to me, and I fully agree. And we need to be intentional about bringing in the next generation of engineers and training them up. So what are, kind of in closing here, what is the advice you would give to software engineers? What are the skills and the things that they need to be developing to be that 10x engineer, that kind of superhero engineer over the next year, 5, 10 years in their career?
I still think, going to school and just studying comp sci fundamentals is something very good, because at the end of the day, just knowing basic data structure knowledge, that will go a very long way in helping craft an effective prompt that you would use.
I would answer the question the same way I answered to my daughter, who's a software engineer back in the US. Embrace AI. It's a wave, it's a big wave. We would rather be on top of the wave riding it than under the wave about to get crushed by it. And in the future, I think it's highly likely that developers who are comfortable with AI, who embrace it, who know how to use it as a tool, are going to be much, much, much more marketable. So embrace it, love it if you can. Me, I love it. I'm having more fun than I've had in 40 years. And learn to use it as a tool, because that's where we're going.
Good. Anything to add to that, Alan?
Yeah, I think AI is such a great learning tool because I've been, recommending that .NET devs learn a bit about Python because it's useful to have with machine learning. And I always tell them, I learned Python without a Copilot. You learn Python with a Copilot. It's going to be so much easier for you to learn. And it's great as a teaching tool. Like even as 30 or 40 years writing code, I'm still learning stuff, seeing what the actual Copilot will suggest. Oh, I didn't think of doing that. And yeah, it's helping me to improve.
It's good. Yeah, I'll add some thoughts to that as well. I have a good friend who is a teacher, now as a principal, and she is very much into classical sorts of things and literature, and I've always given her a hard time and said, no, like engineering is where it's at. Science and math, that's where it's not all of this language stuff. And I feel like now I'm kind of eating those words because, yeah, that's important, but we need engineers that can write, can communicate their thoughts, can communicate, with others like you're talking to a child, as Jeff was saying. And so all of those other disciplines are really, really important for, I think, software engineers going forward, because English is, or language is the way we're going to communicate potentially with these models in some way. So I think that's all important. Well, Alan, Jeff, Scott, thank you all so much for joining us and being on Techorama TV and talking about AI today. This was the Techorama TV AI panel. Thanks so much.
Thank you.
Good job, Eric.
Thank you for joining us at Techorama TV. It's somewhere 4 o'clock in the afternoon. People are getting tired, and I get to have the most fun in my job. I got to interview some real cloud experts with me. They're going to be so sorry after this interview. I know, I already apologize in advance. So with me, I have Laurent Bugnion. I have Chris Ayers, and I have Erwin Staal with me. Nothing to do with steel. You could be Iron Man, but that's a little bit different story. Laurent, you're still a dev advocate, I think?
Yes, indeed, yeah.
Okay.
For about 8 years now, yeah.
About 8 years, yeah. And Chris, you're still a specialist in resiliency and resilient architectures, mission critical, and things like that, all right?
I'm actually working on Azure itself. I'm doing resiliency of the Azure platform.
You switched again? Oh,
no,
man.
switched last year here.
You switched last year, yeah, I remember that. And Erwin, you're kind of a DevOps guru and everything which in regards to bicep and infrastructure as code, right? Or am I mistaken there? Did you change roles too and you're doing now Count Colossal, for instance?
No, totally correct. I currently work as a cloud architect on one of the largest hospitals in the Netherlands. Yep.
Okay, cool. So I got myself some genuine SMEs here, which is awesome. So I got a first question for you guys. Seeing we are living in this crazy little world where AI rules everything, where do you see what AI will do for cloud, and where do you see the evolution of cloud after this small, well, you can say revolution. I mean, it's only been for 2 years in IT. It was been going around for the last 200 years by figure of speech. Where do you see cloud going from here, and what will be the impact on cloud with everything in regards to AI? And I'll give the word to you first, Chris.
Well, I think that there's definitely an impact on AI from the development standpoint. Just things are speeding up with release cycles, SDKs are speeding up, but I also think that we're going to have quicker transitions between things because we're going to have AI-assisted technologies to build out infrastructure, to build out new services, and I think we're going to see a big spike in just speed of delivery, and then I think it's probably going to taper off when we maybe run into weird problems with scalability or security or things where people have got, that looks good to me, approve. But we'll see.
Yeah, so typically what we're having today, but in a larger scale, right? Any add-ons to that? I mean,
well, I can totally relate to your last point in that you already see developers. I'm mostly working on infrastructure. But you see the same happening in application code as well, right? That a lot of stuff is being created very quickly, but the level of quality is dropping. You actually see the same happening on the infrastructure side as well. And the LLMs are pretty good actually these days in doing bicep and Terraform, which is mainly my focus. But also, when you start playing around with both of the tools, they tend to make mistakes quite quickly. It looks reasonable what comes out, and then it either fails or tends to be a very insecure solution. And we still need people with the knowledge to actually see that. And I sort of hope that LLMs and AI will evolve in such a level that it's more clever on that level as well, helping us, protecting us from ourselves, so to say.
Let me add one other thing that before Laurent goes. Another thing we're seeing is some self-healing systems, like more SRE bots and AI bots to help analyze outages.
Like the Azure SRE agent, like we have.
Like Azure SRE agent. Yeah. Like we're going to have some tools to help identify and fix problems more quickly.
Yeah, so totally agree with what you said, but I think if we go even one level deeper, right? I mean, first of all, without cloud, there wouldn't be AI. Like that's one thing, right? Because
finally, somebody said it.
Yeah, no, it's true. I mean, you cannot train. I mean, OpenAI works on Azure, right? It works on Cosmos DB. Without those database, optimized database, etc., there wouldn't be AI, right? So that's one thing. But also, interestingly, I think it's pushing the infrastructure just because the sheer size of those data center we need, right, to store this data, to store and to train it, right? So there is and we know because we talk about it like an environmental impact, etc. And so we are trying to minimize that. So it means that we need to basically have some advances in tech in order. So even at the lowest possible level, even just like water cooling, right, and these kind of things, there are some progress that needs to be made because otherwise it just couldn't work. So I think it's actually interesting, but at the same time, as much as I, run AI models in the cloud, I'm way more excited about those small language models which can run on, on the Surface Pro or on potentially at some point on the phone. Because I think that when you remove, this constant need to access the server, that's when we can really do very interesting things with those things. So it's cool. But that being said, yeah, cloud is, AI runs on cloud, right? That's what it does, yeah.
So, yeah, to be honest, the thing that Microsoft did the last year, we announced that big investment in, Microsoft announced that big investment into that AI data center, they call it. I mean, they pumped in a lot of money in there, but also a lot of hardware in there. Yeah. Seeing that we're also shifting into other components, like quantum, for instance, or things we're doing with Boost, things we're doing in networking integration, things like that. How do you see the evolution of the data center in regards to the end users? Will they be able to be more fine-grained on how we will start using into cloud compute, things like that? How do you see those things? It's a hard question, right? Because nowadays we can just consume and we go serverless or we go something. But maybe for all the compute that we're doing today, it could be more GPU-based, could be more quantum-based. How are you going to do that? We got now the supercomputer that we can use, things like that. How do you see those evolutions going on?
On the Azure platform today, you can usually pick SKUs of things. So if I need a VM or a compute, I can be more memory heavy, more GPU heavy. Like I can choose that. There's also services where, depending upon the region or the availability zones support I want, it might be available in East US or East 2, or Sweden Central, but it's not available in Central US. So as those bigger data centers come online with the more advanced hardware, the choices of places we can pick will go up. But I also think we've evolved from paired regions for resiliency to we have multiple availability zones. I think that's going to continue to expand, especially these bigger data centers for AI. There will be multiple campuses that are linked and give people more flexibility and choice. And there's already choices for moving from an Intel-based platform to an ARM-based platform. Those choices exist. And Microsoft's put out Q#, so we have quantum languages that exist, so those will be coming up on regions, I'm sure, where you can pick things. So it'll just be like you have today. You get to choose where and what you consume. Yeah. And the intercloud problem has always been a problem. Like if we're trying to go AWS or GCP and Azure or on-prem, you're limited by common denominator because it is really hard to go, hey, I have this Terraform module and I'm going to reuse it. No, you're not. True. You're going to fully re-implement it every single time. You're going to use one common little piece of data that's like, here's my name. And then it's a myth that we've told people. It doesn't work. True. It's so expensive. And you still have the problem of what's your primary ingress, what's your primary DNS. You still have to have some sort of fallover for your fallover. Yep. It's a problem.
Yeah, because we learned recently that DNS can cause a few issues.
One region, one data center DNS can cause a problem.
Yeah,
or
somewhere
on
in the
Microsoft
East, right?
side that had a global front door can cause a problem. It goes both ways.
Yeah, but also there is a factor which is as those data centers grow, the cost is also going down, right? Because obviously there is, the maintenance is different. And I mean, every region is a little bit different. Like, for example, in Switzerland, we have actually 2 regions. It's a small country, but we have 2 regions because of resiliency and of compliance, right? And those are small data centers, or at least they started as small data centers, right? But they were necessary. We needed them because of compliance, especially our banks and our insurances don't want to have, they cannot actually have, documents outside of Switzerland, right? But then as they grow, then we also see, first of all, we have more services going on, but also the price is going down because when I was first experimenting with the Swiss data center, the price of pretty much every service was higher because it's a smaller data center and so they limited capacity. We also have the issue for us, I don't know if this affects you as much, but that suddenly we have some demos running in a region, in a popular region, and suddenly we get an email from our boss saying, hey, you need to delete your demo because clients, customers have priority, right?
Been there.
Yeah, exactly. So capacity is really important.
Yeah. So about capacity, and that brings me a little bit to you because this is up your alley and also a little bit of yours, but not up yours, but up your alley.
How very European of you, my friend.
Yeah, very European. I need to apologize for the things I'm saying. No filter. No, but seriously, but people could. People at home could probably misunderstand me, and that was totally not the intent. So hence why I apologize for that. So this brings us to the more thing, because you said something really interesting. Yeah, we had that region and that micro region, because 2 micro regions.
Right.
How do you build for that? So you build in cloud, but how do you, you work in the field, you work with customers, but you also work on the platform itself. What is the best way to make people understand that they need to build not with the intent for one single region, but that they have to build with multiple regions in mind? Because that's, for me, that's the hardest part. How do you approach us, and how do you make them aware of that?
That's a nice one. So this is actually a subject that's really currently at hand in my current assignment at the hospital, because obviously for example, compliance reasons, that's one of the reasons why I would actually need to be in multiple regions, apart from the fact that there are certain applications that simply can't go down, right? And so within the hospital, I lead the team that actually builds the foundation within Azure. And so we try to take that away from our users as much as we can by actually giving them a platform that's easy for them to land on. So we already make the choice around what regions do we actually expose to them. We choose regions that have feature parity, that fall within the right region, have the compliance rules that we need for the type of application that we run. So we try to do that for our sort of internal customers as much as we can. And on top of that, my team builds these standard types of way of working. It also helps them to, if they need to go multi-region, and I mean, not everyone needs to, not every application needs to be a multi-region.
So you're becoming kind of a center of excellence, maybe.
Yeah.
Yeah. Kind of. Yeah. Okay.
So we help them with those kind of things as well to get them up to speed fast, and we do the hard work, and then they can leverage that.
And then you move everything through a DevOpsy way. I hate saying it, DevOpsy way, but you're trying to do it in a more automated way that everything passes through. You take AI out of the equation, but you make humans decide on top of that. But if you're doing that multi-region thing, how do you do the trade-off if you're going to go multi-region or not? Because typically they come like, Erwin, very nice of you, but you're costing us a lot of money. Yeah. Or, an additional data center, do we keep it alive? It's these kind of decisions that will make it hard. Now, for a developer, they don't care because they're just in the little local cloud. But for the guy that in the end pays the invoice, it can be a big difference.
So when I did this with Fortune 100 and 500 companies doing resiliency reviews, the first question usually is, what actually are your resiliency requirements?
Yeah.
Because if you talk to any manager, they're like, I want 5 nines. I want it up all the time. And I show them like, oh, you mean you get 5 minutes of downtime a year because you want 5 nines? Like, that's not how that works.
Yeah, that's a good one, yeah.
Like you're not Walmart. Like, you might have some sort of very high requirement, but also you might just be 8 to 5 Monday through Friday. And you might not be around the world. You might be in Germany and France, or you might be in 2 or 3 countries. So understanding your actual requirements, understanding like we need a really high or a really, really low like RTO and RPO for our data recovery. Like, we just have to assume failure is going to happen. Failure is always an option.
Yes.
So something's going to fail. What do we need to do to deal with it? Is it we need it back up quickly? We need minimal loss of data? We just need to, oh, this isn't a critical application. We can be up in whatever. So understanding that's the first question. The second thing is choosing regions is actually farther down the decision tree.
Yeah.
Because it starts with, well, what are you trying to do and what's your architecture? Can you have graceful failure of things? And has it been designed in a way you can do that? And then you can go, now what regions do I want that support my services? And then there's code layers and all sorts of other things, procedures and policies. It's just so many layers. And this is something I actually talk about here tomorrow.
Oh. quite often.
Also, it's important to remember that you're only as good as your weakest service, right? So you can have 5 nines everywhere, and then you have one gateway somewhere which is crashing, and your whole application is gone, right? So there is that. But personally, I like to take the path of least pain, right? So I usually start.
Is there one?
There is a least pain. I didn't say no pain, right? But essentially, I like to just start with whatever is easier, and then if I see that it's not good enough, then I will, think about it and improve. But I think that very often we go into very complicated thought processes. It's a little bit like you said, right? Thought processes which are not absolutely necessary. And so, try things out. If it works, it works. If it doesn't work, engineering is just like failure and trying again, right? Is what we do. So
that's a valuable thing. Failure mode analysis, understanding how your application could fail. What do we need to do to mitigate those particular steps?
Well, I should say computer engineering is that, because in bridge engineering, I hear that it's a little bit different, right?
Yeah, that's a given. That's one of my mottos. I have a motto called FINO, failure is no option, and everybody goes like, why is it no option? Because it's always there.
Yeah.
So
it's always an option. Yeah.
It's to quote one of my dear friends at Microsoft, presumably with the same family name, a certain Derek Martin, he always say, never take a dependency on a single region.
Yeah.
So this is something that you need to keep in mind. Okay, this has already been a good discussion. This is I see the heat in you. It's good. It's good. So we already talked a little bit about resiliency, but there's also this other thing that is popping up now. And I'm first going to ask you, and then I'm going to ask either of you, because you're living on the other side of the world, how do you see that sovereignty thing coming up? Because with resiliency, there's also that part where, region is failing, where are we going? Can we do this? And this is bringing us back, we mentioned it a couple of times, regular compliance and on all these things, but the sovereignty thing is something which is hot topic nowadays. How do you see that? And how do you, like for instance, your customers see that? Or how do you see it yourself? And what are the things that you can do or that you're doing today to make it more tangible and more production ready, for instance?
Right. Yeah, I think that it first of all understands with understanding the level of sovereignty you and your organization actually needs.
Yeah.
And then trying to explain what Azure can do in that part. If you want, some organizations say, we need full sovereignty. That is something you can't do on the Azure cloud, because there's digital sovereignty, there's data sovereignty, there's operational sovereignty, and some of that you can do to quite an extent, but some of that you simply can't do because the hypervisor is there, and you're not going to patch that, right? So operational sovereignty isn't going to be your thing, that's Microsoft. So you need to find the level that you need, and then find the level that you can actually do on the Azure cloud. And it for sure is a very, very hot topic these days. I recently wrote an article on this very topic, so I dig into it. And I wasn't quite aware of all the regulations around it, because that's where it actually starts, right? With the Cloud Act, the Patriot Act, and then also what do we do in Europe, GDPR, people thinking that GDPR can actually protect us from the Cloud Act, which is not the case. So it starts with understanding all those things involved, and then we get to sort of talk about technology and how do we actually then maybe run it on Azure in the most sovereign way that we want to. But there's always a balance, because you can, for example, go to confidential compute to get a pretty high degree of sovereignty on the Azure cloud, but also comes at a cost, not just money, but also a limitation in the services you can use, for example. So it starts with understanding what is actually sovereignty and what do you as an organization need to achieve.
Yeah, as you say, there's a lot of acts around that. Now we also get that AI Act coming up in Europe and all these things. So that's something that you need to keep in mind. What's your vision on it as United States citizens?
Well, first of all, I'm not a United States citizen, right?
Well, living there at least.
I think that it's been, and first of all, this is not my expertise at all, right? So I see that a little bit from outside, so maybe it's a little bit different viewpoint. But I found very interesting to see how American companies have to worry about GDPR now because they want to sell stuff in Europe, right?
Yes.
And so I thought it was really interesting. And I'm kind of wondering, and I know we said we wouldn't talk about AI after the introduction, but nonetheless, sorry, this is like the secret that we discussed before. Nonetheless, I'm kind of curious about how that's going to play out with AI, because AI is such a wild west in the US right now. And in Europe, they are trying to do, you know, to have some legislation and stuff like that. And I'm very curious to see if that's going to be the same effect, essentially, where US companies are going to be kind of forced to adopt certain compliance and sovereignty and things like that, certain rules to just be able to sell in Europe, right?
Yeah.
So yeah, this is the kind of thing that interests me, but again, I'm not an expert in that, yeah.
So I actually helped some customers with this, and like just inside Microsoft, we stopped logging IP addresses for like App Insights for a long time ago to comply with GDPR.
Yeah,
and
that's something that you could have already masked in the past. For
like
yourself,
internally we were like, GDPR, we're a global company, here's things we have to do. But like when I'm helping customers, it's, okay, cool, you want backups. Are your backups, do they have to be stored in your country? Are they allowed to go to another region? Like that's a basic question. And that is a compliance thing that their legal department needs to answer for us. It's not my job to make sure you don't get sued. Like you need to know what you're allowed to do. I can tell you if you can do it or not, but you need to tell me what you need for compliance.
Yes,
like I am not a lawyer. But I've worked with some customers where it's like, we want a stamp architecture, and we'll have a stamp in the US, and we'll have a stamp in the UK, and we'll have a stamp in the EU, and we'll do maybe eventually consistent on non-customer facing records, but we'll have operational records flow. Like, or we'll do like compute environments or class, like
or anonymization or things like
yeah,
that.
so there's different techniques and patterns that we can apply, but we need to know what they need. So if it's, we'll have operational data that's not tied to any customer flowing across the backbone, but we'll keep all of the like shards of customer information tied to their data. Like there's ways to do it. And how do we do auth? Well, we'll have to do auth a different way because then we have user information. And these are the conversations I've had. But that was because I was helping people build and I was consulting on Azure. But even, let's do Azure DevOps or GitHub. If you set up a GitHub Enterprise instance or you set up an Azure DevOps, it's like, where's my region I want to keep my code? Right. There is information out there on like AKMS, like Trust Center, that you can go look at compliance reviews, you can go look at regulatory reviews, like where your data is stored, how you can get it, how you can request it, how you can delete it. Like this is all super transparent from the big company Microsoft. Now, other companies as they build have to come up with these problems themselves or have consultants help them or consultants help them.
That's that's a given. Yeah, and even it's not only for a single platform; it's also the subservices, for instance. But Copilot was a long time not in Europe possible to keep your data there. It's all these things, right? So this is something that you need to keep in mind of the platform itself.
And this is why we say use Azure OpenAI and not use OpenAI directly, because it's like, by the way, when you make that request out to whatever with an arbitrary key, you leave the Microsoft backbone and go over the public internet, and we can't guarantee your sovereignty. If you're using a private network with an Azure service to an Azure thing, we can, it's staying in the network, staying on the backbone, staying in the data center.
And this is something that leads up to my next set of questions. This is where something like multi-cloud also will become a harder part to do, because if you're leaving, let's say, for instance, using Cloudflare in front of Azure, and then you're also using AWS, how you cope with these things, right? I don't know whether you ever came into that kind of a situation.
Now you have to do point-to-site or site-to-site VPNs, set up over one, or use like an MPLS or some sort of data VPN through the actual network providers.
For instance.
There's different options, but they're all expensive and they add up because you're paying for egress from both directions.
Microsoft did with OCI, like the Oracle thing. I know it's ugly to say it at a Microsoft-focused conference, but you know, Oracle did the same thing. There's a collaboration between OCI and Azure, and even running Azure inside of Oracle inside of Azure, stuff like that. So But when we're talking about real multi-cloud, let's say we talked about resiliency. Let's take the resiliency of a multi-cloud thing. How do you see that? Did you ever come across that with customers, and how do you approach that thing?
No, I'm for all the clients I've done so far, it's mostly a hybrid scenario, as in on-premise data centers and then to an extent the Azure cloud. What I do find interesting is that I talked this morning about various infrastructure as code tools up onto infrastructure from code. And what you do see in that field is that some of those tools try to fix the multi-cloud issue that we just discussed around Terraform. I mean, Terraform can do multi-cloud, but it's not like a switch of a button and you are on AWS instead of Azure, right?
Yeah.
You need to rewrite the whole Terraform code base you've built. It's very specific to particular cloud. Some people don't know that. But what you see is that, for example, I think Radius is a nice example on a tool originally came out of Microsoft, now open source, that actually found a way to build a model that, from an application perspective, nicely hooks into the multi-cloud scenario and lets you define your application requirements at one place and then the actual implementation for the specific cloud in another, which allows you to, well, sort of deploy on both. But then there's always, of course, the connection between the two. How do you, if you want to do active-active or active-passive, and how do you actually switch, and how does the data actually switch? And I mean, building the infrastructure on both clouds is sort of the easy part. Then running it on two, I don't think that's doable for a lot of
And
clients.
not to mention the monitoring and the telemetry and all that stuff.
So Microsoft recommends in the cloud adoption framework, which is something that we usually help people that are looking at these multi-cloud type solutions. It's also in the well-architected framework, that when you're trying to do a multi-cloud solution, you need a primary cloud. You need one that's going to be your main ingress and egress and all that, and the secondary one is usually for fallover or like passive or something. Like you can't have them both equal. Like, where does www.mymulticloudapplication.com point? You can't point it both easily. Like you're going to point at something, and then it's going to route traffic, and then maybe use a traffic manager or something to flip it. But like, or Cloudflare or a global service. But at the end of the day, it points to an IP, and
that needs to go somewhere.
It needs to go somewhere. Another thing that I've been thinking about is like with Pulumi and some of the others. Now Aspire has that. Like you're building an application model and you generate infrastructure and deployments, and you can have Azure, you can have AWS. Like you could they now have, I've seen the approach of, we're just going to do Kubernetes for everything. We're going to be agnostic in our infrastructure by being Kubernetes on everything. We're going to use Rook, we're going to use, like, we're just going to, actually, let's just build out our own clusters too. We're going to use VMs and Rancher to build our Kubernetes cluster, to layer on our platform engine.
And then add hybrid to that, and then the PC, which is after the bus desk, right? Yeah,
and then we're going to do the whole like fleet with clusters across clouds. So complex.
What?
No, just don't.
It's funny. You mentioned Radius. You mentioned Aspire. Are you going to mention Dapper now? Because that will confuse the people at home mostly.
I most certainly won't.
Hey, Radius is 2 years old. Rasinovich just celebrated its 2-year anniversary.
Something like that. It's actually older.
Well, I thought that we just had the 2-year anniversary of it.
Or let me.
That's like last week. This week, yeah.
It was like this week or last week.
Yeah, but internally we had it way longer, because I remember when I onboarded at Microsoft like 8 years ago, somewhere in the middle, during COVID, I saw that popping up, and that was at least in 2021, but it was internally that we were doing that. So it's really, really cool to see how that evolved. And it's funny that everybody wants their own piece of the cake of multi-cloud and taking away the burden of infrastructure. Sorry, man, you're almost out of a job. Time to move on. No. Kidding there. Yeah. But and then you take into programming and development paradigms like Dapper, and also open application models and all these things into how do you see the world changing towards that now that we have these things in a more general available way? Do you think people are now more confused when they want to build for cloud solutions, or do you think it might make it easier on them?
I mean,
keeping into consideration that people are still like digesting the cloud transformation part.
I mean, it's certainly. I mean, unlike those two experts, I'm really a developer. I came to the cloud. I was hired by Microsoft. I had no idea about cloud, right? And then they told me, well, you'll learn it, and then you'll be a developer.
Yeah, you were Mrs. Samuel, right? I mean.
Yeah, exactly. So I was a client application developer when I joined. But nonetheless, the one thing for sure is that the role of the developer has changed tremendously. And now we have to kind of understand what they are talking about, right? So, I mean, nonetheless, right, there's also a lot of hype, right? I mean, AKS, I'm still going to pretend, and this has been my strong opinion from the start, that 98% of the people don't need it, because you can do containers without AKS, right?
Yeah,
and
true.
now we have Azure Container Apps and everything, which is kind of hiding the complexity, so this is great. And I mean, you can still just deploy to a dumb old app service and it works, right? So there is that level of complexity which is caused by hype, because everybody wants to adopt, the latest and greatest, and this is one thing. But nonetheless, right, even if you just consider even the most simple architectures that you still have some stuff that I never used to worry about. Infrastructure as code, or CI/CD. This is all stuff that we had to kind of learn, because if you want to use those environments to deploy your code, very often that's the only way, or that's really the best way, right? So it's probably a good thing, to be honest, because it forced us to think about things like as developers that we didn't really think about. Because I had an infrastructure team that was worrying about these things. My job was, to provide stuff that built and that did what it was supposed to do. And after that, my job was done, right? But now I'm also deploying. I'm also, doing things. So yeah, it is probably confusing sometimes. But I mean, if there is one thing true when you're an engineer, is that you keep learning, right? And so I take that, C#, okay, we've been doing C# for 20 years now.
Yep.
Okay, I can say, well, I'm probably an expert at C#, but now I need to learn new things, and that's very healthy, I think.
Yeah, cool. Your opinion on this?
Yeah, I totally agree. When you were talking about AKS, and then the thing that I thought was, I think containers have become the standard deployment model, right, for applications. But if you only look at Azure, there's quite a few choices to make and sort of paths to follow when you want to decide, all right, so what container service am I actually going to use on Azure to actually host this thing? I mean, there's AKS, container apps, web app, container instance. I think there's 5, 6, 7 flavors that you can actually run a container. And I think those kind of things, it's good that we have choice. And the same happens in the space of Dapper, Radius, Aspire. There's a bit of overlap, but there's also difference between the things. It sort of used to be easy in the past, as in you would just sort of get a VM, deploy your application, IaaS done. So all the choice is very cool, but it's also very complex because you need to actually make the choice, and it's quite hard to do these days, I think.
Yeah, to that point, there's multiple flowcharts out there for decision trees on do I need access to an API? Do I need to host this? Do I need to scale? I think what we're seeing, though, is the tooling is helping remove choice. So to just optimize it for the right experience for what you need to get started. So let's say I start a new project in Aspire, and then I build a pipeline, Aspire Publish. It's going to host my containers in ACA. It's going to wire that up for me. ACA, I don't have to worry about it. If I'm using AZD, and I do an AZD init, and I set up a project, it's going to build bicep and infrastructure, host it in container apps for me as well, or Azure Functions if I need to. If I'm building infrastructure as code, there's stuff like Trivy and all sorts of tooling out there that looks for insecure defaults that try to help correct us. The tools go, hey, you made a public storage account. You don't want to do that. Hey, you left this unsecure. You don't want to do that. And it'll detect it and tell you, don't do that. The cloud advisor will tell you, hey, don't do that. So like, we need to be security experts so that we don't get hacked and we don't lose, have our data breached in some way. We need to be performance experts if we want to scale. And so that's where we're starting to build these recommendations, these identifications of poor patterns, poor configurations into play, but it still needs strong architecture. We need to understand architecture is trade-off, and we get some saving grace in our like application code. If we use the SDKs, it uses the right security patterns. It does exponential backoff. It does retry. It does circuit breaker. But did we put the boxes and arrows in the right places, or are we like screwed from the beginning, and we have to go back and re-architect the whole thing because we did it wrong?
So from an architecture point of view, and this is an evolution over the last 60 years. Think about Alan Turing, think about all the things we did in compute. Aren't we over-complexifying things for most of the applications and most of the solutions that we're building? Because hey, you mentioned a lot of tooling and all the choices that we're making. Don't you think that we, from a point of view of the richness of choice, that we are putting ourselves into a risk to over-complexify solution building and making it unmanageable? And that's just an honest opinion. It has nothing to do with technology or whatever.
There's always a risk, right, for sure. But I think this is really where you differentiate between the engineers and I mean, you know, there's always a debate, right? Are you an engineer or a computer scientist, right? But I think at some point we need engineers to understand these kind of things, right? Because the role of the engineer is really to architect things and to build stuff, and maybe the role of the computer scientist is a little bit different, right? So this kind of duality is very necessary, and I'm happy that we have it. But definitely the engineers are needed for that, because that's the way that we are trained to think as an engineer, right? I mean, I came to software through electrical engineering, so I'm an electrical engineer first. And when you learn electrical engineering, same thing, right? I mean, okay, I can build some super complex things, and then when I plug it in, it's going to blow up or something, and that's not what you want.
That's where the fun is, right?
Yeah, exactly. So yes, there is a risk. But that being said, I want to point out that, I mean, I started coding in '95, more or less, right? So I came to coding relatively late, but nonetheless, I've been doing that for 30 years. It's so much easier now. It used to be really hard. I mean, when you wanted to have a machine talk to another machine,
true.
You had stuff like Corba. Do you remember Corba?
Oh yeah, I do. I do.
Okay, now I gave nightmare to everybody, right?
Too young.
Yeah, no, you're too young.
You're
Yeah,
a hipster.
You don't know how lucky you are, man.
Common
tell you.
object request broker.
Because
Corba.
it was so
bad.
complicated,
Yes,
right?
true.
You had stuff like DCOM when you wanted
thought
to
SOAP
build,
was bad?
you know, a
Transaction
distributed
server.
application. Exactly.
Oh, beautiful.
And so I'm always amazed nowadays that I can do file new project, and literally within minutes I can have an application which
true.
I can, and I'm not even talking about GitHub Copilot, right? Which is, by the way, my session tomorrow. I'm talking even just like I know how to code. I can do file new project. I can build something. I can deploy it to Azure, and literally 10 minutes later I have something which has been deployed, right? That is amazing, and I feel that yes, we overcomplexify sometimes. But let's not forget, you know, that back then it was way more complicated.
That's true.
I mean, and to add to this, I think a lot of our architectures in a lot of organizations are accidental. Like if you're not making, choices. Like if you're not choosing between this, like we're doing this thing to reduce cost. We're doing this thing to improve reliability or security. We're doing this thing to make sure that we get the right performance out of it.
Yeah.
If you're not making these choices intentionally and you're just going, next, default, you have an accidental architecture that's terrible, because architecture is about trade-off. And I've seen many, many, many people I've worked with in the past that read a book from an expert and said, this is the way to do it. Thou shalt do this. And so they draw the boxes, they draw the arrows, they submit it, say, go code it, and then about a year they leave, and they never see the pain, and they never learn.
Yeah, I do have a word on that.
There's no
accidental architecture, Microsoft Access.
but the boxes and arrows, and then they leave
still
and
there.
they don't
It's
learn.
still there.
I remember one time I was doing a cloud transformation and moving into a modern data center topic thing. And there was this one application that was running, and they were pushing everything into SAP, and all of a sudden they realized that there was one Excel file that was pushing the entire organization. And if that failed, that's also a simplification, but afterwards, over-architecturing because you probably think, why the hell did they pull this thing in? But
Yeah.
there's a
Oh, yeah.
reason for it.
It's because how we always did it. We always did it this way.
How much of this old code is still running?
Yeah,
and
yeah, yeah.
basically, like, you know, I mean, there is a very good video circulating these days about the whole Log4net, Log4j issue bags. But, you know, I had a couple of years ago, I was giving a presentation about migration, right? Migration to Azure. And I have this gentleman who comes to me and says, he was in a Middle Eastern country, not necessarily want to name it, but, you know, and came to me and said, hey, so I have this, you know, this ASP code that I'm running, and I'm like, oh yeah, ASP.NET, no problem. And he's like, no, ASP, not ASP.NET, right? And I swear I hadn't heard talk about ASP for like 15 years at least, right? But it's still running.
It's still running,
and
yeah.
that's the thing. And his application is still running, right?
Yeah.
And I mean, look at how much COBOL is still running, the
true,
finance and our airplanes and everything, right? So yeah, this this topic about migration and modernization, it's really important. It's really good to think about, but it doesn't change that the system that works. It works.
It
right?
works, yeah.
And if you start touching it, then it's not going to work anymore, right?
So it's a good segue into a next topic actually, because that's a topic that I didn't think of. Also with transformation, modernize, rewrite, or move on.
Yeah, that's a very good discussion to have. Yeah.
It depends.
Thank you.
I was
thank
waiting
you.
for that.
I
I was waiting for that.
one.
So I used to sell this too, and like Microsoft had the 5 Rs. I think AWS has the 6 Rs.
yeah. I
There's
think
like some number of Rs about replace or retire or rewrite or
If I'm not mistaken,
re-architect,
Barbara Forbes has a very
rehost.
good session on that. You should watch that one. But yeah, but what's your opinion on that? If you, of course, it depends. But if you can choose, what would you do? If you can choose, you got all the time in the world, all the budget in the world. What would you do? Just okay, it works. Just move on and just put it, rehost it.
What happens after is the first question.
That's the first question, yeah.
So is it we need to have new capabilities that are not available on-prem? Do we need to have capabilities that don't exist in the code today that we need to add and that we can add easily without having to rewrite it, re-architect it, you know, all of that? Like, so we could lift and shift it up and just let it run and not worry about it, and it's fine, cool. But if we spend X amount of dollars to optimize it, will we get savings in efficiency or in future development and capability? Like, this is that matrix of what are the drivers for the move or the migration? What is the budget that you have? What's the expected like runtime in its current form, runtime in the different like rehost, re-architect, you know, rewrite forms? What are you trying to get out of it?
Yeah.
Yeah, and how long can you afford to have a system that's not going to work, right?
Very important.
Well,
because that system is not going to work as good as the old one. So you need the old one. You need, you know, you need 2 teams, right? You need one team which maintains the old one because otherwise your business is dead, and you need one completely different team which is building the new stuff, right? It's not easy.
And if you just rehost, we all know that as soon as you just lift and shift it up, your costs actually go up.
Yes.
And so a lot of teams try to do the re-architect where they, instead of just lifting up, they try to go at an angle and like, we're going to tweak some stuff. Strangler fig pattern. We'll just replace some bits. We'll put a facade over the UI and then like keep the cores, the old thing. Like, what can we strip out and keep it usable? There's too many choices, and it really depends per org and per outcome you're trying to achieve.
You any other additional?
Well, I think you actually started your question with if you have unlimited budget, unlimited time, then you would probably rewrite the whole thing because that's fun, right? But yeah, so that's.
Should you?
Apart from well, no. If you have unlimited time and budget, then why not, right? But that's never gonna happen anyway. So for the rest of it, I totally agree with what you guys said. I think it depends, and I've actually been in such a migration where we, and it's actually a lot of work, not to be underestimated, to actually figure out per application what is the best path forward for this particular application. It's actually a lot of work. It takes a lot of time.
Yeah. Luckily, we have nowadays these patterns around these things. We have modern web applications and reliable web applications, RDA patterns and practices, like the old patterns and practices we used to have. mission critical is there. So we
Well, there's tooling now too.
there's
They-
tooling,
like you
yeah.
can ask AI to help like do it. You can ask AppCat, and now like and like you said, there's the patterns, the reliable web app pattern, the modern
12 factor
application.
success apps and all these things. And sometimes you just don't even need that anymore because with all the new things that we're having today, take any JavaScript, take any, I know JavaScript is an ugly thing, but yeah, a lot of people for some reason hate it. I don't know why. No, but take any JavaScript framework, take any version of .NET, there's lots of evolution in that. There's interactions immediately with services into the cloud. You take away some of the hey, sometimes you can even just host a static file with just some serverless functions underneath it. Simplify the solution as such. Yeah, those are nice insights that you're giving here. That's a good thing. Maybe for the last set of mumblings and things, if you were to, I'm going to ask you 2 more questions. One thing, if there was any service that you want to see today on Azure that you think we should have something like this, it can be anything, right? Up to a pancake maker till something which is non-existing today or that a competition cloud has, what would it be? And the other one is, give me your most favorite Azure function or service, or it can be something hidden, it can be something niche, or something that you think doesn't get enough attention. I mean, I did a show a couple of years ago, 2 years ago back with a colleague of mine called the Azure Unsung Heroes of the Cloud, where we picked out things that people typically didn't talk about because they didn't know about it. It's these little things, right?
Yeah.
Do you have any of those? So let's first go with the first question that I asked you. So the one on the what kind of service is missing, and then your favorite one. So I'll start with you, and I'll just go to the end of the line.
I actually need to think about that first question.
Oh, you want me to pass it on, and you want to think about it?
Nothing pops to mind right
Okay.
now. So yeah.
The question I always get from people is, how can I take my deployed resource group and export it? Like, I've heard it, like, export to Aspire. I mean, I know I could just go and click a button and get an ARM template out. We had, like, AZ Terrify to, like, extract it into Terraform. But that has always been kind of meh. It's never been that good.
Unreadable.
Yeah, it's been meh. It's not been that good. And so, like, there's a resource mover service, but, like, I don't know. Like, the backup of the infrastructure and all the settings has not been, like, the perfect thing ever. And I think that could be improved.
So this is something that might pop up because of, you know, Copilots and all these
I mean,
things, right?
maybe, yeah, but
Yeah.
anyways, it is a hard question because, like, new services sometimes fundamentally shift how we think about software or how we consume cloud. And, like, I remember finding 1 years ago, there was a logic app to drive an AS400. So you could do like a logic app into a mainframe and like drive the screens on the mainframe. So it's like, you don't have to move the mainframe up. We'll just like connect it with a logic app.
Host integration server, these kind of things, right?
Yeah. So like, I'm not sure about a missing service, but that's one that's a pain point for me that has never been done just right, but it's still kind of a pain point.
Something that you think of, Laurent?
So the missing thing, I mean, it's not really a service, but like if ever I stop coding, it will be because of authentication. Because I hate authentication with a passion, right?
You don't love Entra ID?
Anything that has to do, when I have to write authentication code, it will fail. Like I'm bad at authentication. Like it's not so much that I hate it, is that it hates me, right? But that being said, I found a great workaround, which is for most stuff.
Don't do it?
Who are you again?
For most stuff, because you need authentication, right? Just to be clear for the audience.
Admin password.
Yes. That being said, a great workaround is to use, I use Logic App for anything that needs authentication. So if I need to send a message to Teams, for example, right? I'm in the process of creating a lot of content with a whole team of people. I need to send Teams messages to each one of them. What I have is that I have code, right? I have an Azure function, etc. But when it needs to send the message to Teams, it calls a logic app, which does the work because I can authenticate super easily in logic app. And I wish, and I know it's not possible, but I wish, we can wish whatever we want, right? You said. I wish there was a way to do that with, with code, right?
Yeah.
That I could just say, I don't want to worry about it. I want to go into my Azure function. I want to log in into Teams. And then you remember that, and I don't need to do that in code. That would be really cool. So that's for me like the main missing thing which comes to mind. And if I may continue on the other question, which was the which is my favorite service. So I have a lot of favorite services. I would say Logic App, Azure Functions, and storage. Right, those are the three that I always use. But I want to mention, because everybody always forgets it, Azure Data Tables.
Ah, yeah.
It's so simple. It's so beautiful. It solves 99% of your data. I don't know, I'm just making things up here. It solves really a lot of problems, right? It's a NoSQL database, which is running in Azure storage, so it doesn't cost much. I was going to say it doesn't cost anything. No, it does cost, but not much.
Yeah.
Super easy to use. It has some great connectors to Logic App or to functions or whatever.
Event grid.
And yeah, and I feel that before you start worrying too much about your data stuff, that's a great place to start. And then after that, you can always build from there. So that's kind of my
and
favorite.
Of course, it can scale afterwards because if it doesn't, like partitioning or all these things, you can just move on to the next.
To Cosmos DB,
Cosmos?
for example, or something else. Yeah.
I hear you. You've figured out already what you want really in Azure that isn't there yet?
No, not really, no. I'm gonna keep thinking. I have still 8 minutes, right? Yeah.
Okay, then maybe answer the other question then.
Right. Yeah. So what I think is a very nice, quite recent addition is the notion of service groups. We already used to have these grouping mechanisms in Azure, right? Resource groups, subscription management groups, and the whole layering structure in there. But it wasn't really a way to sort of combine and group resources across those things. So sometimes a workload consists of multiple applications that might be created and hosted by multiple teams, and therefore might live in different subscriptions, but they do have a relationship with each other. And in terms of resilience, for example, you might want to see the relation between the things, and if this thing goes down, then there's a direct impact on the thing over there. Yeah, and that is a thing, it's not completely out there yet, but that's a thing that Service Group is probably gonna fix for us to quite an extent. So I think that's actually one that's quite nice.
Oh, okay.
You almost stole mine, because no, service groups are so good.
Yes.
They really are. I think ACS is an interesting one. That I don't.
Which one?
Azure Communication Services.
Okay.
I don't think you could do some really interesting things to connect calls and teams and do some interactive apps tied into AI. Do some interesting agent work with that. I would say another one is the network boundaries. The network perimeter.
Yeah.
That is something that is newer. That is really, I think, going to revamp how we do some of the network rules, and we can define perimeters a lot easier and secure our applications more effectively.
That's a nice one. Yeah, it's a very recent one. It has some additional value to everybody who wants to simplify things, actually.
It simplifies things, but it also is more powerful in some ways.
Okay, still nothing?
No, still blank. Still blank.
Okay.
Could I have a beer as a service? That would be a nice, wherever you are, you can use.
I think that would be another cloud that would provide that. It's called an Amazon Dash or something, right? As beer as service. It's actually a good one because that would bring us to more closer to things like the Azure user group we have in Belgium with Cloudbrew, for instance. Just to give you an idea. Not stealing the thunder of Techorama. Still a better conference, but it's a thing. No, I think we're good on the questions here, and I hope you guys had fun.
Yeah,
I mean, at least I did.
Yeah.
Seeing. Oh, maybe one more. Is there one service that you regret that disappeared?
That we what?
That you regret that disappeared?
I think that sort of every service that disappeared sort of got replaced by something better. So I don't think I'm actually missing anything.
Some are just rebrands. Like, I mean, the IoT service went away, and now we have IoT like operations that's replaced it, which is like IoT v2. Like form recognizer went away because it became document intelligence. It's just kind of like a rebrand on that one.
Cognitive services were fun, but now they're all like
AI Foundry.
AI, right? Yeah.
AI Foundry.
Etc. Etc.
Yeah. Well, I mean, like there's SDKs that are going away and merging.
Yeah.
Like AutoGen and Semantic Kernel are going away into
Agent
Framework,
yeah.
and that's tied to AI Foundry, and yeah.
Yeah. Okay, but nothing that you're missing from the past, or that does, like media services or something like that.
I definitely remember back in the day, cloud worker roles and web worker like the original ASM stuff, and I'm fine that it's gone.
I don't miss them.
I'm fine it's gone. It's okay that it's gone.
Okay, with that last question and on that bombshell, I really want to thank you for the pleasant discussion that we had. I hope I didn't like burn you too much with my harsh questions or my.
Let's see if we still have a job.
No, I think you will. I mean, it's your honest opinion, but also the things that you've seen across the industry and seen across with everybody is actually doing cloud and the pain that they live through. And with that, I want to thank the audience for watching Techorama TV. Thank you for being and watching us live at Techorama. I hope you enjoyed the rest of Techorama TV and hope to see you somewhere in the next season. All right. Bye-bye. Thank you.
My opinions are my own.
Well, this was Techorama TV for day one. What do you think, Mike?
Well, I think everybody enjoyed themselves, right?
I hope so. I hope so. Well,
Did you have fun?
I had a lot of fun. I had a lot of fun getting all the speakers here, especially for these sessions. So we'll do it again tomorrow.
All right, cool, very cool. So I hope everybody then still stay tuned in, right? And of course they can watch it afterwards, but there's nothing as much fun as watching it live, right?
I agree. So these sessions will be available afterwards, but please join us live tomorrow again for day 2.
At what time?
At Techorama.tv.
Yeah, at what time? At what time?
The first session starts at 8:30.
Oh, okay.
First session at 8:30, and you can meet those makers. So the people behind Techorama tomorrow in the afternoon as well, after lunch. So please join us again live tomorrow.
So stay tuned and watch and tune into this channel again tomorrow at
same channel. A little bit earlier, different people, but tune in live.
Okay.
And thank you so much for watching.
Okay. Good night.
Bye-bye.